Hi folks, welcome to the Modern JavaScript Fundamentals course here on Tuts Plus. My name is Dan Wellman, and in this course we're going to learn all of the essential concepts of JavaScript. Yep, all of them. After the introductory first section, we'll take a look at some of the fundamental concepts of the language, like how variables are declared and assigned, and the different data types and operators in the second section. In section 3 we'll focus on data structures and look at arrays, objects, maps and sets. In section 4 we'll see how we can control program execution and take a look at the conditional logic involving if, switch and ternary statements. We'll also cover loops and iterators here. Section 5 will see us move on to some more practical aspects of JavaScript, like how to work with the different types of data and some of the built-in APIs like JSON and math. We'll also see how to work with dates and times. Functions are one of the most used parts of the language, as well as one of the most useful, so section 6 will focus entirely on them. We'll look at some essential function concepts like scope, closures, prototypes, and the this keyword, and we'll see how to work with different types of functions, including arrow functions and generator functions. In section 7 we'll look at a collection of different but widely used features of the language, like AJAX, promises, destructuring assignment, regular expressions, and classes. Section 8 will focus exclusively on working with the DOM, and the final section, section 9, will look at some of the more common web APIs, like the Selector API, Geolocation, web storage, and web workers. Don't worry if you've never written a single line of JavaScript before. By the end of the course you'll be able to work with the language to leverage its strengths and steer clear of its weaknesses. And don't worry if you don't know any other programming languages at all. All concepts required to understand JavaScript will be explained in full. We've got a lot of material to get through, so let's move on to the next lesson and get set up ready for the coding examples. In this lesson we're going to get a basic development area set up, ready to work through the various coding examples that I'll be showing you throughout the course. During the course we'll be using a variety of JavaScript versions. It will be a mixture of mostly ES5 and ES 2015, but we'll also include some newer features such as ES modules. ES 2015 is now largely supported in most modern mainstream browsers, but ES modules do not have as much support yet. For this reason, it's still best to use a transpiler to convert the latest JavaScript into a previous version of JavaScript that will be understood by a wider number of browsers. For this course, I've chosen to use System.js with the Babel plugin because it's extremely simple to set up and requires very little configuration. The repository for this course is set up to use System.js out of the box, and while we won't need it till later in the course, we can go ahead and clone the repository at this point. You'll need to have the latest stable version of Node.js installed, as well as the Git version control system. So if you don't have these already, head on over to nodejs.org and git-scm.com and follow the installation instructions for your platform. So to start with then, we can clone the repository, which we can do on the command line. You can get the URL of the repository from GitHub. Once the clone is complete, which basically just means that the repository has been copied from GitHub down to your local computer, we will then need to run npm install to install the project's dependencies. npm is the package manager for Node.js and allows us to install many useful packages for JavaScript development. Once this command is finished, everything should be ready to use. Let's just take a quick look at what you'll get in the project directory once you've cloned the repository. There are a couple of files there for Git, the git ignore, license and readme.md files, and there are some npm files as well, the package.json and the package-lock.json files. We can ignore these. They aren't related to the course material at all and just contain meta information for Git and npm. There is a config.js file which contains a small amount of configuration for System.js. We won't need to make any changes to this throughout the course, and again, this can largely be ignored. There is also a very basic HTML file called index.html. This file loads system.js and the configuration file and tells system.js to load a file called index.js. This index.js file is our playground and is where I'll be adding most of the different examples that we'll work on. There is another branch in the repository which contains individual files for each of the different lessons throughout the course, just to separate out the various coding examples that we're going to be looking at. These are in a branch called completed-course, and you can look at these at your own leisure. Let's just open up the index.js file. It should contain just the useStrict directive and a console.log statement. We'll be looking at strict mode in more detail later in the course. The console.log statement just writes a message to the browser's console, but it can be very useful for debugging purposes, and we'll be seeing it a lot throughout the course. As well as system.js, the project also uses a tool called BrowserSync, which allows us to run a local web server, and again this is very useful for development purposes and is a very common practice in JavaScript development. We can run BrowserSync by running the command npm run serve from the command line. We'll first need to move into the directory that we've just cloned. We can then use BrowserSync by running the npm run serve command. So this command should open up your default browser and load the index.html file from the repository in the browser. And I'm just going to open up the console now. And in the console there you can see the working message that came from the console.log statement back in the index.js file. One feature of BrowserSync is that it automatically watches our files and refreshes the browser whenever we save a file. So if we go back to the index.js file now, and let's just change the console.log statement. When we go back to the browser, we should find that it has refreshed itself automatically and updated the log message. Great, so this is all the setup that we need to do right now. Let's move on and start learning JavaScript in section 2. In this lesson, we're going to start with one of the most fundamental concepts of JavaScript, variables. A variable is a named container for a value. Once we've declared a variable, we can then use the name or identifier of the variable in other places in our code to access the value that it holds. In JavaScript, there are 3 different ways to declare variables: the var keyword, the let keyword, and the const keyword. Let's look at each of them in turn, starting with var. To declare a variable with the var keyword, we just need to provide a name for the variable. So this statement creates an empty variable with the identifier foo. In this case, the variable is only declared. It is not initialized or assigned a value, so it is automatically given the special value undefined. We'll look at undefined in more detail in the next lesson. There are some rules around the characters that we can use for a variable name in JavaScript. Technically, we can use any Unicode character in an identifier, but the variable name must start with either an underscore, the $, or a letter. Numbers can also be used in variable names, but not right at the start. Space characters cannot be used at all. If we need to declare multiple variables, we can use a single var statement with different variables separated by commas. In this case, 3 variables are created with the identifiers foo, bar, and baz. As well as declaring a variable, we can at the same time initialize it by giving it a value. In this case, we assign the value 42 to foo using the assignment operator, which is the equal sign. 42 is a number, but notice that we didn't need to tell JavaScript that the variable would contain a number. We just assigned it. JavaScript is known as a weakly or dynamically typed language. What this means is that unlike many other programming languages, when a variable is declared in JavaScript, we don't have to specify what type of value it will store. This is great because it means that any variable can hold any type of data. We can store one type of data, say a string, and then later on we can overwrite the string value with a number, for example. The downside to this is that sometimes we don't know for sure what type of data a variable is holding, so we'll often need to check before trying to do something with the value. If we want to overwrite the foo variable later on, we can just assign a new value to it. This time we don't need to use the var keyword. One thing to watch out for with the var keyword is that it can create variables in the global scope. JavaScript has three different scopes: global scope, function scope, and block scope, and we'll be looking at scope in much detail later in the course. If a variable is defined in the global scope, it can be accessed by any other JavaScript that is loaded onto the page, even within other separate JavaScript files. This can be useful in the case of libraries or frameworks, but it can also be dangerous because if other code can access it, other code can also change it, and this can make your program break in ways that are extremely hard to debug. Global scope should be avoided wherever possible, which thankfully is most of the time. Function scope means that a variable is only visible within the function it is declared in. When we declare a variable inside a function, the variable only exists in that function's scope and cannot be accessed by code outside of the function. Again, don't worry too much about this for now. We'll come back and look at functions and scope in much more detail soon enough. Block scope means that a variable is only visible within the block it is declared in. A block in JavaScript is generally any number of expressions enclosed within curly braces. Block scope is a common feature of many programming languages, but it has only recently been added to JavaScript in the last few years. So the var keyword that we've looked at so far only works with global or function scopes. If we use the var keyword inside a block, the variable will still be accessible outside of the block. If we want to enable block scope for a variable, we need to declare it using the let keyword. Syntactically, let is very similar to var. It just differs in terms of scope. With let, if we declare a variable inside a block, the variable is only visible inside that block. We haven't covered blocks yet. We will come to that later in the course when we get to section 4. For now, just remember that for block scope, we need to use let. The final way of declaring a variable in JavaScript is with the const keyword. The const keyword is similar to let in that it can make use of block scope, but it has one important difference. The const keyword creates a constant value that cannot be changed through reassignment. So we can't, for example, do something like this. This will actually throw an error because we're trying to reassign the value of Baz to 43, but it was declared using the const keyword. So in this lesson we learned the three different ways that we can declare a variable, the var, let and const keywords, and we saw the differences in behavior between them. We saw that the var keyword only works with global or function scope, but that let and const are able to make use of block scope when used inside a block. In modern JavaScript, it is common to most often use let and const rather than var because of the global scope issues. In the next lesson, we'll learn another fundamental aspect of JavaScript, the different data types that are available. In this lesson, we're going to learn about the different types of data that we can use in JavaScript. The first group of data types, and the most basic, are known as the primitives. These are number, string, boolean, undefined, null, and symbol. A number can be any regular positive or negative integer or decimal within the range that JavaScript is able to handle. We can also express numbers in octal, hexadecimal, and binary formats. To use octal, which is base 8, we prefix the number with a 0 and an O. The O that we use as the second character in an octal can be lowercase or uppercase, it makes no difference. In this case, we specify the octal number 77, which is the same as the regular base 10 number 63. To use a hexadecimal number, which is base 16, we prefix the number with a 0 and an X. Again, the second character, the X, may be uppercase or lowercase. This time we specify the hexadecimal number 0011, which is equal to the base 10 number 17. To use a binary number, which is base 2, we prefix the number with a 0 and a B. Once again, the B may be uppercase or lowercase. In this example, we specify the binary number 1100, and that is equal to the regular base 10 number 12. If we try to use a number outside of JavaScript's supported range, we'll get plus or minus infinity, which is a special type of number. If we try to do something invalid to a number, like divide it by a string or something like that, we'll get the value NaN, or nan, which stands for not a number. This is another special type of number. Interestingly, nothing equals nan, not even itself. JavaScript has a special isNan function that we can use to check if a number is nan. We can perform numerical operations on numbers, as you'd expect, and JavaScript has a range of different math functions that we can make use of. We'll look at this in more detail later in the course. A string is a sequence of characters enclosed within quotes. These quotes can be either single or double quotes or backticks. Single and double quotes are treated exactly the same by JavaScript, but backticks have some additional behavior. Single and double quotes can be nested inside of each other. So if we wanted to use a quote in a string, for example, we would have to do something like this. In this case, we just need to make sure that we match the opening and closing quote marks. If we want a quote mark to be treated like a normal character, instead of the start or end of a string, we can escape it with a backslash. We can't perform numerical operations on strings in the same way that we can with numbers, but we can concatenate or join strings together to form new strings. To do this, we use the plus operator. In this case, the joined variable will contain the single string wait what. The backtick string form was added in ES 2015 and provides several benefits over regular double or single quote strings. We can easily create multi-line strings, for example, using the backtick. When this string is rendered, the line breaks will be preserved, as we can see if we log this to the console. This is much more readable than using new line characters like we used to have to do in JavaScript, which would look something like this. The string still has the line breaks in it when it is rendered, but in the code it is much less readable. So the backtick can be really useful, even in basic scenarios like this. A Boolean has either the value true or false. As well as the literal values true or false, JavaScript also has the notion of truthy or falsy values. A falsy value is any one of the following values: false, the number 0, an empty string, null, undefined, or nan. All other values are truthy. Don't get too hung up on this now. We'll look at the nature of truthiness and falsiness in more detail in section 4. These data types, number, string, and Boolean, are known as the primary data types. The other primitives are sometimes known as special data types. These are undefined, null, and symbol. When we declare a variable but don't assign it a value, it automatically has the value undefined. In some situations, it is treated the same as the null data type, but it is not quite the same. We can set a variable to undefined intentionally if we wish. Null is a data type that is used in place of any regular value like a string or a number. Once a variable has been declared, it cannot be undeclared, but it can have its value set to null. This is where the null data type is most useful. The symbol is the most recent data type to be added to JavaScript. Unlike other primitives, it does not have a constructor function, so we cannot create a symbol using the new keyword. Instead, we use a global function, which looks a bit like a constructor because it is capitalized. Optionally, we can pass a description to the symbol function, but this description is only used for debugging purposes. The symbol data type has a very specific purpose, and that is for use as keys in an object. Because symbols are always unique, we can add a new key to an object using a symbol, and we know for certain that we won't overwrite any existing keys. So symbols are always unique. To illustrate this, let's look at the following example. Now let's take a look in the browser console and see what gets logged. We can see that false has been logged. The two symbols are not equal. Now we've used a special type of operator in this expression, the triple equals sign. We'll come back and look at that in more detail very shortly. For now, just understand when we use the triple equals sign to compare two values, not only must the values be identical, but the types of the value must be identical also. As I said though, we'll come back and look at that in more detail later on. So these are all of the primitives in JavaScript. There are also two different composite types, that is, types that are made up of multiple entities. These types are arrays and objects. An array is a container, like a variable, except that it can hold multiple values. Arrays are not associative arrays in JavaScript. They're like objects, but they have fixed numerical indexes. These indexes are also zero-based, so the first item in an array has the index 0. To create an array literal, we use square brackets containing one or more comma-separated items. In this case, we declare an array that contains 3 items, the number 5, the string something, and the Boolean value true. So we can see already that arrays can be composed of multiple data types. We can also create arrays using the Array Constructor. However, the first form using square brackets, the literal form, is the preferred way of creating arrays in JavaScript, and we'll see why when we come back and look at arrays in more detail in section 3. To access one of the items in an array, we use the name of the array, or the identifier, followed by square brackets containing the index number that we wish to get the value of. For example, to get the first item in the array that we declared first, we would do this. Arrays have a length property which correlates to the number of items in the array. Arrays also have some methods that can be used to operate on the items within the array. Objects are containers for key value pairs of data, like this. Each key value pair is separated by a comma, and within each pair, the key is separated from the value with a colon. There are several different ways that we can access the values held within objects. The first way is to use the name of the key and the name of the object separated by a dot. This format is known as dot notation. We can also use something called bracket notation. In this case, the name of the key that we want to access is specified as a string within square brackets. Objects are very similar conceptually to an array, except that they have indexes based on words instead of numbers. Again, we'll look at objects in much more detail later in the course. So in this lesson we learned about the different data types that we can use in JavaScript. We looked at the primitive types, number, string, boolean, undefined, null, and symbol, and covered the composite data types, array and object. In the next lesson, we'll start looking at the different operators that we have available. In this lesson, we're going to start looking at the operators that JavaScript has. There are many different operators for use in many different situations. We aren't going to cover all of them here, there are simply too many. So we'll focus on some of the most basic ones for now, and come back and look at some more complex ones in the next lesson. Let's make a start with the simple arithmetic operators. We use the plus sign for adding two values together, the minus sign for removing one value from another, the star character for multiplying values, and the forward slash to divide one number by another, just as we would in regular math. Great, so simple math is simple. As we saw in the last lesson, the plus operator has a different meaning when it is used with strings instead of numbers. And in that case, instead of performing addition, it performs concatenation or joining of two strings. So as well as these mathematical operators, we also have the modulus operator, which is used to determine the remainder following a division. In this case, the remainder variable would contain the value 1, because 1 is what is left over when dividing 5 by 2. The modulus is useful for determining if a number is odd or even. Even numbers will always return 0, and odd numbers will always return 1 when used with the modulus operator. There's one more operator that we've used in all of these expressions, and that is the equals or assignment operator. We also saw that when we looked at variables in the first lesson in this section. We can also use increment and decrement operators. These are slightly more complicated than the simple math operators that we've just looked at, in that they can be used in two different modes. There is the postfix mode, where the operator follows the operand, or prefix mode, where the operator appears before the operand. So we've simply declared two variables at this point, one called postfix and one called prefix, and both with the value 5. When we use postfix increment or decrement, the expression returns the value and then increments it. So the increment operator is two plus signs, one directly after the other. And let's just go back and check the browser output in the console. So we can see that the increment operator, which was the first console log, first returns 5, and the variable has then been updated to 6. So in this case, the expression returns a different number than the actual value of the variable that has been incremented. The prefix increment or decrement doesn't suffer from this subtle issue. So if we go back and use prefix instead of postfix by moving the operator to the start of the expression, what do you think the two logs are going to say this time? Well, let's go back to the browser and see. So in this case, we can see that the variable has been incremented before it gets returned. So this time the two expressions return the same value. So this behavior creates a confusion that can lead to off by one errors in some situation. And for this reason, it is advised to avoid using the increment or decrement operators altogether. We can use assignment operators instead. So the increment operator is two plus symbols. If we want to decrement a value instead, in either postfix or prefix mode, we would use a double minus sign. So let's move on now to look at some more assignment examples. So we've already seen that a single equal sign is used to assign a value to a variable. As well as this, we can use addition assignment. So the addition assignment operator is a plus sign followed directly by an equal sign. This is identical to using the increment operator, except that it doesn't create any confusion. We don't have to increment by 1 either. We could just as easily do plus equals 10 to increment the value by 10. Subtraction assignment works in the same way. So for subtraction assignment, we use the minus sign directly followed by the equal sign. We can also do multiplication assignment, division assignment, and modulus assignment in the same way. So the multiplication assignment is the star character directly followed by the equal sign. Division assignment is the / character directly followed by the equal sign, and modulus assignment is the modulus or percent character directly followed by the equal sign. The last set of operators that we're going to look at in this lesson are very important, and we use them a lot. These are the comparison operators, and we had a brief look at these in the last lesson. JavaScript gives us equality comparison and greater or less than comparisons, and the language does have a gotcha here in the form of type coercion. Let's take a quick look at this. So to test if two values are equal, we can either use the equals operator or the strict equals operator. So this is the equals operator, which is two equal signs, one directly following the other. And in this case, the value of 1 is equal to the value of true, because they are both truthy. In this case, type coercion coerces the value of 1, which is truthy, to the Boolean value true. If we'd like to use strict equals instead, we need to use the 3 equals signs which directly follow each other, like this. In this case, the expression evaluates to false, because with strict equals, not only do the values have to be equal, but the types of the values have to be equal as well. The value 1 is a number, and the value true is a Boolean, so those are two different types, and that's why the strict equals operator in this case returns false. We can also test for inequality using a bang instead of the first equals sign. In the first expression, 1 does not equal true. This evaluates to false because of type coercion. But with the second expression, the exclamation mark followed by 2 equal signs, we get the value true because 1 is a number, and that is not the same as a Boolean. No type coercion takes place in that second expression. Different types are converted in different ways depending on the types of the operands being compared, and for this reason it is usually advised to use the strict form of equality or non-equality operators. We can also check if one value is greater than another value. So this expression says 1 is greater than 2, which, as we would probably expect, is false. We could also use greater than or equal. And in this case, the expression is still false. 1 is not greater than or equal to 2. We can also use less than or equal. And in this case, both of the expressions evaluate to true. 1 is less than 2, and 1 is also less than or equal to 2. So in this lesson we looked at some of the more basic JavaScript operators, including the arithmetic operators that we'll generally use for simple math, the assignment operators for assigning values in different ways, and the comparison operators for comparing different values. We also learned that sometimes operators don't behave intuitively, such as the subtle differences between using the increment and decrement operators in prefix mode as opposed to using postfix mode, as well as the type coercion that is sometimes carried out when comparing values. In the next lesson, we'll continue looking at operators, this time looking at some more advanced types of operator. In this lesson we're going to continue looking at operators, but this time move on to some slightly more advanced ones than the ones we looked at in the last lesson. We've a number of them to look at, so let's make a start with the unary operators, which are operators which only have a single operand, rather than two. The delete operator is used to delete an object property. So we've declared a simple object in the variable test, and this object has a single key, which is x, and this key contains the value x in string form. So let's just take a look at this in the browser's console, and we can see that it's logged the string x to the console. So now, before we do the console log, let's use the delete operator to delete the x key. And now if we go back to the browser, we can see that it has now logged the value undefined because x no longer exists in the test object. So the delete operator deletes a property from an object. It only works in this situation. We can't use delete to delete a variable. Another unary operator is typeOf, which we can sometimes use to determine the type of a value. And let's just take a look at the output of that in the browser. And we can see that the type of value that the word variable contains is a string. The typeOf operator works well with primitives, but it does not work quite so well with complex types. Let's just look at another basic example. Before we go back to the browser, just have a little think about what you think the browser console is going to display. Even though we declared an array, the typeOf operator reports that it is an object. Now technically, most things in JavaScript are objects, but because the array is a special type of object, it would be useful if typeOf reported array as being an array instead of an object. However, that's how it works. There are ways that we can use to tell whether the object we're working with is an array or an object, and we'll come back and look at that later in the course. For now, just be aware that typeOf may not report the true type depending on the value that we're using it with. The final unary operator is the void operator. It's more often used in TypeScript than it is in JavaScript, and in fact, it's rarely used these days in JavaScript at all. It used to be used frequently with anchor tags when we didn't want the browser to try to follow the anchor. If we just go to the index.html page briefly, it used to be very common to see anchor tags like this. Whenever somebody clicked that anchor tag, instead of the browser trying to redirect the user to some other resource on the internet, it would instead just do nothing at all. That was the most common use for the void operator in regular JavaScript, but it's not as common these days, so you probably won't ever write that yourself. You might not even come across that in the wild. But it does exist, so it's worth pointing out. Another type of operator in JavaScript is the logical operators. Let's take a look at these, starting with the AND operator. The logical AND operator is two ampersands, one directly after the other. This operator returns true only if both of the operands are true, such as in this case. If either one or both of the operands evaluate to false, it returns false instead. There is also the OR operator, and this is denoted with a double pipe symbol. This time, the OR operator returns true if any of the operands evaluate to true. So in this case, only the last expression returns false because all of the others have at least one true operand. So the OR operator is basically the diametric opposite of the AND operator. The last logical operator is the NOT operator, and this is denoted with an exclamation mark. Another operator is the comma operator, and it is used to include multiple expressions in a place where only one expression is expected. It evaluates each of its operands and returns the value of the last operand. So this expression, in which two variables are declared, both variables would get created and have the specified values assigned to them, but only the last variable would be returned. The comma operator should not be confused with the simple comma separator. So the comma separator is used in a number of places in JavaScript, like if we are declaring an object with multiple keys, like this. So the comma within this object is a separator and not the comma operator. The comma operator is actually very rarely used. You'll most often see the comma used as a separator. The spread operator is the newest operator in JavaScript and is denoted by 3 dots together in a line. In addition to the operators that we've looked at in this and the previous lesson, there is another whole group of operators called bitwise operators. We're not going to look at these here because they are rarely used and they are quite technical in nature. I'd recommend that you wait until you're comfortable with more of the basics of the language. Then, as an exercise in self-improvement, you can look them up and study them at your own leisure. So in this lesson, we looked at some slightly more advanced operators than we looked at in the last lesson. We covered the unary operators, which work only with a single operand, and these are delete, type of, and void, and the logical operators and, or, and not. In the next lesson, we're going to finish looking at operators and cover the exponentiation operator and the logical assignment operators. In this lesson, we're going to look at the exponentiation operator and the logical assignment operators. Let's start with the exponentiation operator. The exponentiation operator returns the result of raising the first operand to the power of the second operand. The syntax is to use a double asterisk. Now the variable num will hold the value 16. We can also use the operator to raise powers of powers, like this for example. Now in this case we kind of break math in JavaScript. The really big number will actually contain a special JavaScript number called infinity, which we can't use to do any further calculations on. There is a solution, however. Instead of using numbers in this expression, we can use a different data type called a BigInt, which may be familiar if you've worked with other programming languages. We'll be looking at BigInts later in the course, so don't worry too much about the syntax for now. One thing to note about the exponentiation operator is that it's right associative, which means that the expression is read from right to left instead of left to right. So it's as if we did this. If we want to specify the order, we can just use brackets. Another thing to note with the exponentiation operator is that we can't precede the first operator with a unary operator. In this case, we get a syntax error. To avoid this, we can again use brackets. In previous lessons, we've looked at assignment operators and logical operators. Well, it's now time to look at logical assignment operators, of which there are quite a few. The logical AND assignment operator assigns the value of the second operand to the first operand if both operands are truthy. In this case, the variable a will contain the value 0, because one of the operands, b, is 0, which is falsy. Similarly, if we do this, Then the variable c will also be 0, because this time the first operand is 0. However, if we try this time the variable e will contain the value 2, because both of the operands are truthy. The opposite of this is the logical OR assignment operator, which will assign the value of the second operand to the first operand as long as one of the operands is truthy. This time the variable a will contain the value 1, because the second operand, b, is truthy. Similarly, the variable c will also contain 1 in this case, because the first operand is truthy again. However, a better example would be this. Somewhat unintuitively, the variable e will continue to contain the value 1. The reason for this is because this expression short circuits. What this means is that if the value of the first operand is truthy, JavaScript takes a processing shortcut and the second operand is not evaluated, so the variable retains its original value. Last of all, we have the logical Nullish assignment operator. This operator is quite similar to the logical OR assignment operator that we just looked at, but the difference is that while the logical OR assignment operator will assign to the first operand if the first operand has any falsy value, the logical Nullish assignment operator will assign the value of the second operand to the first operand if the value of the first operand is explicitly null or undefined. The first operand is null, so it makes the assignment to 1. This time the assignment is not made, because again, the expression shortcuts. The value of c is not explicitly null or undefined, so the second operand is never evaluated. So in this lesson we learned about some more JavaScript operators. We saw that the exponentiation operator returns the value of the first operand raised to the power of the second operand, and uses a double asterisk syntax. We then moved on to look at the different behaviours of the logical assignment, AND, OR, and Nullish operators, and compared the results of using different values for the operands. In the next lesson, we'll look at operator precedence, or the order in which operators are evaluated when multiple operators appear in the same expression. In this lesson, we're going to look at one more aspect of operators, and that is something called operator precedence, which just means the order in which operators are evaluated when there are multiple operators in the same expression. So let's say that we want to perform the following calculation. We might think that we're adding 1 to 4, which gives 5, and then multiplying it by 2 to give 10, right? Wrong. The multiplication operator has a higher precedence than the addition operator, and so this is evaluated first. The calculation that we actually perform is 4 multiplied by 2 plus 1, which gives 9. If we wanted to perform the calculation we thought that we were performing, we could wrap the first part in parentheses. Parentheses, which are also known as the grouping operator, have the highest precedence of any other operator. So any part of a calculation enclosed within parentheses will automatically be evaluated first. If we use two operators of equal precedence, these are usually evaluated left to right. Sometimes, however, operators of equal precedence are evaluated from right to left. The order in which operators of the same precedence are evaluated is known as operator associativity. Out of the operators that we've looked at so far, following parentheses, the highest weighted operators are the postfix, increment, and decrement operators, followed by not and the unary operators. These are all evaluated from right to left. Following this are the arithmetic operators, which are evaluated in the order multiplication, division, modulus, addition, and lastly subtraction. Next in terms of precedence are the comparison operators. These are all evaluated from left to right. And following this are the logical operators and or, the assignment operator, the spread operator, and last of all the comma operator, which has the lowest precedence out of all of the available operators. These are all evaluated right to left, except for the comma operator, which is left to right associative. These rules are fairly complex and sometimes hard to remember, especially when you're just beginning with JavaScript. For now, I wouldn't worry about them too much, but at some point when you're more comfortable with JavaScript, I'd recommend that you look at the developer documentation on precedence and associativity up on the Mozilla Developer Network. So in this lesson we learned all about operator precedence and associativity in JavaScript, focusing on the operators that we've covered in the course. In the next lesson, we're going to take a quick look at reserved words and identifier names. In this lesson, we're going to take a quick look at reserved words in JavaScript. Reserved words are words that have special meaning and so can't be used as identifier names. In JavaScript, an identifier is the name given to a variable, an object property, a function, or a class. It identifies the thing so that we can reference it in other places in our code. As we saw earlier, there are some rules for identifier names. They must start with either a letter, an underscore, or the $sign. We can use these characters as well as numbers within the identifier name, but we can't start an identifier with them. So myThing1 is a valid identifier, but oneThing is an invalid identifier name. The casing of identifier names is also important. Because the casing between these two identifier names is different, they are not treated the same by JavaScript. In addition to these rules, identifiers must not be reserved words. This is generally okay because most code editors these days have code highlighting. So if we try to use a reserved word as an identifier, generally, our IDE will tell us. With a bit of experience, we'll come to recognize the fact that the identifier that we're trying to use is illegal. There are about 60 different reserved words in JavaScript, and these are mostly keywords that have syntactical meaning, like function, if, else, new, type of, and things like that. As well as the reserved words that are actually in the official JavaScript specification, there are also a huge number of words that browsers use to make certain global objects available to JavaScript, things like window, document, and element. Generally, it's best to avoid using these as well, because other scripts running on the page may depend upon them. There are many more of these not quite reserved words, and there are also a range of event handlers whose names we should avoid overwriting, like onClick. So in this lesson we learned about reserved words and identifiers in JavaScript. We saw that there are many words that we cannot use as identifier names, and a lot more words that are best avoided for identifier names because the browser makes use of them. In the next lesson, we're going to look at strict mode. In this lesson, I want to mention a small but useful feature of JavaScript, numeric separators. Numeric separators in JavaScript are a small bit of syntactic sugar that makes working with large numeric constants a little bit easier. Let's say we need a large number constant. There's a lot of zeros there. Was it 8 or 9? We have to stop and think about it. Or let's say we need to store a const value of 1,200,743,000,000. How do we write that in numbers? It may seem trivial, but the less time we think about how to write numbers, the more time we can think about how our app actually works. Underscores can be used as numeric separators in JavaScript, and we can use these to make any large numbers more readable by grouping digits. This is much more readable. These separators are purely a visual device for our convenience. They won't affect any calculations or comparisons at all. So this works as expected. And so does this. There are no correct places to put the separators either. We can put them wherever we like. This is perfectly fine. We can use these with any of the supported number bases as well, binary, hex, or octal. The only thing we can't do is use 2 consecutive underscores. JavaScript doesn't like it. So in this lesson we learned that we can use JavaScript separators to make large numbers in our code easier to read. We saw that these don't affect numeric calculations or operations at all. They are merely a small utility for us developers to make reading code easier. We learned that we can use these separators wherever makes sense to us. There are no correct places to put them. And that we should avoid using consecutive separators to avoid script errors. In the next lesson, we're going to look at strict mode. In this lesson, we are going to learn about what strict mode is and why you must almost always use it. Strict mode is a slightly different mode of JavaScript execution which is stricter than regular or non-strict code, and it affects how some features of the language are used. Non-strict JavaScript is often referred to as sloppy mode. Strict mode was introduced a long time ago to improve some of JavaScript's downsides. These days, strict mode should almost always be used, and in some cases will be enforced automatically, like when using ES modules, which we'll come back and look at much later in the course. It's recommended to always use strict mode because all modern browsers support it, and because it causes some silent errors to actually throw an error. It also prevents global variables from being created if we accidentally forget to use var, let, or const when declaring a variable. And it has a host of other benefits also. So to use it, we just need to add the string useStrict as the first line inside either a function or a file. So now all of the code that we add to this file, which will be added inside the function, will be run in strict mode. This type of function is known as an immediately invoked function expression, or IFE for short. So strict mode does a number of things for us. First of all, it throws errors when we try to overwrite certain globals instead of just failing silently like it would do in sloppy mode. The built-in read-only globals are nan, undefined, and infinity. Usually, if we try to overwrite these, it's because of an error in our code, so an error message is much more useful to us than a silent failure. In this case, we see an error message saying that we cannot assign to the read-only property nan, which is a property of the global object window. Let's just comment out the useStrict directive. Let's go back to the browser again. This time we don't see the error message. However, trying to overwrite nan will have failed. So nan still has the value nan, which is a special value. Trying to overwrite the value with a string didn't work, but we didn't see an error message. So that's one of the most important benefits of using strict mode. It throws errors instead of failing silently. Strict mode also prevents the use of the with operator, and that's why we didn't cover it earlier when we looked at operators. Additionally, strict mode adds some new reserved words to the language, and these are package, protected, implements, interface, private, and static. As I said, strict mode was introduced a very long time ago, but it was only recently that some of these new reserved words became usable, like private and static. These are used with JavaScript classes, which we will come back and look at later in the course. So in this lesson we've learned about what strict mode is and why we should always use it when applicable. In the next lesson we're going to look at Nullish coalescing and optional chaining. In this lesson, we're going to look at Nullish coalescing and optional chaining. The Nullish coalescing operator is a logical operator, like the AND and OR operators that we looked at earlier in this section. Syntactically, it takes the form of a double question mark, and it is intended as a better way to have default values. Typically, we would use the logical OR operator to ensure that a variable had a default value. For example, we might have used code like this previously. In this case, y will equal 10 because we set the value of x to null, which returns false, so the second operand of OR will be used. This works as intended in this contrived example, but it can have unexpected results when used in real code. The first operand will be coerced to a boolean, so any falsy value will result in the right-hand side value being used, and this may not always be what we want. In this case, because 0 is falsy, we would end up with the value 10, when really we probably wanted to initialize the variable num to 0. The nullish coalescing operator prevents this issue from occurring, because instead of returning false for any falsy value like the OR operator, it only returns false for null or undefined. Now, the num variable will contain the value 0 and not 10, because the count variable was not explicitly null or undefined. It's a more predictable operator because of its limited behavior, and is therefore preferred in this situation. Like the logical OR operator, the nullish coalescing operator shortcuts based on the value of the left operand. If it returns null or undefined, the right side is never evaluated. Similar conceptually to nullish coalescing is the optional chaining operator, which also works on values of null or undefined. The syntax for this operator is a question mark followed by a period, and it is used solely to safely access object properties. With regular dot access, if we try to access a property of what we think is an object, but which is actually null or undefined, we'll see an error that says we cannot read the properties of undefined. With the optional chaining operator, we can avoid this error. Now, trying to access properties of something which is null or undefined will just return undefined instead of throwing an error. The behavior of this operand is simple and very similar to the nullish coalescing operator. If the left-hand side of the expression is equal to null or undefined, the right-hand side of the expression is not evaluated, and hence no error is thrown. We can use multiple optional chaining operators in a single property access if we wish. This will still return undefined if any of the properties in the chain are null or undefined. If the inner A1 object did have a test property with a value, that value would of course be returned as expected. So in this lesson we saw that the nullish coalescing operator is designed specifically to only return false for null or undefined values, rather than for any falsy values like the OR operator. We also saw that the optional chaining operator is a feature that allows us to access property values safely on objects or object properties that may be null or undefined. In the next lesson, we're going to look at one of the most fundamental aspects of JavaScript, the function. In this lesson, we're going to take a look at the general workhorse of our JavaScript applications, the function. A function is a named grouping of one or more expressions. A function can be invoked at any time to execute all of the statements inside the function. We'll use functions a lot, and they can be used in a variety of different ways, so it's important to understand them fully. The most basic way to define a function is using the function keyword, followed by the function's identifier, followed by opening and closing parentheses, followed lastly by opening and closing curly brackets, like this. So just to recap, we have the function keyword, followed by the function's identifier, which in this case is function 1. The parentheses are the parameter list. In this case, the function doesn't receive any parameters because the parentheses are empty. And lastly, all of the expressions within the function are contained within curly brackets. In this case, the function doesn't have any expressions inside of it, but that doesn't make it any less of a function. Let's just add an expression, however, inside of it. So this form of defining a function is called a function declaration. To invoke this function, we use its identifier followed by a single set of parentheses, like this. And we can take a look at that in the browser. And we should see the log message that we added within the function. If we want to pass values into the function, which are treated as variables inside the function, we can list them as parameters in the function declaration. So in this case, we have specified that function1 should accept a single parameter, which is called MSG. And inside the function, we just log whatever is passed as that parameter to the browser's console. And then following this, we can invoke the function any number of times that we want, and we can pass in a different string each time, and whichever string we pass in will get logged to the browser's console. So this is really useful because it makes the function reusable. We pass different data into the same function and get different results. There is also a subtle distinction to be made here. When we declare the function, we list the parameters that the function accepts. When we invoke the function, we pass it arguments. This is the difference between parameters and arguments, but you will very often hear them used interchangeably. We can list as many parameters in the parentheses of the function as we want by listing multiple parameters separated by a comma. So these parameters that we have specified as part of the function declaration are named parameters, and named parameters are made available inside the function as if they were variables. Functions have access to another special value inside of them, which is called arguments, and this value contains all of the arguments that are passed to the function. So this time, with the logargs function, we haven't specified any named parameters, but we can still get access to any arguments which are passed when the function is invoked using the special arguments keyword. And you can see that arguments is an array-like object, and all of the individual arguments are available within this. You should be careful when working with arguments. Even though it looks like an array, it's not a true array, and so it doesn't have any of the methods that true arrays have. Another thing about functions is that they always return a value. In the two functions that we've looked at so far, we haven't returned a value explicitly, so both of these functions actually return undefined. To specify what a function should return, we can use the return statement. So now, whenever the logargs function is invoked, it will return the string some value. What the function returns depends largely on the purpose of the function. If the function is to compute some value, it should probably return this value. If the function fails to do what it should do, it could return false. As soon as the function returns, it stops executing completely. Another way that we can define functions is as a function expression. A function declaration always starts with the function keyword, so any expression which defines a function but doesn't start with the function keyword is a function expression. Function expressions are usually, but not always, functions that are stored in a variable, like this. Function expressions largely behave in the same way as function declarations. We can still invoke them, but this time we use the variable name rather than the function identifier. In this case, the function that we have saved in the variable f is known as an anonymous function because it doesn't have an identifier. Function expressions can also make use of functions that have identifiers. We just need to specify the identifier after the function keyword. So this time the function has the identifier f, and it is also stored in the variable f. This can be useful for debugging purposes, so it is advised to try to always use identifiers even with function expressions. When a function expression has an identifier, like this, it's known as a named function expression. We can nest functions inside one another, we can pass functions to other functions, and functions can return functions. This means that JavaScript supports first-class functions. Let's just spend a moment talking about hoisting. When your browser loads a JavaScript file, there are two phases which occur. The browser first reads the entire file. This is known as the parsing phase. And only once it has parsed the entire file does the browser execute the code in the file. This second phase is known as the execution phase. Variables are processed during the parsing phase before any other code is executed. What this means is that even if we declare a variable halfway down a function, it will be available at the top of the function. JavaScript hoists it to the top. Let's look at a basic example. So we'll take a look at this in the browser's console in just a second, but before I switch back to the browser, what do you think the function is going to log? Let's take a quick look and see. You can see that it's logged undefined. Let's go back to the code and just talk through why. So what actually happened, when the browser loaded the index.js file, it first parsed the entire file. And in doing that, it created any variables that were declared. So in this case, the declared variable is test variable. So test variable was declared in the first phase, the parsing phase. The code is then executed in the second phase, the execution phase. And in this case, the browser executes the code inside the file on a line-by-line basis from top to bottom. So when the test variable was declared in the parsing phase, it was given the value undefined. The browser then executed the file, and so the console.log statement appears before the value test is assigned to the test variable, because variable assignment happens in the execution phase, not the parsing phase. It is only the declaration of variables which happens in the parsing phase. So actually, it is as if we wrote the code like this. Even though we didn't write the code like that, that's how the browser interpreted it. Hoisting literally means that the code is lifted right to the top of the function. It's hoisted. So this only affects variables declared using the var keyword. Let and const do not exhibit this same behavior. Hoisting used to be problematic, especially for newcomers to JavaScript. But these days, because it is recommended to use let or const most of the time, we can largely avoid these hoisting issues. So in this lesson we looked at some basic facts about functions, such as how we can create them and invoke them, and how we can specify which parameters they accept. We also looked at how we can create functions which are invoked immediately. We also looked at the difference between function declarations and function expressions, and variable hoisting. We'll now move on to the next section, which focuses on the data structures available to us in JavaScript. Let's start section 3 by looking at arrays. Arrays are very commonly used in JavaScript and have a rich and extensive API for manipulating them. We'll look at these APIs later in the course. So an array is a single object which can contain multiple values. A variable is a container for a single value, but an array is a container for multiple values. As I mentioned before, we can create arrays in a number of different ways. There is the Array Constructor, but we can also create literal arrays. Now, I mentioned earlier that it was encouraged to use the literal form. Let's just look at why. So we saw earlier that there is an Array Constructor. Let's just remind ourselves what that looks like. The Array Constructor receives an argument, and that argument is the number of items that we want the array to have. So in this case, we have specified that we want to create an array with one item in it. So at this point, the myArray variable contains an array which has one value. Now the constructor doesn't let us specify what that value is, and so when we use the array constructor, the values inside the array will be initialized as undefined. This is why it is recommended to use the literal form. In this case, we've also created a new array that has a single value, but instead of that value being undefined, we've given it a string value. This is why it is recommended to always create arrays using the array literal form rather than the array constructor, to avoid having an array full of undefined values. Arrays do have an upper limit on the maximum number of elements that we can store in them, but this limit is so high that for all intents and purposes, we can assume that they have an unlimited capacity. To add multiple items to an array, we just separate them with commas. Arrays use numerical indexes to address the elements within them, and these indexes always start at 0. So the first element in the array is at index 0, the second is at index 1, and so on and so forth. To access an individual array element, we also use square brackets and specify the index of the element that we would like to get. So by specifying the index 1, we will get access to the second element in the array. An array's length is always 1 greater than the index of its last element. So if we want to get the last element in an array, and we don't know how many elements there are inside it, we can do this. In this case, we get the same value that we got before, but if there were more elements inside the array, this would give us the last one. We don't have to know how many items there are in the array in order to add new items to it. For example, in this case, the array will have 100 values, but all of the values in between the first two values that we gave the array when we declared it and the 100th item that we just added, all of the values in between those values will be undefined. They'll still exist, but they'll be undefined. So in this lesson, we've learned some of the basics of arrays in JavaScript. We've seen that we should declare arrays using the literal syntax, and we've seen that we can access individual elements within an array using square brackets and the numerical index of the element that we want to get. We've also seen that we can add new items to the array by specifying the index that we'd like the new value to be inserted at and using the assignment operator. Arrays are capable of a lot more functionality, and we'll come back and look at them in much more detail later in the course. In the next lesson, we can take a look at another fundamental concept of JavaScript, objects. In this lesson, we're going to take a look at the all-important object. We looked at them very briefly earlier. Let's just recap on some of the basics quickly first of all. So objects in JavaScript consist of a series of comma-separated key-value pairs within curly braces. The key-value pairs are known as properties and consist of an identifier and a value. The identifiers are also called keys. The values can consist of any other data type, including objects and even functions. This way of creating objects is known as object literal syntax and is the recommended way to create objects. Like with arrays, there is also a constructor that can be used. Also, just like with arrays, it is recommended to always use the literal form. There are two different ways to access the values held within an object and two different ways to add new values. We can use dot notation to access them, and we can also use square bracket notation. So both of these forms are treated identically by the JavaScript engine. We can also use both these forms to set new values. So these are all equally as valid. Dot notation is more commonly used to get or set property values, but square bracket notation can be very useful if we want to use a variable to access or set object properties. Let's just look at a quick example of this. So here we've declared a simple function called getThingByColor, which accepts a single parameter called color. We've also defined an object inside the function called things, and this object has a key called red, a key called green, and a key called blue, and each of these properties has string values. We can use the return keyword to either return the thing from the object, or the default string, sorry, no thing of that color exists. So the useful thing here is that when the function gets invoked, we can pass through either red, green, or blue, and we will get the corresponding value from the object. Inside the function, however, we don't know what color is going to be passed, and so we just use the color parameter with square bracket notation to get the matching property from the object. Notice how we use the logical OR operator here to return the default message if a color is passed to the function which doesn't have a corresponding key in the object. This works because if we try to access a property of an object that doesn't exist, we get undefined, and undefined evaluates to false. And let's just check in a browser that it is working in the way that we expect. And we can see that the function is working in the way that we expect. So in this lesson, we looked at some object basics in JavaScript. We saw the different ways that we can get the values stored inside the object and how we can add new properties. And we saw that both of these things can be accomplished with either dot notation or square bracket notation. In the next lesson, we'll look at sets. In this lesson, we're going to look at a data structure called a set. A set is similar to an array, but in a set, you can only store unique values inside it. The values can be of any type, but they must all be unique. To create a set, we use the set constructor. At this point in time, there is no literal form of sets. We can optionally provide an iterable object as an argument to the constructor, and all of the values will be added to the set. An array is an iterable object, and we'll look at iterators and iterable objects later in the course. For now, just understand that an array is also an iterable object. So in this case, we declare an array called an array, and we give it some non-unique values. In this case, they're all numbers. And then we create a set called mySet2, and we pass the array to the new set. So using a set is a great way to deduplicate an array. So let's just log mySet2 to the console. And let's take a look at that in a browser. And we can see that the set just contains the unique values 1, 2, and 3. It doesn't contain all of the values from the array because not all of the values were unique. To see how many values there are inside a set, we can use the size property of the set. And in this case, we should see the value 3. And indeed we do. We also have a range of different methods that we can use to work with sets. we can add or remove values from the set using the add and delete methods respectively. And let's just log the set once again so we can see what changes have happened to it. And we can see that in this case it now contains the values 2, 3 and 4 instead of 1, 2 and 3. Because the values are unique, with the delete method we pass the value that we want to remove, not the index of the value that we want to remove. We can only add a single value at a time, but the method returns the set itself, so we can chain it, like this. When we use the delete method, this method will return true if the value was deleted, or false if we try to delete a value that doesn't exist. So if we were to change this expression to this, it would simply return false. It wouldn't throw an error, even though the value 6 is not contained within the set. If we want to determine whether a particular value exists in a set, we can use the has method. And in this case we should see the value true because my set 2 does have a value of 3 inside it. There are a couple of different ways that we can iterate through the values inside a set. We can use the entries or values methods, which both return an iterator. We'll look at iterators in much more detail later on in the course. While a set may seem conceptually similar to an array, we should remember that it isn't. They are completely different data types. The values inside a set don't have an index or a key, so we can't pull out individual values using bracket notation like we can with arrays. So in this lesson we looked at the new set object which was introduced in ES 2015. We saw that it is a data structure that allows us to store unique values. We saw that we can get the number of values in the set using the size property, and we looked at some of the methods that we can use to work with the set, including add, delete and has. We also learned that sets are similar to arrays, but they are fundamentally different. In the next lesson, we'll be looking at the map object. In this lesson, we're going to look at a data structure called a map. Maps are similar to sets, which we looked at in the last lesson, except for the fact that maps store key value pairs instead of individual values. Sets are similar to arrays, but maps are more similar to objects. Let's take a look. Like with sets, we need to use the map constructor to create a map. At this point in time, there is no literal form for maps. So now the variable myMap will contain a new instance of the map object. Just like with sets, we can also create a map that contains data. Instead of passing a regular iterable, we need to pass a two-dimensional array to the map constructor. So the array is a two-dimensional array because it is an array which contains other arrays. The elements in the first array will be used for the key names in the map, and the elements in the second array will be the values associated with the keys. Unlike with regular object literals, the keys as well as the values can be of any data type. Here we have strings as the keys and numbers as the values, but we could also have objects as the keys and numbers as the value, or functions as the keys and objects as the values. Maps have a very similar API to sets, but with some key differences. So first let's look at the methods the map has, which the set doesn't. If we want to add a new key value pair to the map, we use the set method. This method takes two parameters, which are the key and the value. So this expression will add a new key to mymap2. The new key will be the string value c, and the value of this key will be the number 3. The set method returns the map object, so it can also be chained. This method works in the same way as the set object's add method. Unlike with a set, we can retrieve a single value from the map without having to iterate the whole map. To do this, we use the get method, specifying the key of the value that we want to get. So the rest of the map API is very similar to the set. We can use the has method to see whether the map contains a given key, and we can delete a key and its associated value using the delete method. And once again, this method returns a boolean to indicate whether the key was removed or not. If the key doesn't exist in the map, it won't be removed, but it also won't throw an error. It will just return false. We can empty the map completely using the clear method, and we can also iterate a map with a for each loop or using for of. We haven't covered looping yet. We will be coming to that in the very next section. Just like the set, the map can also return iterators and has several methods for doing this which it shares with sets. For example, the entries and values methods. We'll be looking at iterators later in the course, so I don't want to spend too much time looking at them now. So in this lesson we looked at the map object and saw that it is similar to the set object in the API that it exposes, but that we use it to store key value pairs instead of individual values. We also saw that the maps API is very similar to the set API, except that it uses the set method to add new key value pairs and the get method to retrieve values. In the next lesson, we'll look at weak maps and weak sets. In this lesson, we're going to look at some objects that are extremely similar to sets and maps that we've already looked at, weak sets and weak maps. The difference between these objects and the regular sets and maps that we already looked at is that references to the values inside weak maps and weak sets are held weakly. What this means is that the JavaScript engine will be able to remove the values when they are no longer referenced, and this can improve performance. Let's take a quick look at weak sets first. We saw that sets can be composed of any type of data. This is one place where weak sets differ from sets. Weak sets can only be composed of objects. To create a weak set, we use the weak set constructor. So this is very similar to the set constructor, it's just called weak set. And like with the set constructor, we can also pass an iterable object to the constructor, and the elements of the iterable object will be added to the set. Each value inside a weak set must still be unique. Weak sets have a much smaller API than sets. We have only the add, delete, and has methods. So we've declared an object called SumObj because weak sets can only contain objects, and then we add this to the weak set using the add method. And let's just add a log statement that checks whether or not the weak set has the object inside it. Obviously we know that we do in this case, but that might not always be the case. And let's take a look at a browser, and we can see that it returns true because the weak set does contain some object. So now let's look at the delete method. And let's take a look in the browser once again. And this time the second log statement returns false because we deleted some object using the delete method. So these are the only methods that we have available with a weak set. Let's move on to look at weak maps. One difference between a weak map and a regular map is that in a regular map, the keys inside it can be of any data type. That's not the case with a weak map. Similar to a weak set, the keys in a weak map must be objects. Just like with maps, we create a weak map using its constructor. Again, with a weak map as compared to a map, we have a much smaller API for working with it. With a weak map, we have only the methods delete, get, has, and set. And this also means that weak maps, just like weak sets, can't be iterated. What separates weak maps from maps is that references to the keys in a weak map are held weakly, which means that both the key and its associated value can be garbage collected if no other references to the key exist. The main reasons for using weak maps and weak sets is to avoid memory leaks, but I think this is probably a slightly too advanced topic for this point in the course. So for now, let's just acknowledge that weak maps and weak sets exist, and you can come back to them later when your understanding of JavaScript is a bit more advanced. So in this lesson we looked at weak sets and weak maps, which are similar to their set and map counterparts, except that the references to the values inside them are held weakly, and so do not prevent garbage collection. We saw that they both have a very small, focused API compared to their non-weak counterparts, and that neither of these data structures can be iterated. We've now covered the main data structures used in JavaScript. In the next section, we'll focus on controlling program execution, starting with conditional logic. In this lesson, we're going to start looking at how we can work with JavaScript to control the execution flow of our programs. In this lesson, we'll focus on using the conditional if statement. Other lessons in this section will cover additional control structures. The if statement is known as a conditional statement because it only executes certain statements based on the result of an expression. First of all, let's look at how it is structured syntactically. In its most basic form, the statement begins with the reserved word if, followed by parentheses that contain the conditional expression, followed by a block which is denoted by opening and closing curly brackets. So if we run this in a browser now, we should see the console.log in the browser's console because 1 plus 1 is equal to 2. If we go back and change the condition, this time we shouldn't see the log statement in the browser. And we can see that we don't. So the condition to evaluate is within parentheses. Generally, we don't put entire expressions into the parentheses. We would normally compare a single value, like a variable. Each if or the corresponding else is known as a branch, and the statements within the curly braces are known as a block. We can add multiple branches by combining the if statement with an else statement. So we shouldn't see the first log because true is not equal to false, but we will see the second. In this example, we can only really have 2 branches. But if we're comparing different kinds of values, we can have as many else branches as we need. So we start out by comparing the color variable with the string blue. And if that expression resolves to true, we'll log the string blue to the console. We then combine the else and the if keywords. And this time we compare the color variable to the string green. And if that is true, we can log the string green to the console. We then have a final else branch, which basically means that if the first 2 conditions are not met, then do this branch instead, and that will just log the color variable to the console. So in this case, we should see the string red in the console. So we can add as many else if branches as we need to, but we should really only have one else. even if we have multiple else-if expressions. It's not essential that we provide a plain else at the end of the if statement, but we probably will in many cases. One point to note is that any truthy value will cause a branch to execute, not just the Boolean value of true. So in this case, the value 1 is a truthy value. And what truthy means is that in a conditional expression, such as an if statement, the value resolves to true, even though it isn't actually the Boolean true. This can be very useful. For example, if we want to check that an array contains at least one item before we try to use that array, we can check that it has a length property. So here we define an array that has a single value, which is the string yes. The value that the array contains is not important. It's just important that it contains a value. So when an array contains values, it has a positive value for its length property. So in this case, the length would be 1 because the array contains one value. 1 is a truthy value, so we should see the console log array has length. If we change the array so that it doesn't contain any items, the reason why we don't see the console log is because the length of the array is now 0, and 0 is falsy, not truthy. There is one more type of conditional, in addition to the if statement, and that is the ternary statement. This type of conditional is much more terse than a standard if-else statement, but it's basically a shortcut for a conditional that contains a single if and a single else. The ternary operator is a special operator that takes 3 operands. Let's look at the syntax. So the different operands in a ternary are as follows. We have a conditional. That is usually surrounded by parentheses, although these parentheses are not mandatory. It does help improve readability if you include them. We then use the ternary operator, which is the question mark symbol. This is followed by the truthy operand, in this case a console.log statement, and lastly we have the falsy operand, and that is separated from the truthy operand using a colon. So in this case, because true evaluates to true in the conditional part of the ternary right at the start of the expression, we should see the first console log. So in this lesson we looked at the conditional control structure if, along with its else and if-else permutations. We learned that any truthy expression will cause the if block to execute, but falsy values will not cause the if block to execute. We also looked at the ternary operator, which is like a shorthand version of a standard 2-branch if-else statement. In the next lesson, let's take a look at handling errors with try-catch. In this lesson, we're going to look at the try-catch statement. Try-catch is a way of handling code that could potentially throw errors. Now, all code can potentially cause errors, of course, but there is a difference between actual errors in the code because of faulty logic or typos, and operations that may genuinely fail for reasons beyond the code's control. As we've seen throughout the course, doing something wrong in our code generally results in a console error, which is how we diagnose the problem. But it also stops program execution. Our script effectively dies. We can use try-catch to avoid the program stopping entirely and attempt to recover from the error. Let's take a look. The syntax for try-catch is similar to other conditional structures. We start out with the try keyword, followed by a set of curly brackets. statements which may result in an error being thrown should come between these brackets. The try block is followed by the catch block. This block is also wrapped in curly brackets, and this time may optionally receive an error object containing information about the error. So let's add something that is definitely going to cause an error to the try block. When we try to invoke a function that doesn't exist, a reference error should be thrown, and indeed, in the logged console message, we can see reference error doesn't exist is not defined. But there isn't an actual console error. The script didn't die. It entered the catch block when the error occurred, logged the error to the console, and then stopped executing gracefully. The error object passed to the catch block is an object, not just a string. It will have a name and a message property. In our example here, the name is reference error, and the message is doesn't exist is not defined. A common, but nevertheless unofficial property that this error object may have is the stack property, which provides useful debugging information about the exact call stack of functions that led to the error occurring. We can see this stack below the error. One point to note is that the error binding is optional. We can also use a shortened version where we don't make use of the error. This is less useful in some ways because we don't get any information about the error, but it is valid code. So in this lesson we looked at the try-catch statement, which allows us to catch errors from code that may be prone to cause errors. We saw that any potentially problematic code can be wrapped in the try block, and that if an error does occur, we can catch it in a catch block and attempt to do something with the error or try to recover in some way. We saw that we can optionally receive an error object in the catch block, which provides information about the error that occurred. In the next lesson, we're going to look at the switch statement. In this lesson, we're going to cover the switch statement, which is an alternative to the if statement in that it consists of a series of branches that are executed depending on whether a condition is met. A switch statement can perform faster than an equivalent if, and some argue that the construct is more readable. Another differentiator between if and switch is that if is normally used with Boolean or truthy and falsy conditions, whereas switch statements can be used with other values, like strings. The syntax for a switch statement is fairly straightforward. Let's look at a simple example. So first of all, we've declared a variable called switcher, which has the string value 2. This isn't part of the switch statement, but we will use it in conjunction with the switch statement. So we start out with the reserved word switch, followed by an expression in parentheses. We'll use the switcher variable as the condition to switch on. We can now add cases for what we expect the switching variable, in this case the variable switcher, to match. The switch block as a whole is surrounded by curly brackets, but the individual case statements within it are not. To define a case block, we use the keyword case, followed by the value that we expect the switch variable to equal. In this case block, we can just log a message to the console. It's very important to end case blocks with the break keyword. We'll come back to that in just a moment. So let's add another case now. And let's just add one more case block. So our switch statement consists of 3 separate case blocks. Let's run it in a browser and see what happens. In this case, we see the message the value was 2. Because the variable that we're switching on, the switcher variable, contains the string 2, so that matches our second case block. So I mentioned that it was important to always use the break keyword. Let's see what happens if we don't. This time we see 2 log messages, both the second and third. This is why it is very important to always use the break keyword at the end of each case. If we don't, then program execution falls from the case that gets matched into all cases below it. So if we had cases for 4, 5, 6, and so on and so forth, all of those would be logged. That's why the break statement is very important. As well as providing cases for particular values of the expression, we can also add a default clause that will be executed if none of the other cases match. And now let's just change our switcher so that it doesn't match any of the cases. And let's go back to the browser. We can see that in this case the default block was executed because none of the other cases matched. So this is a bit like the else block at the end of an if block. So in this lesson we looked at the switch statement, which works in a similar way to the if-else statement that we looked at in the last lesson. The difference is that this construct is able to conditionally execute one or more blocks based on any type of value rather than true or false conditions like with the if statement. In the next lesson, we can move on to look at loops, starting with the for loop. In this lesson, we're going to take a look at the for loop. In programming, a loop is used to execute a block of statements numerous times, each time with a different value. JavaScript has a number of different types of loop, the while and do-while loops, and the for, for-in, and for-of loops. In this lesson, let's focus on the for loop. This loop is useful for iterating through the items in an array. With the for loop, we use the reserved word for, followed by 3 expressions inside parentheses, followed by a block of statements within curly braces. So for this example, let's say we have an array containing 3 elements. We can loop through this array using a for loop and do something with each of the elements in the array. So let's look at this syntax in more detail. We start out with the for keyword. We then have 3 expressions within parentheses, and this is followed by a block containing 1 or more expressions. And let's look at the 3 expressions within the parentheses. So the first expression sets a counter variable for the loop. The second expression checks that the counter variable is less than the length of the array, and the last expression increments the counter variable by 1. So the first expression will be evaluated the first time the loop is run, but the second and third expressions will be evaluated on each iteration of the loop. In this case, the array has 3 elements, so the loop will be executed 3 times. Inside the block for the loop, we can get each item in the array using square bracket notation in conjunction with the counter variable, x. So if we look at this in a browser now, we should see 3 different log messages containing each element from the array. So this is the most basic form of loop, and it's been a part of JavaScript for a very long time. We can actually improve on how this loop performs quite easily by adding another variable to the first expression and making a minor change to the second expression. So we've only made a small change here, but what we've done is change the first expression, which is only evaluated once, to include a variable that contains the length of the array. Then in the second expression, we can just compare the 2 variables. Remember that I said the first expression is only evaluated once the first time the loop runs, so we aren't checking the length of the array on every single iteration now, only on the first iteration of the loop. All three of the conditions in the parentheses following the for keyword are optional. We just need to provide the separators if we want to omit any of them. We can even omit all three if we like. So in this case, we didn't provide any expressions within parentheses, we just provided the separators. This means that we have to do the check that we're not going over the length of the array inside the body of the for loop. And it means we need to do the increment ourselves at the end of the loop. This will work in exactly the same way as the first for loop. So this time we see the same 3 log messages as the first loop showed. So this is valid JavaScript syntax, and you might see for loops that look like this, but generally it's best to stay away from this second format. And the reason for that is because in the first for loop, the x variable, which we declared with let, is scoped to the for loop block and is not visible outside of the block. Whereas in the second form, the x variable is defined outside of the for loop, and so it is visible both within the block of the for loop and outside of it. We also have to do this length check ourselves using an if statement and manually break inside the body of the for loop, which will stop the loop from executing. So really, we lose the benefits of block scoping in the second format, and there is a bit more code that we have to write ourselves. So generally the first format is preferred. So in this lesson we looked at the for loop, which we learned is specifically for iterating over arrays. Be aware that the bigger and more complex a loop is, the slower it will run. In the next lesson we'll move on to look at the for in loop. In this lesson we're going to continue looking at loops, this time focusing on the for in loop. As we saw in the last lesson, the regular for loop is useful for iterating the values in an array. The for in loop is useful for iterating the values inside an object instead. The for in loop has a much simpler structure than the basic for loop. With this loop, we also start out with the reserved word for and a set of parentheses. But inside the parentheses, we just have a single expression. Let's take a look at an example. So let's recap the syntax briefly. We start out with the for keyword. We then have an expression within parentheses. And lastly, we have a block which will be executed for each property in the object that's being iterated. So this time the expression inside parentheses is much simpler. We simply declare a new variable, in this case called prop, and then use the in keyword followed by the object that we'd like to iterate. Inside the block, we can add a simple console.log, which shows the value of the prop variable on each iteration of the loop, and also uses the prop variable with square bracket notation to extract each value from the object. Let's just take a look at the output in the browser. And we see the 3 key names and the 3 values. On each iteration of the loop, the variable defined within parentheses has the value of one of the keys in the object, and the block of expressions will be invoked for each key value pair within the object. With this type of loop, we don't need to specify or maintain a counter variable manually. JavaScript takes care of that for us. For in loops are only able to iterate over properties that are marked as enumerable. When we create an object literal, like we have done here, all of the properties that we specify are enumerable, But there are ways to define object properties as non-enumerable, and we'll look at that later in the course. Just be aware that the for loop will only iterate enumerable properties. However, it is possible for objects to inherit enumerable properties from other objects. So there is a simple check that we should always perform inside the body of a for loop. So in this example, the object literal that we've defined in the variable obj has inherited a method called hasOwnProperty. And this is used to check that the property that we're currently iterating actually belongs to the object. The hasOwnProperty method itself is non-enumerable, so it doesn't get logged out in the for loop. But there are situations where enumerable properties do get inherited, even by simple object literals. So it's very common to see this hasOwnProperty check inside the body of for loops. Another difference between for loops and for-in loops is that with for loops, an array's elements are accessed sequentially, from the 0th index to the last index. For-in loops, however, do not guarantee the order in which properties are accessed. This means that if you use the for-in loop with an array rather than an object, the loop may not access the array items in the correct sequential order. And that's the primary reason why we should always use a for loop with arrays and a for-in loop with objects. So in this lesson we looked at the for-in loop, which is used to iterate all of the enumerable properties within an object. We looked at the structure of the loop and saw how to perform a hasOwnProperty check to ensure that we are only working with the object's own properties and not any that it has inherited. In the next lesson, we'll focus on the newest type of loop in JavaScript, the for-of loop. In this lesson, we're going to take a look at the for-of loop. This is similar conceptually to the for-in loop that we looked at in the last lesson, except that instead of getting the keys of the object being iterated, it gets the values instead. I mean object in the generic term, not just object literal in the JavaScript term, because with the for-of loop, we can't actually iterate actual objects. The for-of loop is used to iterate over anything that is iterable, which is usually an array-like collection of values. True arrays are iterable, but also array-like collections of items, like the arguments value inside a function, for example, are also iterable. This makes the for-of loop useful if we don't know whether we'll be working with a true array or an array-like object. The syntax is very similar to the for-in loop that we looked at in the last lesson. We just use the of keyword instead of the in keyword. We don't need to use square bracket notation with the for-of loop. We can access the value directly. Let's just take a look at the output in the browser. So the for-of loop can iterate any kind of iterable, not just arrays. We can also use it with maps and sets, for example. So using a set works in pretty much the same way as using an array. When we come to use a map, however, we do need to revert to square bracket notation, because recall that when we get the value from a map, it returns an array, and we want to get the second item in that array, which will be the value. The first item in the array that gets returned at index 0 is the key name. And let's just check in the browser that the output is what we expect. And of course, we don't use the add method with maps, we use the set method. Let's just correct that. this time we see only the first item from the last example, the value a. In terms of performance, the for of loop is slightly faster than both for and for in loops. But to be honest, you would have to be using an array or object with tens of thousands of items in it to really notice the difference. So in this lesson we looked at the for of loop, the newest of the for loops in JavaScript. We saw that it can be used with arrays or any other iterable, but not with regular objects. We saw that the syntax was almost identical to the for in loop, except that instead of working with the keys of an iterable, we are working with the values instead. In the next lesson, let's take a look at iterators and iterables in more detail. In this lesson, we're going to look at iterables and iterators. We learned in the last lesson that the for of loop can be used to iterate any iterable, and we've come across the term several times so far throughout the course. An array is a type of iterable, so is a string, as well as a number of other objects, like the special arguments object inside functions, and maps and sets. This is generally all we'll need to know about iterables, although it is possible to overwrite the default iterable behavior of iterable objects, and it's even possible to make uniterable objects, like object literals, iterable. But this is quite advanced and pretty uncommon at this point, so we won't worry about this today. An iterator is a special object that provides access to a collection of items one at a time, and which keeps track of which items have been accessed. All iterators contain a next method. When the next method is invoked, an object is returned with two keys, value and done. Value will be whatever value the iterator returned from the collection, while done is a boolean that equals true only when the iterator has finished iterating the collection. So let's take a look at some iterators. We looked at the set object in the last section and saw a few of its methods like add and delete. Another of the set's methods is the entries method, and this method returns an iterator that we can use to iterate the set. Let's take a look. In this case, the setItems variable now contains an iterator, because the entries method of a set returns an iterator. This iterator has a next method, so we can invoke this method in order to pull out the first item from the set. Let's take a look in a browser now and see what we get. So the value is an array, and the done property equals false, which means there are more items in the set. Now the reason why the set returns an array as the first item is so that sets and maps work in the same way. It was decided that iterators for both sets and maps should be aligned. In the case of a map, the array contains two items, both the key and the value. But with sets, there are no keys. And so even though the value contains an array when used with a set like this, both of the items in the array are the same, and they both equal the value. So the done property is equal to false, and that means that we can still call the next method. So if we wanted, we could go back and add another log statement which called the next method once again. We can keep invoking the next method until done is equal to true. So the last time, after we've already pulled out all three values from the set, the object that the next method returns contains undefined as the value, and this time the done property is set to true. So maps and sets both have methods that return iterators. Iterators are very similar to a loop, except that instead of the loop executing a set number of times, depending on how many values there are in the thing that we're using the loop with, an iterator is like a manual loop, and it doesn't get executed automatically. We have control over when it gets executed, and that execution is controlled by us invoking the next method. There are many more methods in JavaScript, and there are many more objects that can return iterators, so you will come across them fairly regularly. So in this lesson we looked at iterators. An iterator is any object that exposes a next method. When this next method is invoked, an object is returned which contains the current value in the collection being iterated and a boolean indicating whether there are more items in the collection. Iterators are just like loops, except that we control when each iteration of the loop takes place. In the next lesson we'll look at one more type of loop available in JavaScript, the while loop. In this lesson we're going to look at the last remaining looping constructs in JavaScript, the while and do-while loops. We'll start out with the while loop. The while loop is used to execute one or more statements for as long as a condition returns true. The syntax is straightforward. We use the while keyword, followed by the condition to evaluate in parentheses, followed by a block of one or more statements to execute. In this very simple example, we first set a variable called limit, which we initialize with the value 0. This is used in the while loop's condition, where we check that limit is less than 5. Inside the body of the loop, we log the current version of the limit variable while simultaneously incrementing it. When the variable becomes 5, the loop will stop. So let's just check the output in a browser. If we need to stop the loop prematurely, we can use the break statement, just like with some of the other types of loop. And let's just go back to the browser now. As we can see from the log statements, the condition is checked before the statements in the body of the loop are executed. So depending on the condition, the statements may never be executed. Now let's take a look at the very similar do-while loop. The premise of this loop is the same as the standard while loop. We want to execute one or more statements while a condition evaluates to true. What differs is the syntax and the fact that with the do-while loop, the statements in the body of the loop will always be executed at least once, even if the condition evaluates to false to begin with. So let's look at the syntax for this type of loop. This time we start with the keyword do, followed immediately by a block within curly brackets. The while statement then comes after the block and is followed by the condition to evaluate. What this means is that the block will always be executed at least once. Let's check the output in a browser just to verify that that is indeed the case. And we can see that the statements in the block are executed at least once. So in this lesson we looked at the two variations of the while loop, the while and the do-while loop. We saw that they both execute one or more statements while a condition is true. The only difference between them, other than the syntax, is that the statements in a do-while loop will always be executed at least once, but the statements in a while loop may or may not be executed depending on the condition which is being evaluated. We also saw that we can use the break statement to exit a while loop early if necessary. This now brings us to the end of the execution control section. In the next section, section 5, we're going to move on to look at using JavaScript in everyday coding situations. In this section of the course, we're going to take a look at some of the most useful properties and methods that we can use in order to work with the different types of data used in JavaScript, starting with strings in this lesson. So let's see how we can work with strings. We know from earlier in the course that we can create strings as literals or as objects, and we also know that it's best to create them as literals. One interesting feature of JavaScript is type coercion. Not the kind that takes place when used in conditionals that don't compare strictly, but when wrapper objects for strings, numbers, or booleans are created for us automatically by JavaScript when we call methods or access properties on literals or primitives. So first of all, let's define a string that we can work with throughout the rest of this lesson. So in this case, we've declared a simple string literal, which has the value, this is a test string. So even though a string is a primitive, we can call properties and methods on it. One property that strings have is the length property, which tells us how long the string is. And let's just check the output in a browser. And this tells us that there are 21 characters in the test string. And that includes the space characters. So a string is a primitive, and primitives don't have properties or methods. So the fact that we can look at the length property of a string tells us something interesting about JavaScript. Whenever we try to access the property of a primitive or invoke one of its methods, behind the scenes, JavaScript will wrap the primitive in an object. This process is known as boxing. It's not something that you need to worry about. JavaScript boxes and unboxes primitives as and when it needs to, based on what we're doing in our code. It's just interesting to be aware of. So the length property is really the only property of strings that we'll need to work with. There are, however, a lot of different methods that we can use. Let's look at a few of the more common ones now. One thing we can do with a string is turn it into an array, which can be really useful and is something that you'll probably do quite frequently. To do this, we can use the split method. So we pass the split method a single argument, and that argument is the character that we want to split the string on. In this case, we use the space character. So we should get an array with 5 items, because there are 5 words separated with spaces. Let's check the browser's output. We do indeed get an array of 5 items, and the characters that we split on, the space characters, are not included in that array. Another thing that we might want to do quite often is to check whether a string contains another string. We can do this using the index of or last index of methods. The index of method returns the index of the first occurrence of the search string within the context string. So the index of method will return the index that the test string, which we pass to the index of method, is found within the string that the method is invoked on. So in this case, the first index of the substring is at index 2. So just like arrays, strings are 0 indexed, which means that the very first index is 0. So index 2 is here. So index of just returns the index of the first occurrence of the test string. It doesn't return the indexes of all instances. So it doesn't care about the second occurrence of the word is, which is here. If the string that we are searching for is not found within the context string that is being searched, this method returns -1. The last index of method works in exactly the same way as the index of method, except that it starts at the end of the string and works backwards through the string instead of starting at the beginning of the string, like the index of method does. If we use last index of, however, we should see the index should equal 5. Don't forget that the first index is actually index 0 and not index 1. If we want to convert the string into capitals, we can use the toUpperCase method. So one point to note is that toUpperCase doesn't actually change the value of the string that it is called on, it just returns a new version of the string which is all in capitals. There is also a toLowerCase method, which works in a similar way. We can select specific parts of a string using the substring method. This method can take up to 2 arguments, both of them are numbers, and correlate to the index in the string, with the first argument specifying the start index to begin selecting from, and the second argument specifying the end index to stop selecting from. Let's take a quick look. So we passed 8 to the substring method, which indicated that we wanted to start selecting the substring from the 8th index. We didn't specify an ending index, so it selects everything to the end of the string. We can change that so that we do specify an ending index by passing the second argument. And this time it just selects the character A because it only selects a single index. And you can tell from this actually that when we include an end index, that index does become part of the substring that gets returned by the substring method. If either of the arguments that we pass to the substring method are negative or nan values, they are replaced with the value 0. Another way to select part of a string is with the slice method, which operates in a similar way, just with some slight differences. So this works in a similar way to the substring method did earlier when we selected everything from the 8th index. If we pass 2 positive arguments, including 0, the slice method works in exactly the same way as substring. So again, we just select the character A in this case. The difference between slice and substring is that we can provide negative numbers to the slice method. If we supply a single argument to the slice method and it's a negative number, the slice will begin from the end of the string instead of the start of the string. So in this case we just get the last 6 characters because we specified -6. That's the main difference between slice and substring. There are quite a number of other methods that we can use. We won't cover all of them. We'll just look at one more for today. This is the trim method and is used to trim space characters from the start or end of strings. Let's use a different string this time. So notice how we can call the method on the string literal directly. Again, this is thanks to JavaScript's automatic boxing. And let's just go and check the output in a browser now. So we can see that there are no space characters either before or after the string test. This is because the trim method has trimmed them from both the start and end of our test string. So in this lesson we learned about the different properties and methods that we can use to work with strings. I say properties, but actually there's only one property that we'll ever be interested in, which is the length property. We also covered turning a string into an array with the split method and how to find the index of individual characters within a string using index of or the last index of methods. We saw how to convert a string to either all capitals or all small letters with the 2 uppercase or 2 lowercase methods, and we saw how to select different parts of the string with either the substring or slice methods. Lastly, we saw how to use the trim method to remove white space from either the start or end of a string. In the next lesson, we're going to continue looking at some of the useful methods we can use when working with strings. In this lesson, we're going to continue looking at some of the useful methods that strings have. In the last lesson, we saw the trim method, which allows us to remove white space from the start and or end of a string. As well as the trim method, we also have the trim start and trim end methods to individually remove white space from only either the start or the end of a string respectively. Like the trim method, trim start doesn't take any arguments and returns a modified copy of the original string rather than changing or mutating the original string. In this case, white space is only removed from the start of the string. If the target string doesn't contain any white space characters at the start, a copy of the original string is still returned. The trim end method works in exactly the same way and the same caveats apply, just to white space characters at the end of the string. Moving on, let's now look at the pad start and pad end methods. These two methods are used to insert a specified string at either the start or end of a string. Both the pad start and pad end methods accept up to 2 arguments. The first argument, which is mandatory, is the length that we would like the string to be padded to, which means that the actual number of times the padding string will be added will vary depending on the length of the original string. For example, in this case, the string the method is called on is 4 characters long, and the length we would like to end up with is 7. Therefore, the padding string will be inserted 3 times. The second argument is optional and is the string we would like to use as the padding string. If this is not specified, a whitespace character will be used, but we can use any string value here. Like the trim methods, the pad methods return a modified version of the string on which they are called. The pad end method works in exactly the same way as pad start, it just pads the end of the target string rather than the start. Some more useful methods are the replace methods. First, we have the basic replace method, which is used to replace a string within a string. The first argument is the string we would like to replace within the target string, and the second argument is the replacement string. Both arguments are required. One thing to note is that if the target string contains multiple instances of the string we would like to replace, only the first occurrence will be replaced. This is exactly what the other method, replaceAll, is designed to handle, and we'll come back and look at that method in just a moment. The replace method is not actually basic at all. The arguments that it can be passed and the things it can do are surprisingly flexible and powerful. We aren't going to cover the more advanced uses of this method today because it uses things like regular expressions and pattern matching, which we won't be covering until much later in the course. Coming back to the replaceAll method then, as I mentioned, this method is useful for replacing all occurrences of the string we want to replace instead of just the first. The usage is identical to the replace method that we looked at before, and like the replace method, replaceAll has a whole plethora of more advanced uses than we've seen today. So in this lesson we looked at some additional string methods that we can use to manipulate and work with strings, including the trim start and trim end methods, which we can use to trim whitespace characters from only the beginning or end of a string. We also looked at the pad start and pad end methods, which allow us to pad a string to a specified length by adding an optionally specified string to the start or end of a string. Lastly, we took a look at the replace and replaceAll methods, which can be used to replace a single or all occurrences of a string within another string. In the next lesson, we'll look at a different type of string, the template literal. In this lesson, we're going to look at another type of string. Template literals are a fairly new type of string literal, which were introduced in ES 2015. They support multi-line strings and expression interpolation, which basically means replacing tokens within a string with values. Let's take a look. To create a template literal, we use backticks. So far, this is just like a regular string in every way. So, one thing we can do with template literals is include line breaks inside them without using the new line character. So that is equally valid. In template literals, all characters, including whitespace, are significant. This isn't groundbreaking, but it does mean that we can create strings that include line breaks without having to use escape characters. The above code example is much more readable than the escaped alternative, which would look something like this. Another feature of string literals is interpolation with data. We can evaluate expressions inside the string. The syntax for this is the $ character followed by the expression within curly brackets. The tokens inside the curly brackets are replaced when the template is evaluated at runtime. Because template literals have access to variables and objects in our code, they should be handled carefully and must not be constructed by untrusted users. And let's just check the output in the browser. We aren't limited to simple variable substitution either. We can use functions inside the tokens if we wish. One of the most powerful features of template literals are tagged template strings. These strings are tagged with a function name, and this allows the function to be called and passed all of the different parts of the string when it is interpolated, for full control of how the string is constructed. So first of all, let's define a new function. When the function is invoked, it will be passed an array of all of the regular string parts of the template literal as the first argument, and then a series of additional arguments for each of the tokens within the template. Notice how we use the spread operator, which we learned about earlier in the course, to collapse all of the remaining arguments after the first one into a single array called values. So now we can tag a template literal with our function by prepending the name of the function to the template string. If we use a similar template string as the previous example, the tagging function will be passed an array containing 4 items as the first argument and an array of 3 items as the values parameter. In this case, we can just build the same string that we were building before. So the function that we defined, which we tagged the template literal with, should return the value of the evaluated string. We can use the function to make any kind of transformation to the string that we want. For example, we could swap the order of the tokens. And now let's check the output in our browser. This time the order of the strings and tokens is completely different. So in this lesson we learned about template literals. We saw that we need to use backticks instead of single or double quotes to define the template literal. And we saw that template literals are just another form of string literal with some extra powers. We saw that we can create multi-line strings without explicit newline characters, and that we can perform simple token substitution. We also saw that tagging template literals with a function is a powerful way to handle token substitution and gives us full control over the final form of the string. In the next lesson, we'll look at working with numbers in JavaScript. In this lesson, we're going to look at numbers. Like strings, numbers are another type of primitive. And also like strings, they have a number of properties and methods for working with them. And that's what we're going to focus on today. The number object contains some properties that represent different values in JavaScript, like max underscore value, min underscore value, max underscore safe underscore integer, and min underscore safe underscore integer, which are the maximum and minimum values and safe values that it is possible to use in JavaScript. There is a special number in JavaScript called nan, which is produced when we try to do something with a number which is not possible, like multiplying it by a string. The problem with nan values is that they ruin any mathematical calculations that you're trying to perform, and they are very hard to detect, because nan is not equal to anything, not even itself. So this makes it very hard to test for in a conditional. To overcome this, we have the isNan method, which we can use to detect when a value is nan. Let's take a look. And let's check the output now in our browser. And we can see that that has resulted in a value of true. So isNan is a static method which is invoked directly on the number object, rather than on number instances. We also have the static methods isFinite, isInteger, and isSafeInteger for performing other checks on numbers. The last two static methods are very commonly used. If we want to convert strings into numbers, there are two more static methods that we can make use of. parseFloat for parsing floating point numbers from strings, and parseInt for parsing integers. Let's take a look at how these two work. So here we've defined two strings which happen to contain numbers. Let's convert them directly into numbers instead of strings. So they look like numbers, but let's use the typeOf operator just to be certain. And we can see that they are both numbers. The strings that we're parsing from don't have to just contain numbers. They can also contain numbers and letters, and these two methods should still work in the same way, depending on where the numbers occur. And we can see that we have still managed to extract the numbers from those strings, even though the strings contain more than just numbers. However, in order to parse numbers successfully from strings, the numbers need to come at the start of the string. So when we add non-numerical numbers to the start of a string before any numbers occur and try to parse those numbers out of it, we'll get the value not a number. And just to highlight how dangerous the not a number or nan value is, let's just go back and add typeOf again to the start of the first console log. And it misleadingly tells us that we're still working with a number because the nan value is a type of number. So we have to be very careful when parsing numbers from strings to make sure that we don't end up with this nan value. As well as the static methods that we've looked at so far, number instances also have several methods that can be used to work with the number in some way. For example, to convert a number to have a specific number of decimal places, we can use the toFixed method. So we've invoked the toFixed method on our number instance, and we've passed it the argument 2. So it should truncate the number down to 2 decimal places. Let's just check the output in our browser. And as you can see, that has worked. And the rounding that has occurred is probably what you would expect from regular mathematics. As well as toFixed, we also have toExponential, toLocalString, toPrecision, and toString methods. The toFixed and toPrecision methods are very similar. The difference between them is that toFixed rounds to a fixed number of decimal places, while toPrecision formats a number to a given number of significant digits. So in this lesson we looked at numbers. We saw the static properties and methods that we can use from the number object directly, and we also saw some of the instance methods that we can use with number instances. In the next lesson, we're going to look at a data type called BigInt, which is used to work with very large integers. In this lesson, we're going to take a look at a data type called BigInt. As we saw when we learned how to work with numbers in JavaScript, JavaScript has a maximum safe value that it is able to represent and operate on as an integer. The number type has a property called max safe integer, and its value is 2 to the power of 53 minus 1, which is a little over 9 quadrillion. In this context, safe means the ability to represent exactly and be able to compare correctly. For example, if we try to compare some values that are greater than max safe integer, JavaScript will report that they're the same even though they aren't. When working with numbers greater than max safe integer, workarounds such as representing very large numbers as strings or using third-party libraries were needed. BigInt is the official solution to working with very large numbers that negates the need for either hacks, workarounds, or additional third-party dependencies. BigInt is used to safely work with integers that are larger than JavaScript's max safe integer value. Like number values, BigInt values are primitives and can be created using either the BigInt constructor or in literal form. Let's take a look. Now the variable very large number contains the value 9007199254740992 as a big int. Note that we don't use the new keyword when using the constructor. Also note that we can pass strings to the BigInt constructor as well. The two variables will contain exactly the same value. To create a literal BigInt, we simply append n to the end of an integer. We can also create BigInts with hex, binary, or octal syntax using either the constructor or the literal form. Using BigInt, we can now correctly compare values that are larger than max safe integer. Notice that BigInts aren't restricted to very large numbers. Here we are creating BigInts with the max safe integer value as well as the relatively small values 1 and 2. There is no maximum limit for the size of a BigInt either. We can use all standard operators with BigInts except for the Unary operator and the zero fill right shift operator. But we should make sure that all values we want to operate on are BigInts, or we'll see an error. Instead, we should convert any regular numbers to BigInts also. When dividing BigInts, remember that no fractional part will be retained by the BigInt. We can also compare BigInts, and here we can mix BigInts and numbers. BigInts are loosely equal to numbers, but not strictly equal. Bear in mind that BigInt values cannot be used with any of the math object's built-in methods. Some of them aren't really applicable anyway, like floor or seal or round, but even others like squirt will also produce errors. BigInts can also be used in conditionals and are treated similarly to numbers. BigInts have a few methods available for us to use, including toLocaleString, toString, and value of. One good use for the toString method is to make BigInts serializable to JSON. BigInts don't work with JSON.stringify out of the box. We can easily add our own implementation to BigInts prototype if necessary. This will then allow us to stringify BigInts as expected. Once serialized as JSON, it looks just like a regular number in string format. And of course, if we JSON.parse it, we'll get a straight number back, unless we use the result of the parse as the argument to the BigInt constructor. So in this lesson we learned about the BigInt type and saw that we can use it to work with numbers outside of JavaScript's maximum or minimum safe integer range. We saw that we can create BigInts using either the constructor or in literal form by appending n to the end of a number. We saw that we can use BigInts with most of the standard operators and in some of the same places that we can use numbers, such as in conditionals. Lastly, we learned that BigInts are not directly compatible with JSON's stringify method, but that we can make them so very easily using BigInt's toString method. In the next lesson, we'll move on to look at how we can work with arrays. In this lesson, we're going to look at the different properties and methods that we'll use most frequently when working with arrays. Just like strings and numbers, arrays have a wide range of different properties and methods that let us manipulate them. First of all, let's just add a basic array that we can work with throughout this lesson. Just like strings, arrays really only have one property that we'll ever use, the length property, which tells us how many items there are in the array. For our test array, the length is 3. Don't forget that arrays have 0-based indexes. So let's move on to look at the methods which arrays have, of which there are many. If we want to add a new item to an array, we can use the push method. In this case, our array will now contain 4 items. The items that we want added to the array are passed to the push method as arguments, and we can add as many arguments as we need. The method returns the new length of the array, and the new items are added to the end of the array. If we want to add a new item to the start of the array instead, we need to use the unshift method. Again, we can pass multiple arguments to the unshift method if we want to insert multiple items. And again, this method returns the new length of the array. If we want to remove the last item from the array, we can use the pop method. This will remove the last item from the array and return the item that gets removed. We can also remove items from the start of the array if we need to, using the shift method. If we want to remove items from within the array rather than from the end or the start of the array, and optionally insert new elements, we can use the splice method. The splice method can take a number of different arguments. In this example, we've only provided the first argument. When we only provide the first argument, all items from the index of the argument that we provide right to the end of the array will be removed. So passing 0 to the splice method should result in all of the items from the array being removed. The second argument, if we do supply it, is the number of existing items that we want to remove. So let's just change the previous expression, and instead of removing all of the items from the array, let's just remove 2 of them. This just leaves us with the final item in the array, the string 3. Following the second argument to the splice method, we can insert new items into the array by passing them as additional arguments. So let's use the splice method to replace all of the items within our test array. So we'll provide 3 as the second argument to say that we want to remove 3 items, and the array at this point just contains 3 items, so that will empty the array completely. And let's add 3 new items to the array. So now all of the original items from the original array have been replaced. We can reverse the order of the items in the array if we want. We can do this using the reverse method. The reverse method is another simple method that doesn't require any arguments. All of the methods that we've looked at so far change the underlying array permanently and are therefore referred to as mutator methods. There's one more that we haven't covered, and that's the sort method. Let's take a look at this one next. The sort method sorts the items in an array. If we use the method without passing an argument, it uses its default lexicographic sort. This sorts in alphabetical order, but it uses Unicode, so it might not always work as we expect. In this case, because we're working with 3 lowercase letters, it does get sorted as we would expect. Let's just go back and make one of the letters uppercase. In this case, the sorting doesn't quite work in the way that we would expect. And this is because, as I mentioned, it uses Unicode to sort. Uppercase letters in Unicode have a lower code number than lowercase numbers do. And so when we use the default sort, the uppercase C gets sorted to the first item in the array. That's probably not what we would want or expect. Sorting with numbers can be just as confusing. That is probably completely backwards from what we were expecting. To fix this, we need to perform a custom sort. To do this, we can pass a comparison function to the sort method, which encapsulates the sorting logic that we want to use. What we do inside the comparator will depend on the type of values that we want to sort. The comparator function will be passed two values from the array each time it is invoked. Conventionally, we call these A and B. To sort simple numbers, we can just subtract B from A. Let's go back to the browser now and take a look. As we can see, this has sorted the numbers into probably the order that we would expect the default sort to sort them into. So the comparator function needs to return a negative number if A is less than B, 0 if the two values are equal, or a positive number if B is greater than A. That's why subtracting B from A works and gives us the sort that we were expecting, from smallest to highest. Sorting strings with a custom sort function is slightly more complex. First of all, we'll need to put all of the strings that we want to sort into lowercase. So now we need to return either -1, 0, or 1, depending on whether B is less than A, equal, or greater than. So this should be all the sorting logic that we need for this example. Let's go back to the browser and see if it works. So now we can see that regardless of the fact whether C is uppercase or lowercase, it still gets sorted into what we would probably expect to be the correct position. So as well as the mutator methods that we've looked at so far, there are also a range of accessor methods. These methods don't alter the underlying array that they are operating on, but instead return some subset of the items in the array as a new array. For example, when we looked at strings earlier in this section, we saw that there is a way for us to turn a string into an array. Arrays have a method that turns an array into a string, the join method. So we can see that the items in the original array, CAB, have been turned into a single string. The join method accepts a single argument, and that is the character that we'd like to use to join the items in the array. In this case, we've specified no character, and we saw that the individual letters are just joined together. We can change this if we like to use a different separator character. We can change this if we like to use a different joining character. And now the pipe character is used to join them. If we want to test whether a particular item exists inside an array, we can use the index of or last index of methods. These methods work in the same way that they do with strings, and return either the index of the item if it is in the array, or -1 if it isn't. The index of method checks from the start of the array, while the last index of method checks from the end of the array. Only the index for the first or last item is returned, so it can't be used to check if the array contains duplicates. Like strings, arrays also have a slice method, and this returns a new array consisting of the items between two specified indexes. So the argument that we pass to the slice method is the index that we want to begin slicing from. In this example, we passed 1. And so we start slicing from the second item. And because we didn't provide a second argument, the method will slice all the way to the end of the array. If we do provide a second argument, that is the index of the item that we want to stop slicing at. So now the returned array just contains a single item. If the second argument is a negative number, then slice will start slicing the array from the end of the array rather than the beginning. So in this lesson we started out by looking at the length property, which tells us how many items there are in an array. We then moved on to look at the mutator methods, which included how to add and remove items from the start or end of the array, and how to insert new items at either the start or the end of the array. We also saw how we can add or remove items from within the array using the splice method, and we saw how to reverse or sort the items in an array using the reverse or sort methods respectively. We also looked at some of the accessor methods that are available, including the join method for converting an array to a string, the index of and last index of methods for finding the index of an item within the array, and the slice method for returning a new array containing some or all of the items in the original array. In the next lesson, we're going to continue looking at some of the many array methods. In this lesson, we're going to continue looking at arrays, this time focusing on some of the many iteration methods that arrays have. As well as being used with for and for of loops, arrays themselves contain methods that iterate them in different ways. For basic iteration, we can use the for each method. So the for each method is called on an array, and we pass a callback function to this method. The callback function will be invoked for each item within the array and is passed the current item each time it gets invoked. In this case, we just log it to the console. Unlike the for or for of loops, it's not possible to exit from a for each loop early. It will always visit every element in the array. If we do want to only partially iterate the items in the array, we do have some other options. We could use the sum method instead. The signature of the sum method is similar to the signature of the for each method. It's still a method that is called on array instances, and it still gets passed a callback function. This callback function is passed the current item from the array each time the callback gets invoked. The difference between sum and for each is that the sum method will iterate the array that it is called on until the callback function returns true. In this example, that will be on the second iteration. So let's check the browser's output this time. This time we only see 2 console logs, and that is because the callback function returns true when the current item equals y, and that is the second item in the array. And it's at that point that the sum method stops. The sum method itself will return true once it stops iterating. If the callback that we provide doesn't return true at all, the method will return false. The opposite of the sum method is the every method. This method works in exactly the same way as the sum method, except that it stops iterating the array when the callback function returns false. Let's check the output for this one. This time we only see 1 console log. We only see 1 console log because as soon as the every method invokes the callback function for the second item, that item will not equal x, and so it will return true and the every method will stop iterating. Another useful method is the reduce method, which reduces an array down to a single value. Let's use a new array for this example. Like the other methods that we've looked at so far, the reduce method is passed a callback function. This callback function will be passed the value returned by the callback on the previous iteration, as well as the current item in the array. In this example, we just return the sum of the previous item plus the current item. As well as passing a callback function, we also pass a second argument to the reduce method. This argument is the value that the previous argument to the callback function should have the very first time the callback function is invoked. So let's take a look at the output. So basically what we've done is use the reduce method to sum all of the numbers in the array. One of the most powerful iteration methods that arrays have is the map method, which is used to map an array into another array. In this example, we first added an object of references which associates a letter with its equivalent in the Greek alphabet. We then have an array containing the values a, b, c. Like the callbacks passed to most of the methods that we've looked at in this lesson, the callback can receive up to 3 arguments. The first argument is the current item, and it will also receive the index as the second argument to the callback, as well as the original array as the third argument. Although we don't actually use these in this example, they are available if you need them. So the callback function will be invoked for each item in the array that it is called on. Whatever we return from this callback on each iteration will end up as a new element in the new array that the map method returns. So let's take a look at the output. So we've mapped the first array, ABG, into a new array containing alpha, beta, gamma. So the map method takes an array and creates a new array by iterating the original array. We can modify the values from the original array and transform them, or create entirely new elements for the new array, just like we did in this example. So in this lesson we looked at some of the methods that all arrays have for iterating through the items in the array. We looked at the basic for-each method first, which simply visits each item in the array and invokes a callback function for them. We then moved on to look at some variations of this behavior, such as the sum and every methods, which iterate the array until the callback function returns either true or false, respectively. We also saw the reduce method, which reduces the array values down into a single value. And lastly, we looked at the map method, which maps one array into another array. All of these methods can be extremely useful when working with arrays, so it's good to understand them well. In the next lesson, we can look at some of the useful properties and methods that we can access through the object type. In this lesson, we're going to continue looking at some of the many methods that arrays have to make working with arrays easier and more powerful. The first method I want to look at today is the includes method. The includes method is a convenient way to see if an array contains a particular element. Let's look at a quick example. Let's say we're working with this example array. The includes method is used to determine whether the array contains a particular value. In this case it returns true because the array does contain the string apples. You should note that in this case the string must match exactly, so passing apples with a lowercase a will return false. The first argument to the includes method is the thing that we want to see if the array contains. The method also has a second argument, which is the index of the array that we would like to start searching from. As the string apples is at index 0, when we start searching from index 1, the string is not found and the method returns false. Now let's move on to look at a method called flat. The flat method is used to flatten an array that contains subarrays, effectively unwrapping subarrays and inserting their contents as individual array elements in a new array. Let's use a different array to test this method. This array is similar to the one that we used before, but the third element in the array is also an array, which itself contains 2 elements. An array that contains other arrays is called a multi-dimensional array, by the way. To turn this into an array of just a single level with no nested arrays inside, we can just call the flat method without any arguments. By default, only a single level of array nesting will be unwrapped. If we have an array which contains an array which contains another array, only the first level is flattened by default. As you can see, the second level array items remain as an array in the output of the flat method. If we do want to flatten deeper levels within the array, we can pass an integer to the method specifying the depth of the flattening. So to flatten the above array, we just need to pass 2 to the method. Now the flat method will flatten 2 levels down, and our array is flattened with no nested subarrays. There is no limit to how many levels we can flatten either. And if we don't know how many levels we might need to flatten, but just want to make sure all levels are flattened, we can even pass the special value infinity to it. So in this lesson we looked at a couple more array methods. We started out by looking at the includes method, which is a convenient and easy way to see if an array contains a specific item without having to inspect each element in the array manually. We then moved on to look at the flat method, which allows us to unwrap multi-dimensional arrays either to a single level or to any specified level of nesting up to and including infinity. In the next lesson, we can look at some of the useful properties and methods that we can access through the object type. In this lesson, we're going to look at some of the properties and methods that we have available through the object constructor. So let's start with the prototype property. All objects in JavaScript are descended ultimately from the object constructor, and the properties and methods that it has access to are inherited from this prototype object. This object is considered a live object, so if we modify properties or add new properties or methods to it, all other objects that are descended from it will inherit them. Let's take a look at an example. So let's just see the output in a browser and then we'll talk about what actually happened. So first of all, we created a brand new object literal and we didn't add any properties or values or anything to the object at all. We then used the uppercase O object to access the prototype of all objects. And we added a new property to the prototype called mySpecialProperty, which we set to a string which just says special. We then logged the new property that we added to the object prototype, mySpecialProperty, via the new object literal that we created, new obj. And as you saw from the console, we could access this string special even though we added it to the prototype after we defined our object literal. It still inherits it from the prototype. And that's what I mean when I say that the prototype is considered a live object. We can also make use of the prototype property when working with other types of objects in JavaScript, like numbers or arrays. For example, if we wanted to add a new method to all arrays called head, which just returned the first item in the array, we could do this. And we can see that it has pulled out the first item from the array. So let's look at exactly what we did in this second example. So we first defined a new array instance which contains 3 items. We then modified the prototype of the array constructor, so that's array with a capital A, to add a new method called head. This method just returned the first item on the array that it is being called on. And in this context, that's what the keyword this refers to. This refers to the array that the method is being called on. Don't worry too much about this for now. We're going to come back and look at the this object in much more detail a bit later on the course. And on the last line of the example there, you can see that we invoke our new head method on the array instance that we created. And when we saw the output in the browser's console, we could see that it simply outputted the first element from the array, the number 1. So the prototype is very, very powerful. And we need to be very, very careful when we're updating the prototype of any of JavaScript's built-in or native types, just in case we overwrite a method that already exists. Some developers take a very strong stance against modifying the prototypes of any of JavaScript's built-in objects. Sometimes, however, it can be useful to add a polyfill for a method which is supported in some, but not all, browsers. In this case, we would check whether the property already existed before trying to add it. So let's just make our previous example a little bit more defensive and robust, just in case JavaScript does decide to add a head method to arrays in future. Messing with the prototype is both powerful and potentially problematic, so do make sure you understand the implications of using it fully before you proceed with it. Going back to the object constructor now, the prototype property is really the only property that we'll ever use. So let's move on to look at some of the methods which are available through the object constructor. A very commonly used method is the keys method. This method returns an array containing just the keys from the object which it is called on. This is very, very useful because it means we can use it with a for each array to iterate over an object's properties while ignoring any properties that might be coming from the object's prototype. So first of all, let's add a new object. So we've defined a new object literal, again called new obj, which just contains a single property which has a key called prop1 and a value of the string property1. Now let's use the keys method to iterate just the own property prop1, which we added to our object literal. And let's check the output now in the browser. And we can see that we have managed to extract the value of an object using for each, when usually for each only works with arrays. So the keys method is called directly on the object O constructor. And we pass the object whose keys that we want to get as an argument to the keys method. If we were to go ahead and add a new property to all objects via the object constructor's prototype, when we go back and check the output in the browser, we find that it is still only logging property 1. Even though our object literal will contain this test property, the test property is inherited from the prototype of the object constructor, and so the keys method will completely ignore it. So this is a useful way of filtering out properties that might be inherited from an object's prototype, and it means that we can avoid using the hasOwnProperty check that we used earlier in the course. Another thing that we can do is freeze an object, and that prevents any other code from deleting any of the existing properties or changing any of their values. So to do this, we use the freeze method of the object constructor. The freeze method is simple to use and just takes a single argument, which is the object that we want to freeze. Once an object is frozen, we cannot add any new properties to it. So let's see what happens when we run this in a browser now. So this time we see an error again, but unlike the previous errors that we've seen in this lesson, this is a genuine error, and the error is coming from the fact that we're trying to add a new property to a frozen object. So when an object is frozen, it is classed as being not extensible. We can't extend it with any new properties or values. And we'll see the same error message if we try to alter the value of an existing property. To avoid seeing errors in the console like this, we can check whether an object is frozen using the isFrozen method. So let's just make our code a bit safer and avoid that error. So now let's go back to the browser again. This time we can see that the error has been avoided. We're using the isFrozen method, which is another method of the O object constructor. And again, we pass the object to the method that we'd like to test. And with the if statement, we're saying execute the block of code if the object is not frozen. That's what the exclamation mark at the start means. So in this case, the object is frozen, so we don't try to add the new property and we don't see the error in the console. Once an object becomes frozen, it can never be unfrozen again. There is no unfreeze method. What we would have to do in this situation is to create a new object and copy the properties from the frozen object to the new object. We could do that using the keys and for each methods that we looked at earlier on. As a quick example to test your own knowledge, why don't you see if you can do this? Similar to the freeze method, but not quite as severe, is the seal method. When we seal an object, we can change the values of existing properties, but we can't delete them and we can't add any new properties. We also can't change a regular property into a getter or a setter. We haven't covered these yet, so don't worry about them too much for now. So to seal an object, we use the seal method. At this point, we can still update the value that the new obj object contains. And we shouldn't see any errors in the console if we go back to the browser. But if we try to delete a property or add a new one, we will see an error because sealed objects do not allow this. So we can see the message that we can't delete the property prop1 of the object. If we want to test whether an object is sealed, we can use the isSealed method, which works in a similar way to the isFrozen method. So if we wanted to prevent the error that we just saw in the console, we could just use the isSealed method in a very similar way to we used the isFrozen method earlier. And as before, the error message goes away. Slightly less extreme even than the seal method is the prevent extensions method, which simply prevents any new properties from being added to an object. We can change existing properties and we can delete existing properties. We just can't add new ones. So if we try to add a new property to the object, we see a message saying that the object is not extensible. And now we can make the error message go away by checking whether the object is extensible before we try to add any new properties to it. So in this lesson we looked at some of the different methods that we can use which are available from the object constructor, and that's object with a capital O, not a lowercase o. We first looked at the prototype property, which allows us to add new properties and methods to existing objects that may already have been created. We then looked at the keys method, which we saw returns an array containing only the keys from an object. And we saw that this can be useful for filtering out properties that the object may have inherited from its prototype. We then looked at how we can lock down objects to prevent them from being changed using the freeze method. And we looked at different levels of control over this that we have, including sealing an object and just marking it as non-extensible. We also saw how we can check for these different object states using isFrozen, isSealed, or isExtensible. In the next lesson, we're going to look at some conveniences that we can make use of when using object literals. In this lesson, we're going to look at some cool things we can do when defining object literals. One feature is a shorter syntax for defining object properties that we saw when we looked at objects earlier on in the course. Let's look at that first. Instead of specifically setting properties and values, we can simply supply the value and the key will be created for us automatically. Let's take a look. So let's start out by defining a couple of variables. So later we might want to create a new object literal which contains these values. In previous versions of JavaScript, we would have had to do something like this. So we've defined an object literal called obj, and we want it to have two properties, one with the key x and one with the key y, and we want to give the x key the value of the x variable and the y key the value of the y variable. So in this case it's not too bad because the key names and the variable names are quite short, but there is a lot of duplication there, and if we were adding more variables and we wanted to use longer key names and we had different variable names, there could be a lot more repetition. So in the latest version of JavaScript, we can shorten that to just do this instead. When the key name is the same as a variable name, we can just supply that once and JavaScript will figure it out for us. And let's just log it to the console to ensure that it's working in the way that we expect. And we can see that our object has been created and it has x and y keys and it has the values of the x and y variables as we would expect. So we've saved ourselves a bit of repetitive typing, which can be useful. It seems like a small thing, but in regular day-to-day JavaScript, it can save you a lot of repetition. And that's really why this feature was introduced. Another time-saving and repetition-saving addition is a new way of defining methods. So in earlier versions of JavaScript, if we wanted to define a method, which is simply a function attached to the property of an object, we would have had to have done something like this. So in this case, we've defined a new method on our object, and this method is stored in a property simply called method, and we have to use the whole function keyword. So if we were adding a lot of methods, we'd have to repeat that function keyword over and over again. Well, in the latest version of JavaScript, we can get rid of that function keyword altogether, and that allows us to do this instead. So we simply add the parentheses after the method, and we don't have to worry about the function keyword at all. So again, in this case, it hasn't really saved us much time or effort, but if we were adding lots and lots of methods to this object, it would save us a considerable number of keystrokes. And it just looks a bit nicer and it's a bit easier to read. One other new feature that we have with objects is having computed property names. So in this case we use square brackets to say that we want the key name to be a combination of the x and the y variables concatenated together. And let's just look at the output in the browser. And we can see that our object now has a key called test42, which is the output of computing x plus y. Again, a small thing, but it can be very useful. Before we finish up for the day, let's just take a quick look at another static method that we can make use of from the built-in object constructor that we looked at in the last lesson. This is the assign method, and we can use it to assign the properties of one or more objects to another object, a bit like jQuery's clone method. Again, this is largely provided as a syntactic convenience to avoid having to copy the properties of objects to new objects manually. So let's take a quick recap of what we've done here. We've created a new object called composed.obj, and we've used the object.assign method. This method takes 3 parameters in this example. This method takes 3 arguments in this example. The first argument is an empty object. So this is the target object. This is the object that the method will return. The second and third arguments are the objects that we'd like to merge together. So we're merging our obj example object and then a new object literal that just has a single property called some other prop. And we can see that this new object is a combination of both our existing example object and the new object literal that we passed as the third argument. If the target object already contains a property that one of the other objects contains, it will be overwritten with the property from the last object that we passed. So in this lesson we looked at some mostly syntactic improvements to object literals, including the shorthand for assignment, where when the key name and the variable that we'd like to add to that key are the same, we can just provide one of those, we don't have to duplicate them. And we looked at computed properties. We finished up by taking a look at the assign method, which can be used to merge two objects together to form a new object. In the next lesson, we're going to move on to look at object instances. In this lesson, we're going to see some of the properties and methods we have at our disposal when working with object instances. Because objects are extensible, we can add any properties or methods to them that we want. But even if we create a brand new object literal, it will still inherit properties and methods from the object constructor. This is what we'll be looking at in this lesson. So first off, let's create a brand new empty object. First of all, let's take a look at the constructor property. This property tells us the constructor function that created the object. And let's review the output in a browser. So we can see here that the constructor that created our object literal was actually the object with a capital O constructor. Other things like arrays, strings, and numbers also have a constructor property which shows the constructor that created them. When writing object-oriented JavaScript, we'll often make use of this property to specify the constructor function for a custom object, but in simpler situations we often don't need to use it at all. The constructor property is a property of object instances. One instance method that all objects inherit, and which we saw briefly earlier in the course, is the hasOwnProperty method, which we can use to check whether an object contains a property as a defined own property and not one that it inherits from its prototype. Let's just look at another basic example of this method in action. We already know that our object instance will inherit a constructor property, as we saw in the previous example. So let's test for that. And as we can see, the constructor property is not a defined own property of the object literal. It's a property that is inherited from the object constructor. The hasOwnProperty method will also return false for any property that the object does not have directly defined on it. For example, in this case, the method reports false again, even though it doesn't have any property called random property. It doesn't have it defined and it doesn't inherit it. But the code doesn't blow up, the browser just reports false. Now let's add this new property to the object instance. And if we go back to the browser now, we can see that the second log statement is true because the object does now have an own property called random property. Another method we can use is property is enumerable, which tells us whether the property will be iterated if the object is used with a for loop. So let's test the constructor property first of all and see whether that property is enumerable. And we can see that it reports false. And what that means is that the constructor property will never be shown when we iterate through the properties of my object using something like a for in loop. Let's now test our own random property that we added to the object literal. For this property, it reports true. So the random property will be picked up if we use a for-in loop on myObject. By default, when we add properties to an object literal, they are automatically enumerable. Another method which all objects inherit is the toString method, which returns a string representation of the object. And we can see that we see object followed by object with a capital O. And what this means is that we're working with an object literal which was ultimately created by the capital O object constructor. So remember way back in the course when we looked at the type of unary operator, right back in section 2, and we saw that if we use type of with an array, it actually reports object. And I said that there was a better way to determine if we're working with an actual array as opposed to a generic object. This toString method is how we can do that. Let's see a basic example. This time we can see that the toString representation of an array literal is object, because ultimately an array is a type of object, but the second item is an array with a capital A, because arrays, all arrays, even array literals, are ultimately constructed by the array constructor. So we've invoked the toString method in a slightly different way than we've invoked some of the other instance methods that we've looked at in this section. And we've invoked the method via the prototype and using the call method. The reason why we've had to do it this way is because if we call the toString method on an array directly, the method will return all of the items within the array joined together. So in this case, it's an empty array and there are no items to join, so it will just return an empty string, unless we go via the object prototype, as we have done in this case. So in this lesson, we looked at some of the different things that we inherit automatically with any object instances that we're working with. We looked at the constructor property, which shows us the constructor that created the object, and the hasOwn property is enumerable, and toString methods, including a useful way to check whether an object that we're working with is really an array. In the next lesson, we're going to look at getters and setters in objects. In this lesson, we're going to look at some additional methods of the object type that can be useful for working with objects. Let's start with the values method. The values method returns an array containing all of the values from a given object. We can use the same example object that we used previously. So now to get an array of just the values from the object, we can use the values method. Notice that we call this method on the global object and pass in the object instance that we want to get the values from. Bear in mind that this method only operates on own properties of the object, so it won't go through the object's prototype, and it only operates on enumerable properties. If the object we pass to the values method doesn't contain any enumerable own properties, it will return an empty array. Now let's look at the entries method. This method returns an array containing subarrays for each property and value pair in the object. If we use the same test object as before, this time the result will be an array containing two subarrays. The first subarray will contain two strings, both x, and the second array will contain two strings, both y. Each key in the object is always a string, so the first item in each subarray will always be a string, even if we use numbers or something else in the object definition. The second value of each array will be whatever the property value is, and each subarray will always have exactly two items in it. There is also a from entries method, which is pretty much the diametric opposite of the entries method that we just looked at. This time, if we pass this method an array containing subarrays of exactly two items in length, where the first item in each subarray is a string and the second item is of any value, then JavaScript will give us back a plain object. We don't have to use an array here, we can use any iterable type, so we could pass the from entries method a set or a map as well. Last of all for today, let's look at the getOwnPropertyDescriptor and getOwnPropertyDescriptors methods. These methods are used to get information about a single property or all of the properties of an object. Let's take a look. In JavaScript, object properties have a descriptor, which is an object containing information about the property, such as whether it's writable, whether it's enumerable, and so on. This method takes two arguments. The first is the object, and the second is the property key that we would like to get the property descriptor for. Following on from this is the very similar getOwnPropertyDescriptors method. This is similar to the other method, except that it just gives us the property descriptors for all of the object's own properties. This method returns an object where each property key matches a property key from the original object, and each value is the property descriptor object for that property. So in this lesson we looked at some additional methods of the global object that we can make use of. We first saw the values method, which gives us a flat array containing all of the values from the object passed to the method. We then moved on to look at the entries and from entries methods. The entries method is passed an object and returns an array containing subarrays of exactly two elements, where the first element represents the name of the property key and the second element represents the property value. Conversely, the from entries method is passed an array containing subarrays of exactly two elements, where the first element is a string and the second element can be of any value. But this method returns an object. Last of all, we looked at the getOwnPropertyDescriptor and getOwnPropertyDescriptors methods, which can be used to either get the property descriptor object for a single property or the property descriptors for all of an object's own properties. In the next lesson, we're going to look at object getters and setters. In this lesson, we can take a look at adding getters and setters to properties that we create in object literals. Getters and setters are special functions that are invoked automatically whenever a property is accessed or assigned to. Let's start by looking at getters. We can add a getter using the get keyword in front of the property name. So in this example, we create a regular object literal called myObj. We give it a regular property with the key otherProp and the value other in string format. We then add a new property called prop, but we use the get keyword in front of the property name. And notice how the property actually looks like a method. In this example, we'll just log to the console and then return the value of the otherProp property. So now, whenever we access prop, it will invoke the getter. And let's review the output in a browser. So we see our log message, and then the getter property actually returns the value of otherProp, which in this case is the string other. Inside our getter, we can perform whatever logic we want. Although, as I said, in this case, we just log a message to the console and then return a different property value. Again, inside the getter, we've used the special object called this. We will come back to this shortly in the next section. In this context, just understand that this refers to the object myObj. So now let's take a look at setters. We can add a setter for the same property that we have a getter for. So a setter looks very much like a getter, except that we use the set keyword instead of the get keyword, and a setter will receive a value, and that is the new value that is being set to the property. So in this basic example, we can just do another console log, and we'll just log out the value that we are setting. And on the last line inside the setter, we set the value of other prop to the new value. So we see the log message from the setter, and below that we can see a log of the object, and we can see that the other prop property has had its value set to new. It's important to understand, however, that the other prop property that we've been working with is not hidden or protected in any way just because we're using a getter and a setter with it. We can still access other prop directly if we want to, but if we are building something to be used by other developers, like a widget or a plugin for some framework, we only need to publicize the property that has the getter and the setter attached to it, and not the property that the getter and setter operate on. We don't have to use a different property if we just want to add a getter. We only needed it in this example because we had both a getter and a setter. So in this lesson we learned how to add getters and setters to properties within object literals. Getters and setters are properties that have methods which are invoked when the property is either accessed or has a new value assigned to it. We also learned that inside a getter or a setter, the this keyword points to the object that the getter or setter belongs to. In the next lesson, we're going to look at custom objects. In this lesson, we're going to carry on looking at objects, this time focusing on creating custom objects. Of course, any object literal that we create is technically a custom object, but I mean creating custom types of objects that we might want to create instances of later. This is also known as object-oriented JavaScript. Let's look at a basic example first of all. So let's say that we want to create a new type of object which will be a person object. So what we've defined here is a function expression, but it's a special type of function expression. It's a constructor function because we'll be able to use it to create person objects. Now you'll notice from the syntax that there is nothing special about the function. It's not a constructor function because we're telling JavaScript that it's a constructor function, but it will end up being a constructor function due to how we use it. So that's why we've capitalized the first letter of the variable that the constructor function is stored in, person, because that's the only way to let other people know that if they want to use this person function as a constructor function, it needs to have the new keyword in front of it. So the function will receive a parameter, and that parameter is the name parameter, and inside the function all we do is set a property of this to the name that gets passed in. So we're using the this object once again, and in this context, the this object will point to instances created by the constructor function rather than the constructor function itself. So this is slightly different than other times that we've used this previously in the course. So don't worry, we will be coming back and looking at the this object in a dedicated lesson to go over all of these different types once again. But just remember that when used with a constructor function, the this object will point to instances created with the constructor function rather than the constructor function itself. So if we want to add a method that all instances of person objects will inherit, we need to use the constructor's prototype. So in this case, we've added a new method called greet. And inside that method, all we do is return a string that says, hi, my name is, and then uses this.name to get the name from the person instance. So once again, this, in the context of this example, refers to instances of the person, not the person constructor itself. So now every time we create a new person object, it will have a name property, and it will inherit this greet method from the person constructor's prototype. And in this case, we've set the prototype just to an object literal. So now let's create a new instance of our person type. So let's just log out the new instance of person to the console. And we can see that it is an object of the type person, and it has a name property, and the name is Fred. We can also invoke the greet method if we want. And now we see the log message from the greet method. So this is a very basic way to create custom objects which behave a little bit like classes in other languages. But it's important to remember that JavaScript uses prototypes instead of classes. JavaScript does have classes, and we'll be looking at those later in the course, but these are just syntactic sugar that make writing object-oriented JavaScript a little easier. Even classes still use the prototype internally. So instances of the person will inherit the object prototype, because the person's prototype object is just an object literal. As well as using the new keyword, we can also use a method of the object constructor called the create method to create new instances of objects. So first of all, let's just take a look at the output in the browser, and then we'll come back and talk about why the output is what it is going to be. So we created a second instance of our person object, but as you can see, when we use the greet method, which that person object did inherit correctly, it says that the object's name is undefined. And the reason it's undefined is because even though we created a new instance using object.create, we weren't able to pass the name of the person into the new object when we created it. We bypassed the constructor. Luckily, we can pass a second argument to object.create, and that allows us to specify which properties the object that we're creating should contain, and any attributes of those properties, such as whether they are writable, enumerable, or configurable. The second argument that we pass to the create method is an object literal, and inside that object literal, the properties that we add will become properties of the object that we're creating. So in this case, we wanted to add a name property. So that is the property name that we used. When we specified the name property, we also added an object literal as the value of that property. This object literal is known as a property descriptor, and that allows us to specify different attributes of the property that we're creating. In this case, we specified that the name property should be writable, and we gave it a value of Bob. So let's just go back to the browser now. And we can see that that has fixed the undefined issue. As well as specifying whether the property should be writable, we can also specify whether it should show up in a loop by setting the enumerable property, and whether the property can be deleted by specifying the configurable property. Each of these properties has the default value of false, so if we'd like to enable them, we have to set them to true specifically. We don't have to specify these property descriptors for the object when we create it. We can also add them later using other methods of the object constructor, such as define property or define properties. The define property method is used to add a single new property, and it takes 3 arguments. These arguments are the object to add the new property to, the key for the property in string form, and a property descriptor object. So we used the define property method of the object constructor, and we passed it 3 arguments. The first argument is the object that we're defining the property for, which in this case is the object stored in the Bob variable. The second argument is the name of the property, so we've added a property to the Bob instance object called job. And the third argument is this property descriptor object, and you can see that we've given the job property the value developer, and we've specified that this property should be writable, configurable, and enumerable. And we've added a new log to the console, so let's just check the output now in the browser. And we can see that the instance object Bob does indeed have this new job property, and it is set to the value that we specified, developer. The define properties method is used to add a number of different properties to an object at the same time. The define properties method takes a slightly different format than the define property method did. So this time we pass 2 arguments to the method. The first argument is the object we'd like to define the properties for, and in this case we've used our Bob instance object. And the second is an object literal which contains a series of object descriptors. And the format is very similar to the descriptors that we used previously, although in this case we only set the value of the new properties. The properties that we're setting are specified using the keys of the descriptor objects. And now let's go back to the browser one more time, and we can see that our Bob instance object now has these new properties as well. So in this lesson we saw how to create objects of a custom type, and saw some more methods of the object constructor that we can make use of, such as the define property method, which allows us to define a new property for an object and pass in a descriptor object which specifies whether or not the property that we're adding should be configurable or writable or enumerable. And we also looked at the very similar define properties method, which is used to define multiple properties at the same time. In the next lesson, we're going to move on to look at the math API. In this lesson, we're going to take a look at the math object to see how we can use it to perform more advanced mathematical operations than the regular operators like plus or multiply allow. Unlike most other objects in JavaScript, the math object doesn't have a constructor, and it doesn't need to be created. It exists in the browser as a static object, which is global, so we can use it anywhere. It has a range of different properties which are all constant values and cannot be modified. For example, if we want to know the value of pi, we can use the pi constant. See how we didn't have to instantiate the math object, it's just there whenever we need it. As well as pi, we also have constants for Euler's constant. And there's a whole bunch of other things as well, like the natural logarithm of 2 and the square root of 1/2. I didn't study math past high school, so I have no idea what these are used for, but they're there if we need them. The math object also has a range of different methods for working with numbers. Let's look at some of them now. If we want to round a number up to the nearest integer, we can use the ceil method. Or if we want to round a number down to the nearest integer, we can use the floor method. So you can see that the rounding with ceil or floor just rounds either up or down. It doesn't take into account whether the fraction is greater than 0.5 or not. We can also round to the nearest integer using the round method. The round method rounds to the nearest integer. It doesn't just blindly round up or down. So that's rounding covered. What else can we do? We can find the largest of a series of numbers using the max method. So the max method simply returns the largest number out of all of the arguments passed to it. We also have the min method, which does the opposite. We can find the absolute value of a number if we wish, which basically means any positive number, and we do this using the ABS method. We can find the square root of any number using the SQRT method. This only works with positive numbers. If we pass the SQRT method a negative number, it returns the nan value. We can also raise a number by an exponential power using the POW method. So what this does is raise the number 3 by 2 powers. There's one other method that can be pretty useful, and that's the random method, which allows us to generate a random number between 0 and 1. And if we just refresh that a few times, we should find that the last console log is different each time. So random by itself returns a floating point number in between 0 and 1. If we want to generate a random whole number, we need to floor it and multiply it by 10. And this time we get a random integer. There are also a range of methods that we can use for trigonometry, including cos, sin, and tan, as well as acos, asyn, and atan, and future versions of JavaScript will have even more. So in this lesson we looked at the built-in math object and saw some of the different properties and methods that are available for us to use to perform mathematical operations on numbers. In the next lesson, we're going to see how we can work with dates and times in JavaScript. In this lesson, we're going to see how we can work with dates and times in JavaScript. The date object in JavaScript is interesting because it can only be generated with a constructor, which means that we must use the new keyword with it. There is no literal syntax for creating dates or times. A date object represents a specific instant in time. JavaScript measures time in milliseconds since midnight at the start of the 1st of January 1970, a date referred to as the start of the Unix epoch. This date is represented by a date object with a value of 0. So let's create a date object, and we need to do that using the date constructor. And let's just log that to the console quickly. And this gives us the date. So I said just a moment ago that we have to use the new keyword with the date constructor. Let's just look at what happens if we forget. So in this case, the output looks exactly the same because we're just logging it to the console. But the difference between the two versions is that the second version is a string, whereas the first version is a proper date object. Let's just verify that using typeof. So we can see that at the moment it's a string, but if we go back and add the new keyword like we had originally, we now see object. And that's important because when we create a date in JavaScript, we will generally invoke methods on that date in order to extract different parts of the date or format it in some way. And we won't be able to call any methods on a string because a string doesn't have any of the special date methods or properties. We can also create date objects of a specific date and time. To do that, we can pass various arguments to the constructor. We can pass a single number, and this number should represent the number of milliseconds since the start of the Unix epoch. For example, so what date do you think party time is going to refer to? That's right, it's the changing of the millennium at 1 minute to midnight. So when we pass a single numerical argument, that number is the number of milliseconds which have elapsed since the beginning of the Unix epoch. We can also pass a string to the date constructor, and the constructor will attempt to parse a date out of it. And we can see that it has managed to parse a proper date out of the string September 9th, 1978. If we pass a string to the date constructor that doesn't contain a date, we'll get the string invalidDate returned instead. Lastly, we can also pass in a series of arguments which represent the year, month, date, hour, minute, second, and millisecond for the date that we'd like to create. As you can see, if we don't specify a time, the time part of the date defaults to exactly midnight on the specified date. Months are zero-based, so January is 0, February is 1, and so on and so forth. We didn't specify any times in the special date that we just created, and so it defaulted to midnight. Date objects don't really have any properties that we'll need to make use of very often. They have a constructor property, which points to the date constructor. The constructor itself has a prototype and length properties, but generally, when we work with date objects, we'll be making use of their methods rather than their properties, and there are many methods that we can make use of. The different methods can be broadly categorized into 3 different types of methods: getters, setters, and converters. Let's look at some of the getters first. We can get either the day of the month or the year for the local time using getDay, getMonth, or getFullYear. We can also get the day of the week, or the UTC day of the week. Days of the week in JavaScript also start at 0, and Sunday is actually the first day of the week. There are also methods to get any of the time components in both local and UTC format as well. As well as getting any of these different components of the date of time, we can also set them, again in local or UTC times. The converter methods are all getters as well, and they return transformed versions of the date object. For example, to get the full date and time in string format, we can just use the toString method. We can also get the full date as a UTC string instead. The difference between these two strings is that the second version, the UTC version, doesn't have the number of hours offset that local times have. If we want to get just the date components without the time components, we can use toDateString instead. Similarly, if we want to get just the time components, we can use toTimeString. There isn't a method for getting just the time component in UTC, but we can get a string of the date in ISO 8601 extended format if we need to. There are also some methods we can use which are locale sensitive, including toLocaleString, toLocaleDateString, and toLocaleTimeString. My system settings are set to en-GB, so this method returns a string in a format that I am used to. So in this case, the date of the month comes before the month. That's why it's 3/9 instead of 9/3, which it would be in the standard en-us format. So in this lesson, we looked at working with the date object in order to make use of date and time related functionality in JavaScript. We saw how to create date objects using the date constructor and how to get, set, or convert different parts of the date or time. In the next lesson, we're going to finish up this section by looking at some of the more useful methods of the Array Constructor. In this lesson, we're going to look at the Array Constructor. We've already looked at arrays, and we've looked at other things like the Object Constructor. So in this lesson, I just want to take a quick look at the Array Constructor, because like the Object Constructor, it does have a couple of very useful methods that we might want to make use of. I mentioned earlier that it is quite hard to know whether we're working with an array or an object, because the type of operator returns object for both arrays and objects. I did say that we'll look at an easier way to tell whether we're working with an array. We'll be coming back to look at this again later in the course, but one of the methods the array constructor has is the isArray method, which will tell us whether the object we're working with is an array. So first of all, let's just add an object and an array. So we can now use the isArray method to test each of these things. And let's just check the browser's output. And we should find that it logs first false and then true to the console. So the isArray method is the easiest way to tell if the object that we're working with is a true array. This is a relatively new addition to JavaScript, and there is another older way to tell if an object is an array, and we'll come back and look at that as well later in the course. The other method of the array constructor is the from method, which allows us to easily create new objects from any iterable object. So if we wanted to create an array from a string, for example, we could do this. So when we look in the browser's console, we should find that we have a new array containing each individual letter from the string. We can also use this to create arrays from other types of iterable, like a map or a set, or even the arguments object inside a function. And we can see that an array has been created from all of the arguments passed to the logargs function. We haven't looked at functions in great detail yet, and we haven't really covered the arguments object at all. We will be coming back and looking at functions in much more detail in the next section of the course, and that will include a discussion of this special arguments object. So don't worry too much about it for now. So usually the from method takes a single argument, and that is the iterable that we want to create the array from. But there is also another form of the method which takes 3 arguments. In this case, the second and third arguments are a map function and the this object that we want to use inside the map function. It works like this. So we pass a function to the from method as the second argument, and that function is the mapping function. This function will be called for each item in the array, and each time it gets invoked, it will be passed the current item from the array. And all the function does is return the corresponding value from the this object. So let's take a look in the browser's console now. And we can see that we have an array with the strings 1, 2, and 3. So the map function works in the same way as the map method on arrays works, and we saw that earlier on in this section. The from method just allows us to map the array created by the from method into a new array without us having to use an intermediary array. So in this lesson we looked at a couple of useful methods of the array constructor, the isArray method and the from method. The isArray method returns true or false to tell us whether the object passed to it is an array or not. The from method allows us to create a new array from any iterable object, and optionally allows us to provide a mapping function to convert the array in some way. We're now going to move on to section 6 of this course, which focuses entirely on functions and aspects of JavaScript related to functions. In this lesson, we're going to take a look at the this object in JavaScript. The value of this object is usually, but not always, an object, but it can refer to different objects depending on where it is used. Inside a function, the value of this varies depending on how the function is called. For example, we are inside an immediately invoked function expression at the moment, so let's just try logging out the value of this to see what it refers to. And we can see that it is actually undefined inside a function. So when we use this inside a function and the function is invoked in the normal way that a function is invoked with the double parentheses at the end of it, this will be undefined in strict mode. Now the value will change if we're not in strict mode. And if we're not running in strict mode, inside a function, this will point to the global window object. And that can actually be quite dangerous. If we are inside a function which is the property of an object, this will point to that object. Whenever we are outside of a function, the this object will still point to the window object. And you can see that we're logging the window once again. As we saw in a previous lesson, there's also another time that the this object can point to something different, and that is when we are inside a constructor function. Now we did already go over this, but because that was in a different section of the course, I just want to recap over that once again. So it's a very similar example to the last time we looked at this topic. So we're using a person constructor once again, and the constructor accepts a name argument. And inside of the constructor, we just set a property of this to equal the name that gets passed into the constructor. So even though the constructor function is defined as a regular function, when we call it, as long as we're calling it properly, we will be calling it in a different way. We'll be calling it like this. So the difference in how we're invoking the function this time is that we're using the new keyword. And that's how JavaScript knows to invoke the function as a constructor. And when it invokes a function as a constructor, the this object inside the function will point to instances created by the constructor. It won't point to the constructor itself like you might expect. So in this case where we have created a variable called Bob, when we invoke the person constructor, the Bob variable will end up containing an instance created by the person constructor. And so in this case, this will point to the instance object. There is another time that the this object can change what it points to as well, and that's when we're inside a function which is being used as an event handler. In this case, the function will be invoked when an element triggers it from the UI, like when a button is clicked. In this case, the this object will be set to the element that triggered the event. So if it was a button that was clicked, which triggered the event, the this object will point to that button. We're going to come back and look at event handlers in much more detail in the DOM events lesson later in the course. For now, just understand that this is one more time when the this object might change what it points to. And that's when the function it is within is being used as an event handler. There are some different ways in which we can control what the this object points to, such as when we're using methods like call or apply. We did see the call method very briefly in an earlier lesson, but we're going to come back and look at both of these methods in much more detail in the next lesson. So in this lesson we looked at the different values that the this object can have in JavaScript depending on the context. We saw that in the global context, this points to the window object, and when we're inside a function, this is undefined. If we are inside the method of an object, this will point to the object itself, and when we use this inside a constructor, this will point to instance objects created by the constructor. In the next lesson then, we're going to move on and look at some methods and properties of function objects, including the call and apply methods. In this lesson, we're going to look at some of the properties and methods that functions have. Functions ultimately are objects as well, like most other things in JavaScript, and so they also come with a number of properties and methods that we can make use of. So let's add a simple test function first of all. So we've defined a simple function here which accepts two parameters and it returns those two parameters added together. There's really only one property of functions that we'll ever be interested in, and that is the length property. When used with a function, this property refers to the number of named parameters. Functions do have some other properties, but they are generally unavailable in all browsers, and so they're not recommended for general use. So let's move on now to look at some of the methods that functions have. Functions don't have a huge number of methods, but the ones that they do have are extremely powerful. These are the call, apply, and bind methods, and they can all be used in very similar ways, with just some subtle differences between them, especially call and apply. The call method is used to invoke a function and specify the object that should be used as the function's this object. So let's just add a new object first of all. So we've added a regular object literal in the variable person, and we've given it name and job properties. Let's add a new function now called introduce. So this function just logs an introductory message to the console, but it makes use of this.name and this.job as part of the message. So if we were to invoke the introduce function normally, just by adding its identifier and a pair of parentheses, this would be undefined inside the function. What we can do instead is invoke this function using the call method. So let's see the output in the browser's console now. It works in the way that we were probably expecting. So what's happened is, when we use the call method, we can specify what the this object inside the function that we're calling should point to. So in this case, we are using the call method with the introduce function, and we are saying that inside the introduce function, the this object should point to the person object literal. So the first argument that we pass to the call method is the object that we want to use for this. But we can also pass any number of additional arguments, and these arguments will be passed to the function being invoked as arguments. So let's just add a named parameter to the introduce function. So this time the introduce function accepts a parameter called inductee, and we've added that to the message that gets logged to the console. So now if we want to pass in the name of an inductee, we can add a second argument when we use the call method. And we can see that the argument has been passed through in the way that we would expect. So don't forget, we can pass as many additional arguments as we want using the call method, and they are just passed as a comma-separated list. So this argument passing is actually where the difference between the call and apply methods emerge. Everything about the apply method is the same as the call method. It invokes a function and allows us to specify the binding for the this object inside the function that apply is used with. So now let's look at passing arguments. And now we see the same message as before. So the difference between call and apply is how we pass arguments. The apply method only takes two arguments. The first argument is the object that should be used for this inside the function, and the second argument is an array containing all of the arguments that we want to pass to the function that we're applying. This is useful when we don't know how many arguments we're passing to the function. This makes the apply method very flexible because we can pass an unknown number of arguments to the function that's being invoked. There is a great mnemonic to remember the difference between the call and apply methods. That mnemonic is as follows: C for call, A for apply. C is for comma, because when we use the call method, the arguments are passed as a comma-separated list. A is for array, because the arguments passed to apply are passed as an array. C for call, A for apply. As long as you remember that, you will always remember how to use the call and apply methods and what the difference between them is. So before we finish up in this lesson, let's take a quick look at the bind method. The bind method also allows us to control the value of a function's this object. But this method returns a new function, and the this object that we specify is the this object for the function that bind returns. So bind itself doesn't invoke the function that it's called on. Let's look at a simple example. The function that we've defined, add to cart, receives an argument called price, which will add to a running total. We check whether the this object has a property called total, and if it doesn't, we add one and initialize it to 0. The function then updates the total with the number passed into the function, and lastly returns a string showing the name of whose cart it is and the current total. So now we have to bind the function to an object to use as its this object. We call the bind method on the add to cart function and specify the person object that we used earlier as an argument. So the person object will become the function's this object. So now we can invoke our function and pass it in a value. And we can invoke it later again if we want. We can see that the total property keeps on being updated. This is quite useful. So when we used the bind method, JavaScript returned a function that we can invoke. And every time we invoke that function, the this object will always point to the object that we passed into bind. We can also specify arguments that may be passed when the bound function is invoked. Maybe we want to add a handling fee to each item added to the cart, which is the same each time the function is called. We can update the function to accept a fee. And now when we bind to the add to cart function, we can specify the default value for this fee. So we can see that each time the function has been invoked, it has simply added 1 to the total. So in this lesson we looked at the different properties and methods that we can use with functions. We first looked at the length property, which simply tells us how many named parameters a function accepts. We then moved on to look at the call, apply and bind methods, which can all be used to set the this object, or the context, of a function. We saw that call and apply are both very similar. They only differ in that with call, we need to specify each argument independently, whereas with apply we can pass an array containing all of the arguments that we want to pass to the function. Lastly, we looked at the bind method, which returns a new function that has its this object bound to a particular value, and it retains this each time the returned function is invoked. In the next lesson, we're going to learn all about scope in JavaScript. In this lesson, we're going to take a look at scope in JavaScript, starting with what it actually is. Scope is actually a relatively simple concept and is a feature of many programming languages, although JavaScript does have some subtleties that can be confusing. Scope defines the visibility of variables in different places in our code. In any JavaScript environment, the global scope is the top-level scope that contains all other scopes. The global scope is visible to every single script file attached to the page, and this is why we should avoid setting variables in the global scope if at all possible. So to inspect the global window object, we can just enter window in the browser console. Any global variables that we create will automatically become properties of the global scope. There are many properties of the global object which are useful. For example, if we want to see the URL that is displayed in the browser's address bar, for example, we can use the location object, which is a property of the global window object. So we can see here the location property contains a location object, and that object has a href property which shows the value in the address bar. So I mentioned at the start of the lesson that the global scope contains all other scopes. So how do we create new scopes? We can do this with either functions or blocks. When we declare a function in JavaScript, it automatically creates its own scope. When we declare variables inside a function, we say that the scope of those variables is local to the function that they're defined within. They are local variables instead of global variables. They're local to the function that they are within. Variables defined inside of functions cannot be accessed or updated outside of those functions. Let's see a quick example of this. So we can see both of the variables from within the function. So we've got two functions in this example. We've got the immediately invoked function expression, which surrounds the whole file. So when this file gets executed, what will happen is this outer wrapping function will create a scope. This scope will belong to the global scope. So inside the scope of the ify function, the outer containing function, we then define a function called local. And inside this local function, we create a new variable called localVar. When we do the console log, we see that we can log both the myVar, which is a part of the ify's scope, and the localVar, which is a part of the local scope. So the local scope is actually within the ify scope. The ify scope itself is within the global scope. Inside of the local function then, we can see any variables that are defined within the function itself, so any variables that are local to the function, we can see all of those inside that function. But we can also see any variables which are in any scope which the local function is also within. So the local function scope is within the ify function scope where myVar is defined, and so we can see that both inside the local function and outside of the local function. However, we can't see the local variable outside of the local function. In this case, we get an error to say that localVar is not defined. Now we know that localVar is defined, but it's defined in the local function's scope. So we can reach out of scopes, like inside the local function, we can reach out to the containing scope to see the myVar variable, but we can't reach into a scope. we can't reach into the local function scope in order to see the local var variable from outside of the local function. That doesn't work. So all of these different scopes that get created are known as scope chains. So inside of the local function, we are at the end of a scope chain which includes the local scope, the iffy scope, and the global scope. When we are in the iffy scope, the scope chain just consists of the iffy scope and the global scope. As well as function scope, JavaScript now also has block scope. Block scope enables the same behavior as function scope, but for blocks of code instead of functions. A block of code, remember, is any statements within curly braces. So we've created a block using a for in loop here. Let's run the code in a browser and see what happens. So you can see that we do see prop1 in the console, but then we see an error to say that prop is not defined. So while we are inside the block of the for loop, we can access the prop variable. But because the prop variable was declared using the let keyword, that makes the variable block scope. So it can only be seen within the block of the for loop. And when we try to access prop outside of the for loop, we see the error. If we change let to be var instead, we then don't see the error anymore because the variable is no longer block scope. So actually now prop exists in the iffy scope because that is its containing scope. So in this lesson we looked at scope in JavaScript, and we saw that it can be defined as the area in which variables can be accessed in different parts of our code. We saw that variables defined in the global scope are visible everywhere, even in different script files running on the same page as our own. We also saw that functions create their own scope, and the variables defined inside a function are only visible to other code within the same function. We also saw that blocks can create their own scope, as long as we use either the let or const keywords in order to declare variables. If we use the var keyword to declare a variable inside a block, that variable will leak out of the block and be visible in code outside of the block. In the next lesson, we're going to look at something called globalThis. In this lesson, we're going to take a look at an object called globalThis. At the start of this section, we looked at the this object and saw that it can refer to different things depending on where it is used. Inside modules or functions running in strict mode, this is undefined, but outside of any function, it points to the global window object. As well as this, there is also another keyword that points to the global window object, self. And with self, the behavior is consistent whether you're inside a module or function or not, and if it's a function, whether the function is running in strict mode or not. As well as this and self, we can also access window directly, which also points to the global window object. However, window is only available in windowed contexts, like browsers. In web workers, for example, which we'll be looking at later in the course, window is undefined, and instead we need to use self. But additionally, if we want our code to run in Node.js, for example, we can't use window or self. Neither of those exist there, and instead we need to use the global keyword to access the global context. These inconsistencies mean that we might need to try to detect the environment that our code is running in order to use the correct keyword if we want our code to run on multiple platforms. To remediate this situation, JavaScript has a keyword called globalThis, which always points to the global object regardless of the environment or context the code is running in. So now let's say that we want to access a basic property of the window, like the scroll value, which is available in browsers but not in web workers. Previously, if we wanted to get the global object and we weren't sure which environment the code was running in, we'd have to do something like this. That's not a huge amount of code, but it's annoying that you need to go to those lengths just to access the global object safely. Using globalThis, we can avoid most of that code above and just do this. So in this lesson we looked at a feature of JavaScript called globalThis, which was introduced to address the shortcomings of having inconsistent keywords for accessing the global object in different JavaScript environments. In the next lesson, we'll look at arrow functions. In this lesson, we're going to look at an alternative syntax that we can use to define functions. Arrow functions, or fat arrow functions as they're also known. Arrow functions are mostly a syntactic sugar for using a shorter syntax which is equivalent to a function expression. But they do also make use of a lexical this, which is very different from regular functions. Let's take a quick look. So a typical arrow function will look something like this. So let's just look at the output in a browser and then we'll come back and talk about the syntax. So the square of 3 is 9, as you were probably expecting. Okay, so when we define an arrow function, we don't need to use the function keyword. The function keyword doesn't appear in this code at all, but as you can see, it's definitely a function because we are invoking it. What makes this an arrow function is the arrow function syntax. And really that's this part of the code here, the equals and greater than sign. We also don't provide a name for the function, so arrow functions are always anonymous functions. The body of the function in this case is contained within curly brackets, which is necessary because there are multiple expressions inside the function. Those expressions are where we create the square variable and where we return the square variable. So this should now work in the same way as before. And now actually, because we're down to just a single expression inside our arrow function, we don't need to use the curly brackets. And now that we aren't using the curly brackets, we don't need to use the return statement. Let's just go back to the browser. And we can see that the function is still working in the same way that it did before, even though the syntax is now quite different than when we first started. So we've managed to condense our function down to a single line. And that really is the power and the beauty of arrow functions. Very often they can be simple one-liners like this. So this is now known as an implicit return because we don't explicitly use the return keyword. We only need to do that when we are using an arrow function that contains multiple expressions and thus requires the curly brackets. The parameter that gets passed into the function is specified before the fat arrow. And in this case, we're only using a single parameter. If we want to use multiple parameters, however, we need to use a slightly different format once again. So because we're now passing multiple parameters into the arrow function, we need to surround these parameters with parentheses and separate them with a comma. This is the same even if the function didn't accept any parameters. So even though we aren't passing any parameters at all now, we need to use the parentheses. We can only get rid of the parentheses if we're passing a single argument into the arrow function. So we saw an example where we used curly brackets earlier. What happens if we want to return an object literal from an arrow function? So the function actually is returning undefined at this point. The reason why it's returning undefined is because in this case we want to return an object literal, but when we use curly brackets, that tells JavaScript that we're using a multi-line function. Even though in this case it isn't actually a multi-line function, it still confuses the JavaScript engine. So when we're using an arrow function and we do want to return an object literal, we just need to wrap that object literal in parentheses. And now we see the object literal as we were expecting. So these are some of the variations in the format of arrow functions. You might see any number or combination of those variations depending on how the arrow function is being used. So one other very important feature of arrow functions is that they have a lexical this. And what that means is that they take their value of this from the surrounding code. Whatever is in the this context around the function is what will be the this context inside of the arrow function, according to the regular rules of this. So in this function's case, that would be undefined because we are inside a function. That function is the outer containing ify function. A consequence of the lexical this is that arrow functions cannot change their value of this. We can use arrow functions with bind, call, or apply, but regardless of what we specify as the this object when we're using those methods, inside an arrow function, this will always be the lexical this. A consequence of not being able to change the this value inside an arrow function is that we can't use arrow functions as constructors. Invoking an arrow function with the new keyword will throw an error. Another limitation is that arrow functions cannot be generator functions. We're going to look at generator functions in the next lesson. So for now, just be aware that arrow functions cannot be generator functions. So in this lesson, we looked at arrow functions, which have two main benefits. The first benefit is a much more concise syntax than other functions. And the second benefit is the lexical this, which in some situations can be very useful. We saw that there are several different variations that the arrow function might take depending on how we want to use the function. We saw that we can pass 0 or more than one parameter using parentheses, but if we're just passing a single argument, we don't need to use parentheses. We also saw that we can use curly brackets if we want to use multiple expressions inside the arrow function, and that if we want to return an object literal, we need to wrap it in parentheses. In the next lesson, we can move on to look at generator functions. In this lesson, we're going to take a look at another type of function that we can use in JavaScript, a generator function. This type of function is very powerful, but is very different from regular JavaScript functions. Defining a generator function is really easy. We need to use the function keyword with this type of function. We just need to add an asterisk after it. In almost all respects, it's just like a regular function. It can have a name and it can accept parameters. With a regular function, however, once it starts, it executes all of the statements it contains and then returns. All further activity of the function stops unless the function gets invoked again, in which case it basically starts again. Generator functions, on the other hand, do not run to completion. They can return a value, pause, and then be resumed at any time later, and they pick up exactly where they left off and continue processing, sometimes returning many values before they actually end. Regular functions are blocking. While they are running, no other code can run. With generator functions, we can pause them, and this allows other code to run, and we can then come back and resume the generator function later on. So generator functions are only blocking while they are actually running, not all the time. The way that we pause a generator is with the yield keyword. We can use yield by itself, or we can use it to return a value, a bit like the return keyword. And like with the return keyword, if we don't specify a return value, it will return an implicit undefined. So let's update our generator function now to make use of the yield keyword. And just so that you can be sure that the generator function does pause after this statement, let's add a console log directly after it. Another difference between regular functions and generator functions is that we don't actually invoke generator functions like we do regular functions. We invoke the generator in order to get an iterator, and it is the iterator which actually invokes the generator. We still need to pass the parameter that the generator function is invoking when we invoke it to get back the iterator. We looked at iterators earlier in the course, and we saw that they should have a next method. So in order to invoke the generator function, we need to invoke the next method of the iterator that invoking the generator returned. So at this point, we have invoked the generator in order to get back the iterator, and we've invoked the next method of the iterator. So the generator function should now have started running. Let's just check the output in the browser quickly. We can see that we don't see that log message that we added after the yield keyword. So what's actually happened is, when we invoked the next method, the generator function ran until it encountered the yield statement, which happened to be the first statement inside the function in this example. And then it paused. As soon as the x multiplied by x value was yielded, the function paused. So now we see the log message that was added after the yield keyword. So we can see that the generator function was paused after it yielded, and that when we invoked the next method a second time, we saw the log message that came after the yield expression. And this time in the object that gets returned from invoking the next method, we can see that done is true, and this means that there are no more expressions to evaluate within the generator function. So if we invoke the next method again, nothing will happen. If we want to run the generator again, we'll need to get a new iterator and start again, basically. So one of the key points of this example so far is how we can pass a value back from the generator. And we do that, as we saw, using the yield expression. But what about sending new values into the generator? This is also possible and is another fundamental aspect of generators. So let's just go back and modify the original generator function slightly. And let's also log this new variable to the console in the log statement. And let's also make a change to how we use this function. So when we first get the iterator, we can continue passing 5 in, but let's use the next method of the iterator to pass a different value into the generator when it gets resumed. So this time we can see that something interesting has happened. So this time we pass the value of 10 into the generator using the next method the second time we invoke next. And we can see that the output has now changed. So when the generator runs and evaluates the first yield expression, it will still return 25 like it did before. But when we pass 10 in the second time the next method is invoked, the yield expression will be replaced with this new value. So when we invoke the generator, we still pass 5 in, and so 5 is the value of x when the generator function first begins to run. But then when we invoke the next method and pass 10 in, the yield expression inside parentheses will be replaced with this value that we pass in. So y then becomes 10 multiplied by 5. As well as using yield, we can also use return at the end of a generator. And when the iterator for the generator is used with the next method, the value returned will be the value property in the object returned by the next method. Another point to note is that a value passed to the next method the first time the next method is used is discarded and is not available inside the generator. The reason for this is because the generator hasn't yet evaluated a yield expression the very first time it gets invoked. So in this lesson we learned about generator functions and saw that they are a powerful type of new function that can be paused and resumed instead of running to completion and blocking other code. We saw that we define a generator using the star character after the function keyword. We learned that we can pause a generator using the yield keyword, and that we can pass a value out of the function using this yield keyword. We also saw that generator functions are used with an iterator. We invoke the generator once to get its iterator, and we then use the iterator's next method to start or resume the generator. We also saw that we can pass values into a generator when resuming it using the next method, and that these values will be inserted as the result of the yield expression that the generator previously paused at. In the next lesson, we're going to look at closures in JavaScript. In this lesson, we're going to take a look at one of JavaScript's most misunderstood and feared features, the closure. But don't worry, we have nothing to fear from the closure. Although they are seen as an advanced feature of the language, the premise behind them is actually quite straightforward. Earlier in the course, we looked at scope in JavaScript, and we learned that it refers to the parts of our code in which variables are visible and accessible. As we know, Variables declared outside of any function have global scope, which means that they can be used or accessed anywhere in our own scripts or anywhere in other scripts attached to the page. Variables defined inside functions, on the other hand, are only visible within that function, including within other functions inside that function. The ability to create closures is simply a result of the fact that we can create functions inside of other functions. These functions are known as inner functions. A closure is just an inner function that remembers all of the variables in the scope of the outer function that it's within. This may not seem like a big deal when explained in such terms, but recall that once a function returns, its scope is usually destroyed. This is where the term closure comes from. The inner function closes over the scope that it is contained within, preventing that scope from being destroyed. Let's look at an example to illustrate how closures are formed and how they behave. First of all, let's create a new constructor function that represents an order in a store. At this point, it's just a regular constructor. There's nothing special about it at all. There's no closure. But now, let's have the constructor return a function. We return a function called addProduct, although the name of the function is only useful for debugging purposes. This function accepts a single parameter called price. Inside of the function then, let's compute a sales tax and a fee, and then add these to the price to create a total. So inside the addProduct function, we calculate a sales tax and a fee, which are both based on the price. We then add the price, the sales tax, and the fee to the total, which was specified as a variable inside of the outer order function. So the order function is the outer function in this case, and the addProduct function is the inner function. So now we can create the closure. So in this statement, we simply invoke the constructor and store the return value in a variable. So remember that the return value of the constructor is the function addProduct. So the outer function at this point has returned. By all reasonable assumption, its scope should have been destroyed, including the total variable which exists within its scope. But because the constructor returns a function, something special happens, as we can see if we invoke the function that got returned. Let's now check the output in our browser. We don't see any errors, we see some values, and those values are the result of invoking the addProduct function, which got returned from the constructor. The inner function, addProduct, created a closure, and that closure protected the total variable, which was in the order constructor's scope. So even after the order constructor had returned, the inner function addProduct protected the total variable, and each time we invoke the addProduct method, the total variable is accessible through this closure. With closures, what's important isn't the environment when the function is invoked, but the environment that existed when the function was created. So in this lesson we looked at closures in JavaScript, and we saw that despite being considered an advanced feature of the language, they are nothing more than information about a scope and a function that remembers that scope. We learned that when a function returns or creates another function, the inner function remembers all of the variables in scope when that function was defined. In the next lesson, we're going to move on and look at prototypes again, this time in a bit more detail. In this lesson, we're going to take another quick look at prototypes in JavaScript. So remember, the prototype is a special property that all objects have. This is the object that they are descended from, and from which they inherit properties and methods. For example, when we create an object literal, even if we don't add any properties to it ourselves, it will still have certain properties and methods that we can make use of. In this example, we call the hasOwnProperty method on the empty object literal that we created and stored in the variable myObj. So this hasOwnProperty method came from the object literal's prototype, which is the prototype property of the object, so that's object with a capital O, constructor, which is what created the object literal for us behind the scenes. So we don't actually need to look at the output of hasOwnProperty key. We know that our object literal doesn't have a property called key, so this method is going to return false. We don't need to worry about that. But let's just log the object itself to the console. So there's our empty object literal in the console. Let's just open it up. So we didn't add any properties to this object literal ourselves, but as we can see, it still has this special __proto__ value. And that property is the prototype object of the object literal. And as we can see, that currently points to the object constructor. So this is the object from which our own object is descended. When we open up the __proto__ property, which from this point forward I'm just going to refer to as proto, we can see that there are a bunch of other properties and methods. So we can see the constructor property, and that also points to the object constructor. And we can see the hasOwnProperty method, which we looked at just a moment ago, and which we've used earlier in the course as well. So all of these properties and methods are what is being inherited via this proto object. So this is very interesting, but we shouldn't actually use this proto object in our own code ever. It's awful for performance, and it's actually deprecated. But it is interesting to look at, and it can sometimes be useful purely for debugging scenarios. So prototypes themselves may form chains, similar to how nested scopes form chains. When we access an identifier in one scope, if the identifier is not found, the JavaScript engine moves up to look in the parent scope, and so on and so forth, all the way through the scope chain until it reaches the global scope. When we try to access a property or a method of an object, a similar process occurs. If the property or method is not present directly on the object that we tried to invoke it on, the JavaScript engine will look in the current object's prototype, and then the prototype of that object, and so on and so forth, right back to the object, capital O object, prototype. If the property or method is not found there, the engine gives up and returns undefined. But you can see that prototype chains are very similar to scope chains conceptually. So let's see this in action with another example. So in this example, we first create a new constructor function called example. We then set the prototype of this constructor function to a new array instance, which we can access by invoking the array constructor. We then create a new instance object using our example constructor, and lastly we just log this to the console. So let's go to the browser and take a look at the output this time. So again, we just see our empty example object, and let's open this one up. So we still see a proto property, and that points to an instance created by the array constructor. Let's expand this one. As we know, arrays have a length property, so our example object will also have this inherited length property. It won't have it directly, but it can still reach it through the prototype chain. And there is also another proto property, so let's open that one up. And here we can see all of the methods that arrays have access to, and that means that our instance will also have access to all of these methods, even though it isn't actually an array. Right down at the bottom we can see that there's another proto object, this time pointing to the object constructor. Let's open that up. And we can see all of the properties and methods that get inherited from the object constructor. And there are no more proto objects, because ultimately everything in JavaScript comes from the object constructor. So what we've done there in the console is manually navigate the prototype chain. That is exactly what happens when we try to invoke a property or method on an object. The engine will navigate the prototype chain looking for that property or method, and only if it doesn't find it once it gets up to the object constructor does it return undefined. So let's just do a simple test. And we can see that even though our custom object has the array prototype, because the array prototype itself can access the object prototype, we can still make use of the method. We don't get any errors and the code doesn't blow up. So in this lesson we looked at the special __proto__ property that all objects and all object instances in JavaScript have access to, and we learned that this is the primary mechanism for inheritance in JavaScript and is how the JavaScript engine is able to navigate the prototype chain. In the next lesson, we can look at default parameters and rest parameters. In this lesson, we're going to take a look at spread syntax with the spread operator. I mentioned right back near the start of the course that there was an operator called the spread operator, but at the time we hadn't covered enough ground for its use to be appreciated, and I said that we would come back to it later. This is now that time. Spread syntax is a number of distinct places where we can use the spread operator. We can use spread syntax when passing arguments to a function, when adding values to an array, or when adding key value pairs to an object. Let's take a look. Let's say we have a function which accepts 3 numeric arguments and returns the sum of them. We could call this function in the usual way and pass it a comma-separated list of the individual arguments. But if we had an array containing 3 numbers instead, using spread syntax we can just pass the whole array to the function instead. The array will be automatically expanded to a comma-separated list of all of the elements inside it, and the function will be invoked as if we had passed the arguments individually like usual. Another place we can use spread syntax is when adding values to an array literal. Let's say we wanted to combine 2 arrays. We can use the spread operator to do that very easily. Again, the spread operator is used to expand the array into a list of all its elements. So in this case, the new array will not contain 2 arrays, but 4 individual values, the separate values from each of the original arrays. One thing to note is that this doesn't work correctly with multi-dimensional arrays. Lastly, we can also use spread syntax in object literals. This time, let's say that we have 2 objects that we want to combine. Conceptually, the usage is very similar to that with arrays. The only difference is that objects are expanded to a list of key value pairs rather than single values. So in this lesson we learned that the spread operator is used to expand an iterable object, like an array, into a list of that object's values. We saw that there are several places that the spread operator can be used: in function parameter lists, inside arrays, and inside object literals. In the next lesson, we'll be looking at default and rest parameters. In this lesson, we're going to learn about a couple of features that we have with regards to function parameters. These features are called default parameters and rest parameters. Let's start out by looking at default parameters. Default parameters are a way to specify a value for a parameter when that parameter doesn't get passed as an argument to the function when the function gets invoked. So we specify the default value for a parameter when defining the function. We use assignment within the function's parameter list to specify the default value for the parameter. When we invoke the function, if we don't pass a value or if we pass undefined, the default value will be used. If we do supply a value for the parameter as an argument, it will overwrite the default. So we can see the first time the function gets invoked and we don't pass an argument, it uses the default value of the parameter, but when we invoke it a second time and we do pass a value in, that value then overwrites the default. We can use default parameters with function expressions as well as regular functions like this, and we can specify multiple default parameters. We can even use the default value of one parameter as part of an expression for another default parameter. Let's change the example code to add a second default parameter that makes use of the first one. And let's update the log message inside the function. So we've added a new invocation of our function as well, just with some different parameters there so that we can see the different behavior. So you can see the different variations in the different arguments that we're passing when we invoke the function and how that interacts with the default parameters. So let's move on to look at REST parameters now. We looked at the spread operator right back near the start of the course. We can also use the spread operator in a function's parameter list. And when we do this, the arguments are received as an array rather than an array-like object, like the arguments object. So let's create a new function now. So we can now invoke this function with any number of string arguments, and the function will join them all together. Okay, so let's just take a look at the output. So the reason why REST parameters are awesome is because for many years we've had to endure the fact that while the arguments object looks like an array, it isn't an array, and so we can't actually use array methods like join with it. So let's just illustrate this point by changing the console log. So remember, the arguments object is available within all functions, and it is an array-like collection, but it's not a true array. And we see that it's not a true array because we see an error in the console if we try to use array methods such as join on an array-like object. So that's really why REST params are so awesome, just because we've had to do without them for so long, and now they're finally here. Previously, we might have had to convert arguments into an array somehow, and although that wasn't particularly difficult, it was an extra thing that we would have to do inside functions if we wanted to treat the arguments object as if it were a true array. So now we don't have to do any of that messing about stuff. We can just use a REST param. So in this lesson, we learned about default parameters and REST parameters. We saw that default parameters are simply a way to specify a default value for a function parameter, which we do in the parameter list when we declare the function. When the function is invoked, if an argument isn't passed, the default parameter value will be used instead. We also saw that REST parameters are a way to use an arbitrary number of arguments passed to a function as a true array rather than as an array-like object, like the arguments object. So this now brings us to the end of the section on functions. In the next section, we'll move on to look at some miscellaneous JavaScript features, starting with destructuring assignment. In this lesson, we're going to look at destructuring assignment. Destructuring assignment is a way to extract the values held within objects and arrays and store them in variables using a literal syntax. It actually sounds much worse than it is. It's slightly complex, but it's not as complex as it sounds. The assignment expression that we use to extract data from an array or object is known as an object pattern and matches data inside of the item being destructured. It still sounds quite scary, but it's not, believe me. Let's take a look at a basic example. So let's see the output first, and then we'll come back and talk over the code. So in this case, we create two variables, x and y. Those variables are wrapped in an array-like syntax. So the left part of the assignment expression, the result, actually looks like an array, even though it isn't an array. The right side of the assignment is the array itself, and that array has two values, the string A and the string B. So when we create the variables x and y, the first variable x gets the value A, and the second variable y gets the value B. And that happens because of how the variables in the left-hand part of the expression are declared. So x is declared first, so that takes the first value from the array. Y is declared second, so that takes the second value from the array. The array on the right-hand side of the expression is the array that's being destructured. So this syntax is much more concise than if we were to declare the x and y variables separately. Destructuring assignment also works with objects. So let's talk through what happens. The left-hand part of the assignment looks like the object that is being destructured. So it has the same curly brackets around it as if it were an object literal. It's not an object literal. We use the curly brackets because we're destructuring an object literal. The object literal is the right-hand part of the assignment expression. So this time we create two variables called a and b. When we're destructuring an object, like we are in this example, the variable names must match keys within the object that is being destructured. So variable a gets the value of the a property, and variable b gets the value of the b property from the object being destructured. So we don't have to destructure all of the values from the item being destructured. In this case, if we only wanted to get the b key, and we didn't care about the a key, we could do this instead. And that still works. It just completely ignores the property A inside the object being destructured. And that also works with arrays, by the way, as well, but it works in a slightly different way. Let's just go back and see how that works with arrays. So this time, if we try to do that, so we still get the first item from the array, and that's because we only specified one value in the left-hand side. So if we weren't interested in the first item in the array and we just wanted to get the second, we would have to do this. So all we're doing is not declaring a variable for the first item in the array. We still use a comma and then the name of the second variable to get the second item in the array. What these examples tell us so far is that destructuring is fail-soft. That means it won't throw errors when values don't exist. It just might not return the values that we were expecting, as we saw with the array example. One interesting aspect of destructuring is that we can use it to return multiple values from functions. Returning an array from a function is still really just returning a single object. It's just a single object that contains multiple values. With destructuring, however, we can return multiple arrays from a function. So from the function's perspective, we're still returning a single array. It's just a multi-dimensional array which contains other arrays. Destructuring is all about the assignment, however. So even though the function is returning one array, when we destructure it, we can destructure it as if it was returning two. So we can see that we've managed to extract the two individual arrays from within the multi-dimensional array returned by the function. So it's kind of cheating a bit. It's not actually a function that returns multiple values because that would be a generator function. It is just a regular function, but it is as if the function was returning multiple values. So it's still kind of cool. We can also use destructuring with complex nested structures of arrays and objects. And this is where destructuring assignment does get a little bit scary. So that expression is a bit longer than previous expressions, and because we have a object on the right hand side which itself contains objects, the left hand side of the assignment looks a little crazier than some of the previous examples. But let's just see the output in a browser, and we can see that the output is what we probably were expecting. Because we wanted to get the employment.status value, we still need to provide a variable for employment, even though we don't actually use that in the log statement. So we still need to specify employment to actually get the object within the employment property. And then we go ahead and get the status of that nested object. And that status then becomes a variable. So the more complex the object that we're trying to destructure is, the more complex the assignment in the left-hand part of the expression will be. And these can get very, very complex indeed if the object being destructured is very complex itself. So this feature is useful and it can save us time and effort, but it can get very, very complex very, very quickly. So just be careful when you're using it. So in this lesson, we looked at destructuring assignment, which is a concise way to access data held within arrays or objects. We learned that the assignment is done using the same literal syntax on the left-hand side of the expression that is used to define arrays and objects in the right-hand side of the expression. This makes destructuring powerful, but in some ways syntactically intuitive. Because we know how arrays and objects are structured, we know how destructuring assignment works. In the next lesson, we're going to look at AJAX. In this lesson, we're going to look at one of the cornerstones of modern interactive websites and rich applications, AJAX, or Asynchronous JavaScript and XML, to give it its full title. The premise behind AJAX is that we can use it to make a request to the server and process the response from the server without having to reload the page. The use of AJAX resolves around creating an XML HTTP request object. We aren't going to be using XML in this lesson, don't worry. Historically, when AJAX was first created back in 2005, JSON hadn't really taken off on the web, and XML was the primary data exchange mechanism. Thankfully, JSON came out soon afterwards, and it's been a very long time since we've had to worry about XML at all, and that can only be a good thing. But that's why the XHR object, the full title of that object is XML HTTP request, because of this historical use of XML. So when we make an AJAX request, we create an XHR object, and then we manipulate this object in order to make the request. So first of all, let's create this new object. So in order to create an XHR object, we need to use the XML HTTP request constructor. And let's just log this object out to the console. And we can see that it has a number of properties. And it also has this upload method. We won't be using this method during this lesson, but as you can probably guess, we would use the upload method to actually do an AJAX upload. So that's a bit more advanced than what we're going to be looking at in this lesson. Just be aware that it exists. So we have a series of properties. A lot of these properties tell us the different states that an XHR object can be in. And we also have some event handlers, and we can attach functions to those event handlers. So to make an AJAX request, we need to use two methods. And if we switch over to the Network tab in Chrome here, so we can see the request here. The server has just sent back some data, and it sent back some data about the number 42. So in this case, we were looking in the browser's console in order to see the response from the server. We wouldn't normally do that. If we do want to handle the response from the server in some way, then we need to use one of the event handlers attached to the XHR object. So let's go back to the console now. and we can see that we've logged the message from the server to the console. And what happens when the server responds, it will update the XHR object on our side with the data that it's sending back. In this case, it's sending back text, and it adds that to the response text property. Normally, AJAX requests are limited to the same domain on which the code that makes the request originates. So responses from other domains aren't always accepted by the browser. So in this case, we're running on localhost. That's our own domain. That's the domain that we're making the AJAX request from. And the domain that we're sending the request to is Numbers API. And Numbers API is a completely different domain than localhost. The reason why this is working is because the Numbers API server sets something called a cause header to say that it will accept requests from any domain. And because it sets this cause header, our browser will then go ahead and give us access to the response from the server. If the server didn't set the cause header, cause, by the way, stands for cross-origin resource sharing. If the server didn't set that cause header, it would still respond to us, but our browser would not allow us to access that response, just in case it was harmful. So in this lesson, we looked at how to make an AJAX request and work with the response from the server. AJAX, as we saw, allows us to send and receive data to and from a server without having to reload the entire web page. This is useful because it allows us to update just part of a web page in response to a user action. As well as sending and receiving data, we can also upload and download files over AJAX. AJAX requests very often return promises, and that's what we're going to be looking at in the next lesson, native JavaScript promises. In this lesson, we're going to start looking at regular expressions. Regular expressions are a feature of many programming languages, so if you're coming to JavaScript from another language, you've probably at least heard of them, if not used them before. Regular expressions are extremely powerful and allow us to match patterns of characters within other strings. It sounds really simple, but just like destructuring assignment, regular expressions can get very, very complicated very, very quickly, depending on the pattern that we want to match. Like most of the different data types in JavaScript, we can either create regular expressions as literals or as objects using the regular expression constructor. And as usual, the literal syntax is generally preferred and is used most of the time. So first of all, let's create a regular expression. A literal regular expression is created by adding the pattern of characters that we want to match within forward slashes. In this case, we specify that we want to match the @ symbol. So we can now test strings to see if they contain this symbol. We can do that using the test method, which is one of several different methods that can be used with regular expressions. It's probably the most simple method, and we're going to be using it throughout most of this lesson. So let's take a look in the browser's output. In this case, we see true, because the string that we're testing, which is what we pass to the test method, does contain an @ sign. If we remove that, because the string that we're testing, this time we see false. This isn't the regular expression that you should use if you actually want to test for an email address, by the way. The actual email address regular expression is much more complicated than that. So in this case, the pattern that we wanted to search for is a simple literal character search. Regular expressions can match literal strings, such as in this example, but they can also use special characters and groupings of characters to match patterns in a much more flexible way. Let's say that we want to validate that a string contains only letters and no numbers. In this case, we could do something like this. So even this regular expression is exponentially more complex than the first regular expression that we looked at. Let's just look at what all of these different characters mean. So the hat character matches the start of the string. So we're saying here that we want to begin searching from the very beginning of the input string. The dollar character in a regular expression matches the end of the pattern. So in this case, we're saying that we want to stop searching at the end of the input string. The square brackets denote a group of characters. And in this case, the group of characters is any uppercase letter between A and Z, or any lowercase letter between A and Z. So let's put our pattern to the test. In this case, the test method returns true. And it returns true because the string that we are testing, an uppercase X, does contain uppercase or lowercase letters between A and Z. If we change this to a number, then the expression fails. At the moment, our regular expression pattern is only good for testing single characters. If we try to test a whole word, even if that word only contains upper and lowercase letters, the expression will still fail. As you can see, it has returned false. So what we need to do in order to get this string to match is to say that we want to match any number of uppercase or lowercase letters. We can do that using some more special characters. So now the test method returns true, because our test string contains one or more uppercase or lowercase letters between A and Z. So that's what the plus symbol signifies within a regular expression. It means one or more occurrences of the pattern. We can also test for 0 or more occurrences of the pattern, and we do that using a star character instead of a plus character. And we can test for 0 or 1 occurrence of the pattern using a question mark. So we're saying that our pattern should match any number of uppercase or lowercase letters. So what happens if we add a number into the middle of our string? In this case, the test failed, because the string is not comprised solely of uppercase or lowercase letters. If we do want to allow numbers in the string as well, we can add the character set that matches any number between 0 and 9. And now the expression passes. So we saw that the plus character means one or more, and we also learned that the star character means 0 or more, and the question mark means 0 or 1. So what if we want to match a specific number of occurrences? In this case, we can use curly brackets inside the regular expression, and curly brackets, just like square brackets, have meaning within a regular expression. So before we actually pass a test string into our regular expression, let's just go over the syntax of the expression. So we're using the hat and the dollar characters to mark the start and the end of the string. We understand that already. This time then, we're saying that the test string should consist of 3 numbers between 0 and 9, followed by a hyphen, followed by 6 numbers between 0 and 9, followed by another hyphen, followed lastly by 3 numbers between 0 and 9. So we're checking for a very specific format of a number. This could be a telephone number or some kind of order number or something like that. So in order to get the test method to return true, we need to pass it a string that matches this format. So this string is in the expected pattern and the test method should return true. And as you can see, it does. But if we deviate from that pattern at all, it then returns false. Backslashes within regular expressions also have special meaning. They can be used in a number of different ways depending on how they're used. So for example, in this number format example, instead of using hyphens as part of the string, we could use star characters instead. Now the star character also has special meaning in regular expressions, as we saw earlier. So in order to actually match a literal star character, we need to escape it. And that's one of the uses for a backslash in a regular expression, to escape another character that has special meaning. So now our regular expression should fail. This is because we're still using hyphens. So let's go back and update it to use the star character as a separator instead. And now the pattern matches once again. Backslashes are also used to create special codes which match different groups of characters. For example, the \d code matches any digit or number, and so is a much shorter way of specifying the numeric character set. So instead of using these square brackets with 0 to 9 in our number format expression, we can change that to use \d instead. And we find that the expression is still passing. So \d is a special code that means match any digit between 0 and 9. It's a shortcut for using 0-9 within square brackets. There are a lot of other / letter combinations, as well as some additional special character combinations for matching different things. So in this lesson we started looking at regular expressions. We saw that they are a flexible and powerful way of matching different characters within strings. We saw that the / is the delimiter that specifies the start and end of a regular expression literal. We then moved on to look at some special characters. We saw that the hat and the dollar have special meaning, and they mean the start and the end of a string respectively. We saw that the plus character means one or more occurrences of a particular pattern. We saw that the star means 0 or more occurrences of a particular pattern. And we saw that the / has several different meanings depending on how it's used. We saw that it can be used as either an escape character to escape other characters that have special meaning, like the star character. And we also saw that the / can be used in conjunction with other characters to specify a special group of characters, like \d, which means any digit between 0 and 9. We also looked at how square brackets are used to create character sets, and how curly brackets are used to specify an exact number of occurrences. In the next lesson then, as I mentioned, we're going to continue looking at regular expressions. In this lesson we're going to continue looking at regular expressions, as there are still a lot of things that we haven't covered yet. So one simple special character that we didn't cover in the last lesson was the pipe character, and that allows us to specify an OR condition within a regular expression. One use for this is to verify whether a string starts with either HTTP or HTTPS. So the test method in this case should return true because the test string does begin with HTTP. And if we were to change that to HTTPS instead, it still passes. Whereas if we remove it completely, we can see that it now fails. So the regular expression is not as concise as it could be. We've duplicated the H, T, T and P characters, when really the only differentiator between HTTP and HTTPS is the S character. So let's improve the regular expression slightly. So in this case we've updated the pattern to include a group. The group in this case is the character S, and we're using the question mark to say that the S may or may not occur. So this is much more concise than the previous regular expression, but it essentially means the same thing. We find that it's still passing. I just want to point out as well that just like the email address validation from the last lesson, this pattern that we're using now is nowhere near complex enough to be able to successfully test for proper URLs. We're just checking the first few letters of the URL. As well as breaking up patterns to match in a regular expression, parentheses also remember the characters that are matched and can be used later by some methods, like the replace method of a string, for example. This can be really useful if we want to change the string that we're testing in some way. So let's say that we wanted to take a camel-cased string and insert an underscore character before each capital letter. So let's view the output in a browser first, and then we'll come back and just talk about this syntax. So it has kind of worked. It's found the first uppercase letter in the test string, which was an uppercase C, and it has replaced that uppercase C with an uppercase C preceded by an underscore character. Now it hasn't done the second uppercase letter, the S, and we'll talk about why in just a moment. Let's just go back to the example and take a look at the syntax. So this works in a slightly different way than some of the examples that we've looked at previously. This time, instead of storing the pattern in a variable, we have stored the string that we want to test in a variable instead. The reason why we've done that is because the replace method is called on strings and not on regular expressions. However, the replace method can accept a regular expression as the first argument, and that's where we actually provide the regular expression. So we still use the / at the start and the end of the regular expression. This time we create a group using the parentheses. Inside that group, we specify a character set of any letter between A and Z, which is uppercase. In the second argument to replace, we have specified an underscore character as the literal character that we'd like to insert into the string whenever an uppercase letter is found. But we've also used this special $1 token. That is only available with regular expressions, and that means the value remembered by any parentheses within the regular expression. So when it matched the capital C for the word cased, the capital C is available as $1. Now the reason why it only matched the first uppercase character, the C, is because by default, regular expressions will match as little as possible. If we want to make the regular expression match all uppercase letters within the test string, we can just make the regular expression global, and we do that by specifying the global flag. So the global flag is provided after the regular expression, but weirdly it is still part of the regular expression, even though it comes after the delimiter that marks the end of the regular expression. And now we find that both of the uppercase letters in the string have been replaced with an underscore and the uppercase letter. So parentheses will automatically remember whatever the group inside them matches. We might not always want that to happen, and if we don't want that to happen, we can use a question mark and a colon inside the parentheses. So we do that at the start of the group. And watch what happens now. The $1 has gone from being part of the regular expression to part of the literal replacement string. So because we've specified the group as a non-capturing group using the colon and question mark here, that has caused the $1 to stop working. So one final way that we can use parentheses in regular expressions is for lookaheads. Lookaheads can be either positive or negative and can match a pattern only if it is followed by or not followed by another pattern. So let's see what this outputs in the browser. It outputs false. So we've gone back to specifying the regular expression in the variable. This time we've used the script variable. We've used a different flag this time. As you can see, we've passed I after the regular expression, and that just turns the regular expression case insensitive. So by default, regular expressions are case sensitive. So if we're not worried about case, we can just pass the I flag after the regular expression. We've gone back to using the test method here, and we've passed the string Java. So even though Java does form the first part of our regular expression, it doesn't match because the question mark and the equal sign means match only if followed by. So we only want to match if the word is JavaScript and not if the word is just Java. So let's go back and add script now to the end of the test string. And we find that now the regular expression matches. So that is a positive look ahead. We will only match if the regular expression is followed by the look ahead string. If we want to negate that instead, so we only want to match if it doesn't follow the string, then we can change the equal sign to an exclamation mark. So now we find that JavaScript doesn't pass, and if we go back to just the string Java, it does pass. And that is a negative look ahead. So in this lesson we looked at some more aspects of regular expressions, including the special pipe character, which is used as an OR condition. We then focused on the different uses of parentheses within regular expressions, including capturing and non-capturing groups, and positive and negative look-aheads. In the next lesson, we're going to look at even more regular expression features. In this lesson, we are going to continue looking at regular expressions. In the last lesson, we learned about look-aheads, which are used to match a pattern only if it is followed by or not followed by another pattern. As well as look-aheads, we can also do look-behinds, which are the opposite of look-aheads. These only match a pattern if it is preceded by another pattern. Continuing with the examples from the last lesson, let's take a look. In the last lesson, we created a regular expression to match the word Java, but only if it was followed by the word script. This time, let's match the word script, but only if it was preceded by the word Java. The syntax for a look behind is the question mark followed by a left angle bracket followed by an equal sign. The pattern that should precede the target pattern is next on the inside of the brackets, and the pattern that we want to match follows outside of the brackets. That is a positive look behind. We can also do a negative look behind, where we want to match a pattern only if it is not preceded by another pattern. To do that, we just substitute the equal sign for an exclamation mark instead. This is also true because we passed the test method the string script, which isn't preceded by the word Java. We learned earlier that we can use certain special sequences of characters to match a range of different things, like using \w to match any word character or \d for any number. These are called escape sequences. JavaScript also supports using Unicode property escapes as well as regular character escapes. This makes it easy to identify things like emojis in strings, for example. The escape sequence we use is a / followed by a lowercase p and then a set of curly brackets enclosing the Unicode property name that we want to test. In this case, that property is emoji, but there are many others that we can use as well, like uppercase, lowercase, or alphabetic. You can see the full list of Unicode properties at unicode.org. In order to use the negative form of Unicode property escapes, we use an uppercase P instead of a lowercase one. So in this lesson we looked at a couple more regular expression features. We started off by looking at positive and negative look-behinds, which can match patterns only if they are or are not preceded by another pattern. We then moved on to look at Unicode property escapes and saw that we can use this to match particular types of Unicode character using Unicode properties, such as testing whether something is an emoji or is alphabetic. In the next lesson, we're going to look at classes in JavaScript. In this lesson, we're going to take a look at classes in JavaScript. As we've learned already, JavaScript's inheritance model is based on an object's prototype, and as such is known as prototypal inheritance. Classes are just a syntactic sugar laid on top of the prototypal inheritance model that just makes working with object-oriented JavaScript a bit easier and a bit nicer to write. So when we were creating our person constructor function earlier on in the course, what we were doing basically is creating a person class and using that constructor to create instances of that class. Classes just make it a bit easier and nicer to create these kinds of classes. Let's take a look. So classes are defined using the class keyword. So this is a class declaration, and it looks very similar to a function declaration, except there are no parentheses following the class name. One important point to note, however, is that while function declarations are hoisted to the top of their scope, class declarations are not hoisted, so an error will be thrown if a class is used before it gets declared, unlike a function. Another similarity with functions is that we can have class declarations or class expressions. And just like functions, class expressions can be unnamed or named. So the body of the class is added between the curly brackets. Setting the constructor for a class is done using the special constructor property. In this case, the constructor accepts a name, and this name is set as a property of any instance objects created using this class. We can also define methods that all instances of the class will inherit. So in this case, we've added a method called shoutName. So any employee objects that we create using this employee class will automatically inherit this shoutName method from the class's prototype. This all happens behind the scenes. We don't have to do anything like updating the prototype ourselves manually. JavaScript just takes care of it for us. So let's now use this class and create a new instance. And let's just take a look at the output in the browser. And we can see that the Bob object is shouting its name property. We can also add static methods which are available through the object type rather than through instances of the object. To do this, we just prefix the method name with the static keyword. So this static method can't be called on instances, but it can be called via the class itself. Okay, so you can still see that the string has been reversed. Subclassing is also very simple using another new keyword, the extends keyword. So we can extend the employee class with a new boss class. So let's go back and add a new method to the original employee class. And we'll just call this method work. Now, if we want to override this method in a class that extends the employee class, that's actually really easy. All we need to do is provide a method of the same name in the extending class and customize the behavior of the method however we want. And let's go ahead and create a new instance of our boss class. And now let's invoke the work method of each of our objects. And we can see that the overriding has worked in exactly the way that we would expect overriding a class method to work. Sometimes when we are extending a class, we might want to invoke a method on the base class from inside the extending class or the subclass. We have access to the base class from within a subclass via the super keyword. So let's say that when a boss works, they also shout their name. Now the boss class doesn't have its own shoutName method, but it can still invoke it from the base class. So this example is a little bit contrived, and it's just to show you how we can invoke the method of a base class from within a subclass. It's not something we actually need to do, it's just an example to show you how to do it and that it is possible. There we go. So if you do need to invoke a method of the base class from a subclass, it's very easy using the super keyword. So in this lesson we looked at a relatively new way of defining classes, which came to JavaScript as part of ES 2015. We saw that we can define classes using class declarations or class expressions, and that we do that using the class keyword. We learned how to create a constructor for the class with the special constructor property, and how to add either instance or static methods to the class. We also saw how to create a subclass which extends a base class using the extends keyword, and we saw how to call methods of the base class from the subclass using the super keyword. In the next lesson, we're going to look at one of the greatest features ever added to JavaScript, ES modules. In this lesson, we're going to take a quick look at timeouts and intervals. The methods we'll be using today aren't strictly part of the ECMAScript specification, but they are supported in all browsers and have been around for a long time. Let's make a start with timeouts. A timeout is a way to schedule some code to be executed at a specified later time. We can use a global function called setTimeout to do this. We should see in the console that we don't see the log message until 1 second after the page has loaded. The setTimeout function can be passed 2 arguments. The first is a function, an arrow function in this case, that will be executed when the timeout occurs. The second argument is the duration of the timeout in milliseconds. This is the delay before the function passed as the first argument will be invoked. One point to note is that the second argument should be thought of as somewhat vague. In this case, when we specify here that the code should not be executed until 1000 milliseconds have passed, our code is not guaranteed to run after exactly 1000 milliseconds, only that it will not be executed for at least 1000 milliseconds. It could be longer. Another point to note is that the second argument is optional. We don't have to specify any delay at all. In this case, the code will be executed on the next turn of the event loop. The setTimeout function does have a return value. The value it returns is an integer that represents a unique ID for the timeout. We can use this ID to cancel the timeout, which can be done with the clearTimeout function. This time we store the return value of the setTimeout function in the variable timeout ID. Next we check whether timeout ID is a number greater than 0, which it will be, and if so, we pass the timeout ID to the clearTimeout function. In this example, this will prevent us from seeing the console log at all. Now let's move on and look at intervals. You can think of an interval as a recurring timeout. This time we can specify that a function should be invoked every X number of milliseconds. We first define 2 variables, max and count. We then pass the setInterval function and arrow function. Inside this arrow function, we first check whether the count variable is greater than or equal to the max variable, and if it is, we return and do nothing. If the count is less than the max, we increment the count by 1 and then log the iteration number to the console. We can also pass a second argument to the function, and this is the delay in milliseconds before the callback function will be invoked. As with setTimeout, this argument is optional. In the browser's console then, we can see our log message slowly occur 5 times. One point to note here is that even though we are returning from our callback function after the 5th iteration of the callback function, the interval is still running in the background for as long as the browser tab is open. This is really bad practice. We should never leave an interval running like this. As with the setTimeout method, setInterval will return an ID which we can store and then later use to cancel the interval and stop it running. Let's update the code. This time we store the return value of calling the setInterval method in a variable called int. Then inside the now expanded if statement, we call the clearInterval function and pass it the int variable. This will cancel the interval and prevent it running indefinitely in the background. So in this lesson we learned all about timers and intervals. We saw that we can use the setTimeout method to schedule a function to be executed after some delay in milliseconds. We also saw that we can use the setInterval function to schedule a function to be executed on a recurring basis until the interval is cleared. In the next lesson, we're going to take a look at ES modules. In this lesson, we're going to look at using ES modules. So first of all then, let's create a new module. So as you can see, there is nothing special about module files. They aren't some crazy new type of file, they're just JavaScript files. What determines whether a script file is a module or just a regular script file is how that script file is loaded, not how it is defined. So in order to export a value from a module, we need to use the export keyword. So we can export many different things from within a module. We can export values like we have done here. We've exported a constant value called str, and that is a simple string. But we can also export classes if we want. And it's this class exporting that makes modules really, really powerful. We're not going to go that deeply into modules today. I just wanted to mention that is one of the great things about modern JavaScript is we can have a project which is super organized into lots of small modules that we can then put together in interesting ways. It makes our projects much, much more organized. And when you start doing it, it just makes JavaScript development awesome again. So we've exported this value from module A. So now we want to import module A, and we can do that into our index file. So in order to import a module into another file, we use the import keyword. Now we need to import something specifically, and in module A we exported the constant str. So that's what we're going to import. So we're importing something called str. That will be made available throughout the rest of this file now, as if we had defined str as a variable directly in this file. But we still need to tell the index file where we want to import this from. We do that using the from keyword. And we just need to specify the path now to the file that contains the module. One thing that you might notice is that we have wrapped the identifier that we are importing in curly brackets. This is very similar to destructuring assignment. We're creating this str variable within curly brackets, and it is now as if this str was just a variable that we defined within this file instead of within a completely different file. And for now, let's just log this out to the console. And in the browser's console there, we can see the message that we exported from module A. We haven't had to do anything special to the browser. System.js has taken care of it for us. All we've had to do is define our module and then import that module somewhere else into another file. So another type of export is called a default export. So let's go back and change the export in module A. So this time we're making the same string as before, a default export. So back in the file that we are importing, this str value doesn't actually point to anything anymore because module A doesn't export str anymore. So back in the browser, our log message is just undefined. But that doesn't matter because all we need to do is get rid of the curly brackets, and then whatever we specify becomes the export from the other module. And now everything is working again as before. So previously, when we had the curly brackets, we didn't get to decide what value the imported value could be accessed through. The module defined that. But now that we're using a default export in the other module, we do get to decide what we call the imported data. So in this case, we left it the same as it was previously, str, but we could call it anything we want. It really doesn't matter. And it continues to work exactly as it should. So that's really one of the benefits of default exports, is that the consumer gets to decide what that imported token is referred to as. We can also export multiple values from the same module. There aren't any restrictions. We aren't restricted to just exporting a single value. We can export 100 values if we want, but we can only have one default export from a module. You'll probably have noticed that I commented out the IFI and the useStrict directive in the index file. Now there's a very good reason for that. So the reason why we've commented out useStrict is that anytime we use modules, the code from within the module is always run in strict mode. Now, strictly speaking, if you'll excuse the pun, we shouldn't have commented out useStrict in our index file because our index file isn't actually a module. It's module A, which is the module, but we didn't have to add useStrict within module A because all modules are always run in strict mode all the time. There are never any exceptions. So when we're working with modular JavaScript applications, we don't need to worry about specifying that we want to use strict mode. It will just use strict mode all the time. The reason why we have commented out the iffy, and because index isn't actually a module, we probably shouldn't have commented out in this case, but I really wanted to make an impact here. Unlike with regular JavaScript files, values and variables that we declare inside a module will never become part of the global scope. So even though the code within module A is not wrapped in an iffy, we've used the var keyword here as well. We aren't using let or const or any special kind of scoping. We've just used the regular var keyword and we've declared a variable. So if this were a regular JavaScript file, that variable would now be global and we'd be able to access it from anywhere else at all. Let's go back to the index file and just try to access that. And we can see that it's undefined. Even though we've defined the variable as if it were a global in a non-module, because it's a module, it doesn't become a global variable. That is insane. It means that we can just lose all of this iffy boilerplate that we've added to all of our JavaScript files for years and years now. We can just forget about it completely. As long as we're using modules, we can't accidentally set global variables. That is incredible. So in this lesson, we took a quick look at ES modules. We saw that when working with modules, all we really need to learn is how to export values from modules and how to import them into other modules. We saw that we export values using the export and optionally the default keywords. And we saw that we can import values from modules using the import keyword. We saw that when importing regular exported values, we need to use curly brackets and match the names of the identifiers being exported. But when we're using default exports, we can just import them and give them any label that we want. We get to choose the identifier when we're importing a default export. So this now brings us to the end of section 7 of the course. In the next section, we're going to move on to look at working with the DOM. In this section, we're going to focus on using JavaScript to work specifically with HTML pages and the different elements they contain, starting with the different ways that we can select elements from the page in this lesson. Working with web pages programmatically is not a goal of the core ECMAScript specification that JavaScript is based on, but the W3C have also added a number of specifications for working with the DOM, or the Document Object Model, as it's officially known, which represents a web page. A web page is made up of individual nodes, which constitute the different elements that make up the page. These elements, or nodes, are organized in a tree structure, where some nodes are parents and some nodes are children or siblings of other nodes. Let's just add an element to our index page. We do have some elements on here already, but these are elements that we don't usually work with in JavaScript very often. So let's just add a heading. Okay, so our index.html page now contains a heading, and we've given this heading an ID of main heading, and the heading has some text. One of the fastest and easiest ways of selecting an element from the page is by using the getElementById method. So let's select the heading that we just added. And let's take a look at the output in the browser's console. And we can see that it has logged the heading node to the console. So the getElementById method is a method of the document object, and the document object represents the web page as a whole. Remember, the window object represents the browser. The document object represents the page loaded within the browser. So the getElementById method returns a reference to an element, but if there isn't an element with the specified ID on the page, the method returns null. So the getElementById method returns a single object. Elements on the page should always have unique IDs, so the getElementById method will always return a single element, or null if there aren't any matching elements. But it should always return a single element if there is an element matching the ID. So if we want to get a collection of elements instead of a single element, there are a couple of different methods that we could use. Let's just go back and add some different elements to the page now as well. So I've added a simple unordered list with 3 list items. Each of these list items has the class item. So if we want to get all of the elements that have a particular class name, we can use the getElementsByClassName method instead. And now we can see that we have a collection of the matching elements from the page. Now it looks very much like an array, but just like the arguments object within a function, it's only an array-like collection. It's actually a node collection, or an element collection. It's not a true array, so we can't call true array methods on it. Just something to be aware of. We can also get all of the elements of a certain type. So let's imagine that the list items didn't have a class name. We could still select them all by using the getElementsByTagName method instead. And we see another identical collection of list items. Some elements, like form elements for example, can have a name attribute. And we can also select all elements that have a particular name attribute using the getElementsByName method. This method works in the same way and returns the same type of object as the getElementsByClassName and getElementsByTagName methods. So in this lesson we looked at some of the different DOM methods we have for selecting elements or collections of elements from the page through the document interface. We looked at getElementById, which is by far the fastest way to select a single element, and we looked at the getElementsByClassName and getElementsByTagName methods, which can return lists of nodes or DOM elements. In the next lesson we'll move on to look at how we can manipulate elements once we have selected them from the page. In the last lesson we took a look at some of the different methods of the document object that we can use to select elements from the page. Once we've selected an element from the page, we'll generally want to do something with it. We could remove it from the page or change its text content maybe. In this lesson, let's look at some of the methods we have available for manipulating HTML elements once they've been selected from the page. Elements are represented by objects, which have different properties that we can inspect and different methods that we can invoke depending on the type of element that we've selected. Let's take a look at some of the properties that elements have. Elements may have an ID property. In the last lesson we added a heading. Now we used the document.getElementById method to select that heading, but let's ignore that for a second and just see how we can inspect that element's ID once we've selected it. We can just inspect the ID property, and if the element has an ID, this is where we'll find it. We can also change the element's ID if we wish. And if we look at it in the DOM Explorer, we should see that it has the new heading that we just specified. We can get or set the class attribute of an element in a similar way, but we need to use class name rather than just class, because in JavaScript class means a programmatic class rather than a class name. Now our heading doesn't have a class, so trying to inspect its class name property is useless. as well as a class name property which contains the entire class name, and if there are multiple class names which are separated by a space, the class name will just contain all of them as a single string. There is also the class list property, and that allows us a much richer way to work with the class names of an element. So first of all, let's add some classes to our heading. And we can see that our heading now has two classes. We've just added them, class 1 and class 2. So now let's look at the class list property. We can also use this to add new class names. We just need to add them one at a time. So we add new classes using the add method of the class list object. And we can see that the third class has now been added. If we want to remove a class, we use the remove method of the class list object. And we simply specify the name of the class that we'd like to remove. If we want to see whether an element has a particular class, we use the contains method. And we can see that it returns true. It does have that class. If we're unsure about what type of element we're working with, we can use the tag name property to find out. We can see that it's a H1, and one point to note is that element names are always uppercase when returned by the tag name property. We can also manipulate either the HTML or text content of an element, and there are several properties that we can use for this depending on the situation. If we want to replace the HTML content of an element and give it a new DOM structure with new child elements, we can use the inner HTML property. And we can see that our heading element has some new text, and if we inspect it in the Elements panel, we see that it contains the new span element. There is also an outer HTML property, which includes not just the content of the specified element, but the element itself. And now we can see that we've entirely replaced our H1 with a H2. These properties can be used to both get or set the content. And you should also note that these properties can be a security risk if the HTML being inserted is being received from an untrusted source. If we only want to change the text content of an element, we can use the text content property instead of inner HTML. There are many other properties available with HTML elements, which are used to work with an element's size or its position on the page, but let's move on now to look at some of the methods that we can use with elements. Working with an element's attributes can be useful and is a very common scenario. Most of the element methods that we'll use revolve around this. If we want to add a new attribute or update an existing attribute on the element, we can use the setAttribute method. So this method takes two arguments. The first is the attribute that we'd like to set, and the second is the value that we'd like to give it. In this case, we can see that our heading now has the content editable attribute, and that means we should be able to edit it. It certainly looks like we can. We may want to remove one of the attributes of an element. In this case, we use the remove attribute method. This method only takes a single argument, and that is the attribute that we'd like to remove. And now we can see that the heading no longer has the content editable attribute. So in this lesson we looked at some of the different properties and methods that we can use when we're working with HTML elements. We saw how we can get or set an element's ID or class names, and we saw that we can use either the class name property or the class list object to interact with and change an element's classes. We also saw that we can check the type of element that we're working with using the tag name property, and that we can use the inner HTML, outer HTML, or text content properties to change an element or an element's contents. Lastly, we looked at some different methods that we can use to get or set attributes. We looked at the set attribute method in order to add or update an attribute, and we looked at the remove attribute method that we should use to remove an attribute that we no longer want to be on the element. In the next lesson, we'll look at DOM Traversal. In this lesson, we're going to take a look at the different ways in which we can move around a web page programmatically, starting at one element and navigating through the tree-like DOM structure to other elements in the document. One property that elements have is the child nodes property, and we can use this to access all of the element's child elements. So this property contains a node list which contains all child nodes of all types. So let's select the list element from the index page. So we can select the list from the index page using the getElementsByTagName method, but as this method returns a node list, we need to just get the element itself from within that node list. And as there's only one list on the page, that will be the first item in the list, and that is item 0. So we pass 0 with square brackets, and that will give us back the first unordered list found on the page. So now let's inspect the length of the child nodes list that the UL element has. So we can see there are 3 items in the list, and we have requested the length of the child nodes property. We actually get back 7. Even though there are 3 list items, the line breaks in between each list item are also classed as child nodes, and so these are included within the child nodes collection. This can be very confusing. So instead of using child nodes, if we're only interested in working with the element children of another element, we can just use children instead of child nodes. This property is also a collection, but it only contains genuine elements. It doesn't include other nodes like whitespace or line breaks or comments. So now we see 3 as we were probably expecting the first time. If we want to get just the first or last child of an element, we can use the first child or last child properties. And as before, when we used the child nodes property, the first child and last child properties may or may not point to genuine elements. In this case, they're both text nodes. So once again, if we only want to consider actual HTML elements, we'll need to use first element child or last element child instead. And this time we actually get the list items. So these properties allow us to travel down the DOM tree from a parent to its children. If we want to access the parent of an element, we can use the parent node property instead. This gives us the body element in this case because the unordered list is a direct child of the body. Now notice this didn't give us any weird text or comment nodes or anything like that. Generally, only actual HTML elements can have children. So even though there is a parent element property, generally it's fine to use parent node. The last few properties that we have for DOM Traversal are the next sibling and previous sibling properties. And once again, because next sibling or previous sibling don't just work with HTML elements, they work with other types of node as well. In this case, we see those pesky text nodes once again. So as with the other methods, we can use next element sibling or previous element sibling if we're only interested in working with actual HTML elements. And this time we get the nodes that we were probably expecting. So in this lesson we looked at the different properties we have for traversing the DOM tree from one element to another. We saw that there are several different ways of moving down through the DOM tree and accessing the children of an element using either child nodes or children, and that we can get just the first or last child of an element using either first child or first element child and last element child. We covered moving upwards through the DOM with the parent node property and moving left or right through the DOM with the next sibling, previous sibling, next element sibling, and previous element sibling properties. In the next lesson, we're going to look at how we can add and remove elements from the page. In this lesson, we're going to focus on the different ways of adding or removing elements from the page. This is a very common task, but it's not always as straightforward as you might expect. The easiest way to add a new element to the page is with the append child method, which inserts a new element at the end of a parent element. So the new element becomes the parent element's last child. Let's first create a new element and then we can add it to the page. We can see that our new div element has been added right at the end of the body. If we want to insert an element at the start of another element so that the new element becomes the first child of the parent rather than the last child, we need to approach things in a slightly different way. So this time we need to use the insert before method instead of the append child method. This method takes two arguments. The first argument is the new element that we're inserting, and the second argument is a reference element that the new element should be inserted before. Now we don't have this reference element yet. Let's just select one from the page. And this time we can see that our new div has been inserted before the h1. Removing elements is a bit easier. We just use the remove child method, which works in the way that you probably expect that it would. And now the new div has been removed. So the remove child is called on the parent that we'd like to remove the child from, and if the child cannot be found, an error will be thrown. So we should usually check that the element exists before we try to remove it. We can use the contains method to see if the parent has a particular child. So let's just try to remove our new div element twice. And we see that there's an error. It failed to execute remove child because the child is not actually a child of the node. And that's because we've already removed it. So let's use the contains method now just to add some defensive checks around this second remove child instance. So we use the contains method to see whether a parent contains a child. And we need to tell the method which child we'd like to search for. So in this case, we're searching for the new div that we already removed on the previous line. When we go back to the browser now, we see that the error has disappeared because it hasn't tried to remove the child that was already removed because contains returned false. As well as removing an element, we can also replace it with another using the replace child method. And we can now see that the heading is no longer on the page, and if we inspect the elements, we can see that our new div has taken its place. So the replace child method works in a very similar way to the insert before method. We add the new element as the first argument and a reference element, which is the element that's going to be replaced, as the second argument. So in this lesson we looked at the different methods that nodes have for inserting or removing new content. With these methods we need to either have a reference to an existing element or to create a new element from scratch. We saw how to insert new elements as the last child of a parent element with the appendChild method, or how to insert them as the first child of a parent using insertBefore. We also saw how to remove elements completely with the removeChild method, how to detect whether an element has a particular child using the contains method, or how to swap elements with the replaceChild method. In the next lesson, we're going to see how we can create new elements and other types of nodes programmatically, including document fragments. In this lesson, we're going to look at how we can create new elements and other document-related things. We've seen how to select existing elements from the page, but what about if we want to create a brand new element from scratch? To do this, we need to use the createElement method. The createElement method is a method of the document object, and it takes a single argument, which is the tag name of the element that we want to create. Once the element has been created, it acts like a node that we have selected from the page, so we can edit any of its properties like ID or class name, or edit its contents. The element behaves exactly like a regular element, but until it gets added to the page, it only exists in memory. As well as creating elements, we can create other DOM-related things, such as attributes or comments. To create a comment, we use the createComment method. The createComment method also takes a single argument, but this time the argument is the text for the comment. To create an attribute, we can use the createAttribute method, but the setAttribute method of DOM nodes is generally preferred to using this createAttribute method, so we're not going to look at that today, but feel free to look it up if you're curious. Another type of thing that we can create is called a document fragment. This is very similar to a proper document, except that it contains a much smaller API and is seen as a very lightweight version of a document. To create a document fragment, we use the createDocumentFragment method. This method doesn't take any arguments at all. Let's just go back to the browser briefly. We haven't actually logged anything to the console yet in this lesson, but I just want to show you the difference between a document and a document fragment. So let's just look at a document object briefly. So we can see that the API for a document is huge, and there are many properties and methods that we can make use of, and a lot of data and information. A document fragment, however, as you can see from the size of the scroll bar here, has a much smaller and simpler API, and this makes it a much smaller, much more lightweight object. And this really is the point of document fragments. We can create one programmatically, add a bunch of new elements to it, and operate on those elements in any way that we need to, and all of this happens in memory, which is much faster compared to the real DOM. Once we're done working with the elements in the document fragment, we can then insert the fragment into the page, and these elements become part of the proper document. We can't append the document fragment directly to the main document, however. We need to add it to an element. So let's just go to our index.html page, and let's add a new element to the page here. So we've added a simple new div, and we've given it an ID of target. So now that we have a document fragment, let's just add the new div element that we created to it. And now let's insert that document fragment into the actual document. And let's go back to the browser now. And we can already see that the new element has been added to the page. Let's just inspect that. So we can see that it has been added as a direct child of the target div. The document fragment has been discarded completely. So in this lesson we saw how to create brand new elements as well as other types of nodes like comments or document fragments. We also looked at what a document fragment is and we saw that it can be used as a temporary in-memory container for elements that we have created before we're ready to insert them into the page. In the next lesson, we'll go on to look at an incredibly important aspect of the DOM events. In this lesson, we're going to see how we can make our pages nicely interactive by responding to events triggered by different elements on the page as users interact with them. Using DOM events is a cornerstone of modern web page development. In order to make use of events generated in the UI of our web applications, we need to add event handlers for different user actions, like clicks on particular elements. Traditionally, this was a bit of a cross-browser headache, because IE exposed different methods for attaching events than other browsers. Thankfully, these days, all modern browsers use the same API, so it's much easier than it used to be. So let's add an event handler to one of the elements on our test page. So we've now got a reference to the heading on the page. Let's add an event listener for click events. So we've added an event listener for click events using the add event listener method. This method takes 2 arguments. It can take more, but it's very commonly used with 2 arguments. The first argument is the name of the event that we want to listen for. In this case, it's click events. And the second argument is a handler function. In this case, it's an arrow function. Event handler functions are automatically passed an event object, and we can also log this out to the console as well so that we can take a look at it. So we should find now that when we click on the heading, we see a message in the console. So the event object was part of our log statement, and let's open that up. And we can see that it contains many different properties. And this is all useful information about either the event itself or the element that the event occurred on. For example, we can see the target property down here, and that points to the element that triggered the event, in this case the heading. The add event listener method can also accept a third argument, and that specifies whether the event should be handled in the bubbling or the capture phase. Generally, we don't need to worry about this, but it is useful to understand what happens when an event is triggered. So when the H1 element was actually clicked just then, the event travelled from the document down to the target element, which in this case was the H1. So this is known as the capturing phase. As soon as the event reaches the element that triggered the event, it enters the @target phase. The event then travels back up from the element that triggered the event all the way back up to the document. And that's the bubbling phase. So as I mentioned, generally we don't need to worry about these different phases, although we can make use of the fact that these phases occur in a technique known as event delegation. And that is where we attach event listeners to parent elements instead of individual elements, and we wait for the events to bubble up from the children elements up to the parent which contains the handler. So one example is that we might want to add listeners to the list items in a list. So we do have a list on the page. So instead of getting the heading, let's get the list instead. So we've added the click handler to the list, not the individual children, but we can still click on the individual child elements, and that will still trigger the event listener on the parent. And if we open up the event object, we can see that the target points to the list item that was clicked. So this can be a very useful technique. So when an element is clicked and triggers an event, even if a parent handles that event, the event will still continue to bubble all the way up to the document. So let's add another click handler to the document. So let's see what happens now. We see both of the log messages. So we see the log message added in the handler for clicks on the list item, for clicks on the list, but even once the list has handled that, the click event still travels all the way up to the document element and triggers the handler that we added there. Now we don't always want that to happen. Luckily there is a very easy way to stop the propagation of that event. So we've used the stop propagation method of the event object, and that will stop the event from traveling any further than this handler. So now if we click somewhere on the document, we'll see the generic click happened log message. But if we click on one of the child elements, we only see one event now, because the event gets stopped by the handler attached to the list, and it doesn't bubble up any further from that point. The event object has another useful method called prevent default. This is useful for when the element is an anchor. Usually when an anchor is clicked, the browser's default action is to follow the href of that anchor and to either navigate to a different part of the same document or a different document altogether. We can stop that default behavior using the prevent default method. So let's just create a quick anchor and append it to the page. So we've created a new anchor element, we've given it some text and set its href attribute, and we've appended it to the page. And we can see the link down at the bottom of the page here, and if we click on that, it takes us to Google as we would expect. So let's now stop that from happening. So let's go back to the page now. And this time when we click it, the document doesn't take us to google.com. If we want to remove an event listener, we can use the remove event listener method. However, for this to be effective, we need to know which handler function we are removing. And so we should use named function references instead of the arrow functions that we've been using so far. So it should still work in exactly the same way as it did before. But now if we want to remove that handler, we've got a function reference that we can use. And now we shouldn't see any more messages. But when I click the document, the handler has been removed. So in this lesson we looked at adding listeners or handlers for events triggered on the page by the actions of our users. We focused on mouse events because they're quick and easy to work with, but we can also make use of many other types of events, including keyboard events and scroll events. We saw how to add event listeners using the add event listener method, and we saw that we should provide a name for the event that we want to listen to as the first argument, and the function to invoke whenever the event occurs as the second argument. We saw that event handling functions are automatically passed an event object, which contains useful properties that give us information about the event, and methods that we can use to either stop the event from propagating up the document or to prevent the default behavior of the browser. Lastly, we saw how to remove event listeners with the remove event listener method, but that we need to specify exactly which listener we want to use, and so this only works with function references and not with anonymous arrow functions. This now brings us to the end of the DOM section. The next section is the final section of the course, and it focuses on using some common web APIs. In this section we're going to focus on some of the newer web APIs that are available for working with different features of today's modern browsers. starting with the Selector API in this lesson. The Selector API gives us the ability to use CSS selectors in order to select elements from the page. The Selector API is very simple. It consists of just two methods, querySelector and querySelectorAll. These methods can be called on documents, document fragments, or on individual elements, and they behave in very similar ways. The querySelector method returns the first element it finds that matches the selector passed to the method. So we can see that using an ID selector is very similar to using document.getElementById. But we are using a CSS selector, and we can pass any CSS selector to the querySelector method, no matter how complex. So instead of selecting the heading, let's select the first child of the list instead. And this time we've managed to select the first child using the CSS :first -child selector. So this is much more flexible than getElementById, which only allows us to select elements using their ID. So querySelector will only return the first element that it finds. So if we were to do something like this instead, we still only get a single list item. If we want to return multiple elements, we need to use querySelectorAll instead. And now we get a node list, much like we would get returned from one of the methods like getElementsByTagName. So in this lesson we looked at the Selector API, which is simple and intuitive to use. It works in exactly the way that we would expect and consists of just a couple of simple methods that accept limited arguments. This API is supported in all modern browsers. In the next lesson, we can look at geolocation. In this lesson, we're going to take a look at the Geolocation API, which can tell us where we are using various different means depending on the situation at hand. While incredibly useful for providing location-based services to mobile devices, desktop computers can also make use of them. Unlike anything else that we've looked at so far in this whole course, geolocation is strictly opt-in for our users. So as soon as we try to utilize their location data, they must accept a prompt that specifically allows us to access it. The Geolocation API is a globally available property of the Navigator object. We can inspect it within the browser by entering it in the console. So these are the different methods that are available through the Geolocation API. GetCurrentPosition is used to get the user's current position, and WatchPosition can be used to monitor the position as it changes while the user moves around. If we want to stop watching, then we use the clearWatch method. So the most fundamental method is getCurrentPosition, which we'll want to use to get the user's current location data. This method is asynchronous, so we need to pass it a callback function that will be invoked when the location is returned. So, because this is the first time we've tried to access the location, we see this prompt and we need to allow the browser to access our location. That's partly why the method is asynchronous, because we don't know how long it's going to take for the user to approve our request for access. And in fact, they may never approve that pop-up. It might just sit there at the top of the browser until the user closes the browser and goes off and does something else, in which case we'll never get the location details. When the pop-up is approved, however, we can see that we get this position object in the browser's console. So this has two properties, coordinates and timestamp. So the timestamp is the current timestamp, that's the Unix epoch time, and we also get this coordinates object. And this is what gives us the latitude and longitude, which tells us where the user is in the world. And we can see the accuracy and there might be altitude and altitude accuracy, and if the user is moving, there might be a speed as well. Obviously, I'm running this example on a desktop computer, and that isn't going anywhere, so I'm not going to see the speed there. But you can see some of the other properties that we get. As well as passing a success callback to the method, which is what we did in the first example there, we can also pass an error callback to handle situations where the location request failed. We can also pass a configuration object to specify certain configuration options, such as high accuracy or a timeout for the request. We can highlight both of these additional arguments with a simple example. So first let's add an error callback. Error callback will receive an error object which contains information about the failure, and we can also provide a configuration object as the third argument. So let's add that as well. So we see the position error which gets passed to the error callback, and we can see that it has a code and a message, and the message says timeout expired to indicate that the timeout elapsed. So another method that we can make use of is the watchPosition method. This is very similar to the getPosition method, except that it invokes the success or error handlers every time the position changes. This method returns a numerical ID, and when we want to stop watching the user's location, we pass this ID to the clearWatch method. Now we can't show you these methods in action because, as I said, I'm using a desktop computer and that's not moving. So the watchPosition handlers are never going to be invoked, but just be aware that they exist. So in this lesson we looked at the Geolocation API and saw how we can use it to get or track a visitor's location. We learned that the getCurrentPosition and watchPosition methods are both asynchronous, and so require that we pass callback functions to them, which will be invoked either when the location requests succeed or fail. We also saw that we can pass a configuration object to these methods, and that allows us to control things like the timeout for the request. We also had a quick look at the position object, which is passed when the request succeeds, and the error object, which will be passed to the error handler if the request fails. In the next lesson, we'll take a look at web storage. In this lesson, we're going to look at the web storage specification, which is comprised of a couple of different types of storage: session storage and local storage. Session storage is used to store key value pairs of data that persists while the window that stored the data stays open. Local storage is the same, except that the data persists between sessions and can be used to store data for as long as the user chooses to keep it. A storage object created for a particular domain is scoped to that domain and any subdomains. It can't be accessed from another domain's storage area. Both of these different storage areas make use of the storage interface and so share the same properties and methods, making them very easy to use. We can save much more data with the storage API than we ever could with cookies, and the interface is much easier and more pleasant to use. The session storage and local storage objects are both global, and so we can access them anywhere in our code. We can add a new item to either session or local storage using the setItem method. This method takes two parameters, which are the key for the item to be stored under, and the value. Both of these should be in string format. If we pass simple values to them like numbers or booleans, these will be converted to strings automatically. We can see that the message returns undefined. However, if we look in the Application tab, we can see the storage areas, and we can see that our test item has been set and it has the value true. If we refresh the page, we can see that the data is persisted. So the data will still be there if we navigate through different pages in our own website. It will only get lost when we actually close the browser window. If we want to save complex data structures to operate on as objects later on, there is an easy solution. We just need to serialize the object to a string in JSON format using the JSON API. And we can see that we now have the complex object in JSON format in our storage area. When we want to work with this object again, on another page perhaps, we can parse it back to an object from the string using the json.parse method. To get an item from within a storage area, we use the getItem method, which only takes a single parameter, and that's the key that the data is stored under. And if we go back to the console now, then we can see the JSON string that we'd like to work with, and obviously if we want to work with that as a proper JavaScript object, we can just call the json.parse method. If the key that we passed to the getItem method in order to get the data doesn't exist, the method will return null. If we want to see what the key is for an item at a particular index, we can use the key method. This method takes a simple integer as an argument which corresponds to the index of the key we want to retrieve. So we can see that at index 0, which we passed to the key method, the name of the key there is test item. So if we didn't know that that was the name of the key, we could use that to find out and then access the data stored within it. To remove an item from either session storage or local storage, we need to use the remove item method. And we can see that this method also returns undefined, but if we go back to the Application tab in the browser, we can see that the key has been removed. So in this lesson we looked at the simple storage API, which gives us session storage for persisting data across sessions, or local storage for storing data permanently or until the user chooses to delete it through the browser's interface. The examples in this lesson all revolved around session storage, but local storage is used in exactly the same way and shares the exact same API. So it's easy to mix and match different storage solutions for different situations. We saw how to add new items to storage using the setItem method or retrieve them again using the getItem method. We saw how to read key names of items in the storage object using the key method, and we learned that we can only store simple text strings. We learned that if we want to save complex object structures, we need to convert them to JSON first. Lastly, we saw how to remove single items with the remove items method. In the next lesson, we'll finish up this section with a quick look at web workers. In this lesson, we're going to take a look at web workers. Web workers are a way to execute code in a different thread than the main UI thread. The idea is that if we want to do some heavy processing, we can offload this to a different thread than the main UI thread to avoid blocking the user interface. When we create a new web worker, we specify the file that contains the code for the web worker. Before we create one, let's add a new file that can be used as the worker. We can call it worker.js. So back in the main script now, let's create a worker and point it to this new file. So we create a new worker using the worker constructor. The constructor takes an argument, and that is the path to the file that we want to use as the worker. In this case, it's worker.js. In order to communicate with the worker, we need to send it a message, and we do that using the post message interface. In this case, we send a simple string message that just says hello from the main script. Inside the worker then, we need to add a message handler that will be executed whenever the worker receives a message from the main script. Inside a file opened as a web worker, the onMessage property is globally available for us to assign a function to. This function will act as a handler and will be invoked whenever a message object is received. It will pass an event object to our handler, and we can access any data sent from the main script using the data property of this event object. We can also send messages back to the main script from the web worker. PostMessage is a globally available function inside files opened as workers. It works in the same way as the PostMessage function that we used in the main script does. And again, we can just pass back a simple string message. So back in the main script now, we can also add message handlers to the worker object in the main script. And we can access any data sent from the worker back to the main script in the same way. So we can see both of the log messages from the main script and the worker script. Once we've finished with the web worker, we need to terminate it. We can do that with the terminate method. The terminate method doesn't take any arguments, and it immediately terminates the worker script, so the worker will no longer be available to receive or send messages. This type of worker is a dedicated web worker. There are also shared workers, which can be used by multiple separate pages at the same time. We aren't going to look at these in this lesson. So in this lesson we looked at web workers, which are a way for us to spawn new threads that are separate from the main UI thread. We saw that we can send data between the main script and the worker using post-message and on-message event handlers. In the next and final practical section, we will move on to look at asynchronous JavaScript. In this lesson, we're going to look at native JavaScript promises. A promise represents an action that hasn't yet completed and allows us to add handlers for an eventual success or failure of an asynchronous action, like an HTTP request. Promises are useful for when we want to get a single one-off result that may happen at some point in the future. They aren't so useful for things that occur repeatedly, like clicks on a button, for example. A promise is an object created using the promise constructor. We need to pass a function to the constructor with callbacks to resolve or reject the promise. The function we pass to the constructor, which is known as an executor function, receives functions that can be used to resolve or reject the promise. We can then invoke the resolve or reject functions inside the executor function as appropriate, depending on what we're trying to do. Let's just keep things simple for this example and randomly resolve or reject the promise. We use a simple ternary condition here to check whether the result of math.random is less than 0.5. If it is, we resolve the promise, but if not, we reject it. We can pass whatever we want to the resolve or reject methods. In this case, we can just pass a simple string indicating success or failure. Now that we have our promise object in the myPromise variable, we can use the then method to add success and failure handlers to the promise and invoke the executor function. The then method takes two arguments, which are the success and failure handlers, although officially they're referred to as fulfillment and rejection handlers. Inside each of them, we can log a simple message, in this case. An object that has a then method is said to be thenable, which is a term that you'll likely come across when working with promises. The appropriate handler will be invoked at some point in the future when the promise resolves or rejects. These states of being either resolved or rejected are collectively known as settled. So when a promise has been settled, it has been either resolved or rejected. Before a promise has been settled, it is in a state known as pending. As soon as the promise settles, the appropriate handler, either the success or failure handlers, will be invoked immediately. So let's just take a look at what we've got so far in the browser's console. We can see that this time the promise was resolved. Let's refresh the page. And we can see that this time the promise was rejected. So just to recap then, the promise object may be in one of three different states. Pending is the first state, and then it may be either fulfilled, which is when the promise has been resolved, or rejected, which is when the promise has been rejected. And both the resolved or rejected statements together are known as settled. Remember that a promise can only be fulfilled or rejected once, so it can only be settled once. The then method itself also returns a promise, and that promise is resolved with either the original settled value of the first promise or the return value of whichever handler, either success or failure, returned. So the then method itself is chainable. So let's just go back and update our example. So in the success handler that we pass to the first then method, we return true after we log to the console. And in the failure handler that we pass to the first then method, we return false. In the second then method, which we've chained onto the end of the first one, we can just log this value depending on whether the success or failure handler of the second then method is called. So let's go back to the browser again. And we see true in the console because the first promise was fulfilled. And let's refresh it a few times. And we see that when the first promise gets rejected, the second promise is resolved with false. So the example that we've looked at so far, while illustrative, doesn't really show the true power of a promise in action. Before we finish up for this lesson, let's look at a much more realistic scenario where a promise really excels, an AJAX request. So let's use the Numbers API once again, but this time use a promise to handle working with the response. So let's comment out the first example first of all. And let's start by adding a function that can be used to make an AJAX request. So we've added a function called getNumberFact, and that accepts a URL. So the getNumberFact function returns a new promise. Inside the executor function then, we can create a new AJAX request. And let's now add an onload handler for the XML HTTP request object that we just created. And inside the onload handler, we can just check that the status of the request is 200, which would indicate a successful response. So when the response is successful, we want to resolve our promise. So we check the status of the request object, and if that is equal to 200, we can resolve our promise and pass it the response text, which should contain the response from the server. If the status is not 200, then we can reject our promise instead and pass it the status text, which should indicate why the request failed. So lastly, we can open and send our So this should be all we need to do inside our getNumberFact function. So now we can invoke this function, pass it the URL that we want to make the request to, and add a then method which handles the response or error. And let's now check the output in our browser. So we can see that it was successful and it gave us a random fact about a number, and that number happened to be 2,055,001. And that is apparently the number of people employed by Walmart in 2007, which is fascinating But let's get back to the code. So we saw a successful request there. What about if we give the numbers API a really big number? Let's try that. Let's see if they got a fact for that number. They do have a fact for it, but it looks like a generic fact which just says the number is a boring number. So let's try a really tiny number instead. Okay, so we saw that we can trigger an error by sending it a bad request. And in this case, we just see the text bad request logged out to the console. So in this lesson, we looked at native promises in JavaScript, which were only added in ES 2015. We saw that a promise is an object created with the promise constructor and which usually has a then method. We saw that we can create a promise and use an executor function to either resolve or reject the promise as appropriate. We learned that we can attach handlers for success or failure to the promise using the then method. In the next lesson, we're going to look at promise chaining. In this lesson, we're going to look at promise chaining, which is a useful way of handling a sequence of asynchronous actions while keeping our code nicely readable. In the last lesson, we finished up by creating a function that makes an AJAX request to the numbers API. Let's extend that example so that we make another request using the number returned by the numbers API. Starting with the code as we left it in the last lesson, the success handler logs the response from the numbers API to the console. Instead, let's take up to the first three numbers from the returned number fact, which always starts with a number, and pass this number to a different API. First of all, let's just update the name of the getNumberFact function so that it's a bit more generic. Let's change the name of the function to getAPIResponse. Great. Now before we actually look at promise chaining, let's just look at the alternative. It might be intuitive to make a new request actually inside the success handler of the first then, like this. This time we can get the number at the start of the number fact returned from the numbers API using the matchString method on the response. This returns an array, and the number will be the first item in that array. We can then trim that down to up to the first 3 digits of the number, just in case the numbers API returns a ridiculously big number, which it occasionally does. We then invoke the getAPIResponse method once more, this time passing a different URL, which in this case is a Game of Thrones character API. So this should work, and we should see the response from the second API in the browser's console. Let's just take a look. And we can see the character data there returned from the Game of Thrones character API. The problem with this code, unfortunately, is that the response handler for the second request is indented. The code is moving towards the right of the screen in the classic pyramid of doom. If we wanted to make even more additional requests, our code could end up starting halfway across the page, making it much less readable. Promise chaining can fix this for us. Instead of handling the response in the first success handler, we can just return the value that we want to make use of in the chained promise. Let's change the first success handler like this. This is a condensed version of the previous code, but note that instead of making the second request inside the success handler, we are just returning the number, which will still be up to the first 3 digits of the numbers API number. The then method itself returns a promise, so we can chain another then method after the first one, which will receive the success value from the first promise. The success handler for this then method will receive the number returned by the previous method, so we can use this to make the second request. As this is an arrow function, it will return the return value of the getAPIRequest function, which will be another promise. To handle the response from the second request, we can chain another then method after the second one. In the success handler for this then method, we should receive the Game of Thrones character data, which we can just log to the console. This should work in exactly the same way as the previous example, but notice that our code isn't moving to the right at all. It's all staying neat and readable. This is the benefit of promise chaining. Let's just check that everything's still working in the browser. And we can see the Game of Thrones character data there in the console as expected. We can also tidy this code up further. Notice how we're duplicating the error handler in each method of the chain? Well, instead of doing that, we can just chain a catch method onto the end of the chain. This will now catch any error in any of the previous chained then methods, so we can remove the separate error handlers from the previous methods, making our code even shorter. With nested then methods, this kind of error handling is not possible. So in this lesson we looked at promise chaining and saw that the then method itself returns a promise, allowing us to chain the then method multiple times in order to handle multiple requests without resorting to unsightly, excessive nesting. We also learned that this gives us improved error handling, allow us to catch an error in the chain using a single error handler with the catch method. In the next lesson, we're going to look at some additional useful methods we can use when working with promises. In this lesson, we're going to look at some additional promise methods that we can make use of. Earlier in this section, we used a simple promise which resolves or rejects based on the value of a random number. Let's go back to that example again. We learned that all promises have a then method that we can use to attach success and failure handlers to in order to either deal with the result of the promise or handle any errors. We pass two handlers to the then method, but only one of them will ever be invoked, depending on whether the request is successful or not. As well as this then method, we can also attach a method called finally. This method is passed a single function. This function is invoked once the promise either resolves successfully or is rejected. It doesn't matter which outcome happens. The function we pass to the finally method doesn't receive any parameters, so there isn't really any way to know from inside the finally function whether the promise succeeded or failed. Hence, this method is really just intended to be used for any cleanup that needs to happen after the request, regardless of whether it was successful or not. The promise constructor also has some methods that we can make use of, so we should look at some of these as well. We'll need some new promises for these examples. We've got three simple promises which each use a set timeout to resolve the promise, and each of the second two takes half a second longer than the previous one. One of the methods of the promise constructor that we can make use of is called all. We can use this method to execute some code once all of the promises have completed. The all method is passed an array of promises, so we feed in our three example promises and it then returns a promise, so we can use the then method to get the result of this new promise. When all of the promises passed to the all method are themselves resolved, the promise returned by the all method will also be resolved, and the values from all of the original promises will be passed to the function in the following then. As you can see in the console, the values from each of the resolved promises are passed in an array. One point to note, however, is that if any of the promises passed to the all method are rejected, the promise returned by the all method itself will also be rejected and will throw an error if we don't add a catch handler. Another method we can use is the any method. We also pass the any method an array of promises and use our three example promises again here. This time the function we pass to the then method will be invoked when any of the promises we pass to the any method are resolved. This time in the console we only see the first message from the first promise because that is the first promise to be resolved. In this example, if for some reason the first promise was rejected, the result of the second promise would instead be passed to the function we pass to the then method, because this is the next promise to resolve. So in this lesson we first looked at the finally method. This method is available on all promises, is similar to the then method, and we can use it to execute some code once a promise has either resolved or rejected. We then moved on to look at a couple of methods of the promise constructor. We first looked at the all method, and saw that we can use it to handle a series of promises. This method also returns a promise, so we can use a function passed to the then method to handle when all of the promises passed to the all method have resolved. We also looked at the any method, which is also passed a series of promises, but this time the function passed to the then method will be invoked as soon as one of the promises resolves. In the next lesson, we're going to take a look at the async keyword. In this lesson, we're going to take a look at the ES8 async function. Before we start looking at code, I'm just going to make some space in the editor here. I'm going to collapse this function, and I'm just going to comment out the promise chain from the last lesson. An async function is similar in many ways to a regular function, with just a few subtle differences. To create an async function, we just append the async keyword to the start of the function, like this. It's just like a regular function declaration in that it has an identifier, can accept arguments, and can return a value. In this case, it just returns the value that we pass to it. But one of the things that differentiate async functions from regular functions is that they always return a promise. In this case, we aren't specifically returning a promise, and we aren't really doing anything asynchronous inside the function, but it will still return a promise, which will resolve immediately with the value we explicitly returned from the function. So let's take a look in the browser now, and we should see in the console that the value we pass to the function is indeed written to the console. If the function does actually do something asynchronous, the promise it returns will be resolved when the promise settles in the normal way for a promise, or it will reject if an error occurs. So that's one important fact of async functions. They always return a promise. The other main feature of async functions is that they enable the use of the await operator. We'll look at this in more detail in the next lesson. The only thing to note at this point is that while the await operator does change how async functions work, it's not essential to use. Async functions that don't make use of await are perfectly fine, as we've seen here. In terms of support, all current mainstream browsers support it except for Internet Explorer. There are polyfills that can help if you need to support IE 11, but the one you should use is largely dependent on which frameworks or build tools that you're using. In the last lesson, we saw how to make use of promise chaining. This is a useful feature to know, which addresses an issue with callbacks, where the indentation slowly builds up inside large functions. However, this can still not be optimal in some situations. This is the reason why async functions were created, to simplify the structure of multiple asynchronous actions. So in this lesson we looked at async functions, which we learned are similar to regular functions, except for two main differences. The first difference is that async functions always return a promise. Even if an async function doesn't explicitly return a promise, it will wrap the return value in a promise and resolve it immediately. The second feature is that it enables the use of the await operator, which we'll learn more about in the next lesson. In this lesson, we're going to take a look at the ES8 await operator. The first thing we should know about the await operator is that it can only be used inside async functions. If we try to use it outside of an async function, it will generate a syntax error. The await operator really has only one purpose, and this is to pause the execution of a function while it waits for an asynchronous action to complete. Once the action is complete, execution of the function will then resume and continue until either the function returns or another await operator is encountered. This is really interesting behavior, and if it sounds familiar, it's because it's very similar to how generator functions and the yield keyword work. Using the await operator is just like combining promises with generator functions, and that's actually the reason why the await operator was created, to simplify combining generator functions with promises. Let's look at an example. In the last lesson we added an async function called makeRequest. This is the perfect place to use await, so let's update it. Let's have it call the API response and pass it the URL it receives as an argument. We can just add a console log here to mark when we add the await keyword, which we'll do shortly. So let's see how it behaves before we add the await keyword. We should also make sure we're passing a valid URL when we call this function. And to really appreciate how await works, let's just add another console log after we call the async function. Great. Now let's check the browser console. We should see the after await log statement first, then the after request log message, and last we should see the number fact. This is probably as you expected it to be, right? As the program is executed, it calls the makeRequest function and goes into the makeRequest function. It then creates the getAPIResponse promise, logs the first message, then returns. At that point, it moves on to the second console log. So let's add the await keyword and see what happens. And let's go back to the console. So the await operator changes everything about how the code executes. This time we see that the after request message comes first, then the after await message. Let's walk through how the code executes. This time, when the makeRequest function is called, execution moves into the makeRequest function, but as it creates the getAPIRequest promise, it encounters the await operator. So after invoking the getAPIResponse function, it immediately pauses and execution moves back to the main context. It then logs the first console message, which is after request. Then, when the getAPIResponse promise resolves, execution transfers back into the makeRequest function where it was paused, and resumes, logging the second message to the console. You can see that the await keyword has a profound effect on how our code executes. So in this lesson we looked at the await operator and learned that this is a special operator that we can only use inside async functions. We saw that the await operator causes an async function to pause while it waits for the result of an asynchronous task. In the next lesson, we will look at some additional async and await techniques. In this lesson, we're going to take a look at async and await in a little more detail, focusing on using await multiple times inside an async function. Earlier in this chapter, we saw promise chaining in action. While this is an improvement over nested callback functions and the pyramid of doom, await can improve our code even further. Let's say that we want to do the same as before. Use the number returned by the Numbers API as the basis for a request to the Game of Thrones Character API. We use the await operator on the first call to getAPIResponse as we did in the last lesson. When the promise resolves, we can then get the number from the start of the fact and then invoke the getAPIResponse function again for the second request, and we can await this one too. At the end, we can return the second promise object. As you can see, this is much more concise and readable than having multiple then methods chained together. The code is asynchronous, but it reads and behaves as if it were synchronous, which simplifies the code enormously. Let's compare this to the original then-based code that we used earlier. At the moment, this code is quite expanded, and we could save some space by refactoring it slightly and tidying it up. So this is a bit tidier, and it takes up a few less lines. But still, with async await, we have just a single function. With the original code, we have effectively 4 callback functions. And let's just go back to the browser and check that everything is working as we expect it to. And we can see the returned Game of Thrones character data logged to the console as we expect. One thing we haven't looked at yet is error handling. With async and await, it's recommended to use try-catch around the await statements. We can wrap the whole contents of the function in the try part. In the catch part, we should make sure to throw any error that is caught, otherwise the error will not be passed back to the caller properly. We can then add a catch method to where the makeRequest function is called. So now if we mess up one of the URLs, we should see that an error is thrown. Let's go back to the browser console, and we can see that the error has indeed been thrown. We don't get much information because the getAPI response function only rejects the promise with the status text of the error. So in this lesson we looked at how to use the await operator multiple times inside an async function, which is really a convenience to avoid long promise chains. We also saw how to make sure that any errors in an async function are handled correctly using a regular try-catch statement. In the next lesson, we're going to take a look at asynchronous iteration with the for-await-of loop. In this lesson, we're going to look at asynchronous iteration using the for-await-of loop. Earlier in the course, we learned about iterables. We saw that the entries and values methods of a set object return iterables, and that an iterable is an object that has a next method. In the case of a set, it is a synchronous iterable, and the for-await-of loop does also support synchronous iterators as well as asynchronous iterators. Let's take a quick look. Previously we used a simple set. Let's use that again. We create a new set consisting of 3 simple string values. The values method of the set returns a synchronous iterable, so we can iterate over the values using the for-await-of loop. We can only use for-await-of inside an async function, hence we have to wrap our code in an async immediately invoked function. We use the for keyword followed by the await keyword and then a pair of parentheses. Inside the parentheses we declare a variable, value in this case, and then use the of keyword followed by the iterable, which in this case is the setItems variable, which contains the iterable from our set. Inside the curly brackets we can then handle the iterable values. In this case we just log a simple message to the console. In the browser's console we should see the 3 log messages as expected. The main feature of for-await-of though is async iterables. For the next example we'll need to create one. We create an object in the variable async iterable. We then add a key to this object using the async iterator symbol, which is one of JavaScript's built-in symbols. This property of the object will be a function which will return an iterable object. For an object to be considered iterable, it should have a next method, hence we have added one to the returned object. Inside this next method, we can do something asynchronous, although we'll keep it simple for this example. Let's keep using the set from before, but let's have the iterable return its values instead of using its values method. First we'll need to add an additional counter variable. Now inside the next method of our iterable object we can return a value from the set as a resolved promise. We can increment the counter after checking whether the current value is less than the size of the set. If it is, we return an object containing a value and a done property as an iterable should. We can hardcode the value false here because if this code executes, we know we haven't reached the end of the set yet. We can get the value by calling the next method of the set iterable. If the count is not less than the size of the set, we can return the final object, which does have a done value of true. Now we're ready to use our iterable with for-await-of. It's almost identical to the first example, we're just using a different iterable basically. In the console, we should see the 3 values from the set. We don't see the empty object which has true for done. The for-await-of loop uses this to stop iterating the iterable. So in this lesson we learned about the for await of loop, which allows us to iterate over either synchronous or asynchronous iterators, and saw a basic example of both. We also learned how to use the symbol.async iterator value to create a custom iterator. In the next lesson we're going to take a look at dynamic imports. Earlier in the course we looked at ES modules and saw how we can load JavaScript files as modules. Modules loaded in the standard way with the export keyword are loaded statically, as in they will always be loaded and evaluated at runtime. Dynamic imports allow us to load modules conditionally or on demand rather than statically. This allows us to do powerful things like lazy loading modules. We can load only the bare minimum of code needed for the landing page and then load other modules depending on where in our app the user navigates. Let's create a new module to use in this lesson. We can create a new file called module B in the root of the project. Inside we can just export a default value. Now in our index.js file we can use the import keyword as a function. I've wrapped it in a little timeout with a 1-second delay, just so we can be sure it is being loaded dynamically. We pass the URL of the module we want to load to the import method as a string. When used as a method, import always returns a promise, so we can attach the then method and pass a success handler. This handler will be passed the module when it is loaded, so inside the handler we can access any defined properties of the module. In this case the module only exports a default value which we can access via the default property. The import keyword also has a property that we can access, the meta property, which provides meta information about a module. We can use this inside a module, but not outside of one. Let's add a quick console log to the module b.js file. We should see an object log to the console with just a single property, the URL property, which provides the URL the module was loaded from. So in this lesson we learned that we can use the import keyword as a method in order to load modules dynamically when requested rather than statically at runtime. This brings us to the end of this section. Next we'll move on to the conclusion of the course. We've reached the end of the course now, and I hope that I've helped you get up to speed with the world's most popular programming language. Throughout the course I've tried to focus on the core JavaScript features that you'll need to know to work with the language on a day-to-day basis, as well as some of the interesting capabilities added in order to work with it specifically in browsers, such as DOM manipulation, DOM events, geolocation, and web storage. Of course, there is still a lot more to learn, so treat this course as a firm foundation on which to continue building your knowledge. My name is Dan Wellman. If you have any questions or comments, you can get hold of me on Twitter. My name is @Dan Wellman. From all of us here at Tuts Plus, thanks for watching.